The Big Bang did not bang. There was no sound, no light, no explosion as we understand it. The most significant moment in cosmic history, the very birth of reality itself, happened in absolute silence. You've been told a story your entire life. A convenient metaphor wrapped in the comforting imagery of an explosion. A beginning you could visualize. But what if everything you thought you knew about our universe's origin story was merely a simplified fairy tale? The truth, as we'll discover together, is far stranger and far more beautiful. Imagine for a moment that you could stand outside of time itself. You a witness to the birth of everything that ever was or will be. What would you see in that first second? Not an explosion outward from a single point, but something profoundly more. Alien, space itself, stretching, expanding like the surface of an inflating balloon, with no center and no edge. The universe didn't explode into empty space. It created space as it expanded. There was no outside for it to explode into. There was no before. The very concepts of space and time as we understand them came into existence in that silent, luminous moment. If you could somehow survive this unimaginable instance, this fraction of the first second, your senses would be overwhelmed by a blinding, searing brilliance, a cosmos filled with pure energy so dense, so incomprehensibly hot, that not even atoms could form. No stars, no planets, no emptiness of space as we know it, just pure, raw potential, a universe of energy waiting to cool enough to manifest as matter. The temperature? 10 trillion degrees. Numbers beyond human comprehension, beyond human experience. This is not merely hot. It is a fundamental state of reality we cannot truly visualize, can barely calculate, and will never experience. You are witnessing the ultimate alchemy, the moment when nothingness transformed into everything. But what exactly is nothing? And how does everything emerge from it? These aren't merely poetic questions. They represent the boundary where physics meets philosophy, where mathematics encounters mystery. The universe's first second forces us to confront the limits of human understanding, to acknowledge that our intuitions about reality break down at its most fundamental level. Think about this. Every atom in your body, every particle that makes up everything you've ever touched, seen, or experienced, was forged in conditions so extreme they defy imagination. You are, quite literally, made of this first moment. Your existence an echo of that silent beginning. Your body a living museum of particles that have existed since time itself began. When you look in a mirror, you're looking at matter that was present during the universe's birth. Not similar matter, not matter like it. The same fundamental particles having journeyed across 13.8 billion years to form your reflection. But wait, if there was no bang, what actually happened? Picture the fabric of reality itself, compressed into a volume smaller than an atom. Not just all the galaxies, stars, and planets, but space itself, time itself, the very stage upon which cosmic drama unfolds. Then, in an instant beyond instance, this hyperdense point began to expand. Not like an explosion sending debris outward into pre-existing space, but like the emergence of reality from a quantum realm where our familiar laws of physics lose their meaning. There was no sound, because sound requires air. There was no light as we understand it. because light, as we perceive it, couldn't yet exist. There was only energy, pure and primal, following mathematical principles encoded into the very fabric of existence. For decades, scientists spoke of singularity, that initial point of infinite density from which everything emerged. But even this concept may be a simplification. The mathematics of general relativity breaks down as we approach this moment, unable to describe what happens when the entire universe occupies a dimensionless point. Our equations stutter and fail. Our models reach their limits. The language of modern physics begins to sound more like mysticism, boundary conditions, quantum fluctuations, vacuum energy, inflation. These aren't just technical terms. They're attempts to describe the indescribable, to place into human language events that may exist beyond the reach of language itself. You might wonder, if no human witnessed this moment, how can we possibly know what happened? We are cosmic detectives, working backward from the evidence all around us. The universe, it turns out, is filled with echoes of its own birth. Like forensic scientists at a crime scene, astrophysicists piece together the story of creation from the subtle clues left behind, the perfect 2.7 Kelvin temperature of cosmic background radiation, the oldest light in the universe, still visible with the right instruments, the precise ratio of hydrogen to helium throughout the cosmos, the large-scale structure of galaxy superclusters spreading outward like a cosmic web. These aren't random patterns, they're fingerprints left by processes set in motion during that first second. But there's something profoundly unsettling about our universe's beginning, something that challenges our deepest intuitions about how reality should work, the uniformity of it all. Look in any direction with powerful enough telescopes, and the universe looks remarkably the same. The cosmic microwave background radiation, that faint glow from the universe's infancy, has the same temperature everywhere, with variations of only about 1 part in 100,000. This shouldn't be possible. Regions of space on opposite sides of our observable universe could never have communicated with each other. Light itself hasn't had enough time to travel between them in the entire history of the cosmos. So how did they agree to have nearly identical properties? This apparent impossibility, the horizon problem, haunted physicists until the theory of cosmic inflation provided a possible answer, an exponential expansion in the first fraction of a second that stretched quantum-scale fluctuations into the largest structures in our universe. Imagine watching the entirety of cosmic history unfold before you, in a sliver of time so brief it can barely be expressed mathematically, 10 to 36 seconds after the beginning. The universe expanded faster than the speed of light, not moving through space, but creating space as it expanded. In this infinitesimal moment, quantum fluctuations, tiny variations in the density of energy, were stretched from subatomic scales to cosmic ones. These microscopic ripples in reality would eventually grow into the seeds of galaxies, the blueprint for everything that exists. The largest structures in today's universe, galaxy superclusters, spanning hundreds of millions of light-years, began as quantum jitters in the universe's first breath. There's something almost poetic about this connection between the very large and the very small. The same quantum principles that govern particles within atoms also shaped the largest patterns in the cosmos. The random dance of subatomic particles, magnified across billions of light-years, became the grand architecture of reality. Your existence, The fact that matter could condense into stars, planets, and eventually living beings was made possible by random quantum fluctuations in the universe's first instant. If those fluctuations had been slightly different, reality as we know it might never have emerged. But this raises a profound question. Was it all truly random? Or was there something inherent in the laws of physics that made our existence inevitable? This is where science reaches its current limits, where the empirical meets the philosophical. We can trace the story of cosmic evolution with remarkable precision. But we still don't know why the universe exists at all, or why it follows the specific physical laws that it does. The mathematics works with astonishing accuracy, but mathematics alone can't tell us why these equations, rather than others, govern reality. You exist in a universe exquisitely tuned for complexity. The fundamental constants of nature, the strength of gravity, the charge of an electron, the binding energy of atomic nuclei, all seem calibrated with impossible precision to allow for the emergence of stars, planets, and life. Change any of these values by even a tiny amount, and the cosmos becomes sterile. Sanatoir, universe of pure hydrogen, or one where atoms cannot form, or where stars burn out too quickly to forge the elements of life. This fine-tuning problem haunts the boundaries of cosmology and philosophy. Are we incredibly lucky? Is there a multiverse of different universes with different physical laws, and we simply find ourselves in one capable of supporting our existence? Or is there something deeper at work? Some principle we haven't yet discovered that explains why physics must be the way it is. Let's return to that first second, the moment when possibility became reality. As the initial expansion slowed, the universe began to cool. Energy condensed into matter through processes described by Einstein's famous equation, E, Chi2 Femq, the simplest elements, hydrogen and helium, formed as protons and neutrons, came together in the cooling cosmos. But something strange happened in this primordial soup. Matter slightly outnumbered antimatter. For every billion particles of antimatter, there were 1,000,000,001 particles of matter. When matter and antimatter meet, they annihilate each other in a flash of energy. So after this cosmic battle, only that tiny surplus of matter remained, one particle in a billion. And from this minuscule remainder, everything in our visible universe formed. All galaxies, all stars, all planets, and you. You are, in the most literal sense, the universe's afterthought, the trace remainder from an ancient annihilation. The reason why matter dominated over antimatter remains one of physics' great unsolved mysteries. Without this asymmetry, the IAB cosmos would contain nothing but radiation, no structure, no complexity, no life to contemplate its own existence. The fact that you're here to ponder these questions is itself evidence of a fundamental imbalance woven into the fabric of reality. As the universe's first minute unfolded, the foundations of cosmic chemistry were established. Protons and neutrons fused into the nuclei of light elements in a process called primordial nucleosynthesis. The abundance of these elements, 75% hydrogen, 25% helium, and traces of lithium, was determined entirely by conditions in the universe's first moments. This elemental fingerprint remains visible today, a direct link between our current reality and that ancient time. Every hydrogen atom in the oceans, Every helium atom in the atmosphere of a distant star was forged in the crucible of creation. But something was missing. While the lightest elements formed in the universe's first minutes, heavier elements, carbon, oxygen, iron, and all the rest, would have to wait billions of years. These elements, essential for life as we know it, could only be created in the nuclear furnaces of stars not yet born. The universe's first second set the stage. But the drama of cosmic evolution would unfold over eons. The story of how hydrogen and helium, products of the Big Bang, would transform into the complex chemistry of life is a saga of stellar birth, death, and rebirth that spans billions of years. There's something profound about the fact that the universe required time to become complex. The conditions immediately after the Big Bang were too extreme, too uniform for complexity to emerge. Only as the cosmos expanded and cooled could structure form. Could gravity begin to draw matter into the first stars and galaxies? Complexity isn't something the universe began with. It's something the universe grew into, something that emerged as natural processes unfolded across vast spans of time and space. Your existence depends not just on the precise conditions of the universe's birth, but on its patient evolution over billions of years. What if you could witness the moment when darkness first fell across the cosmos? For the first 380,000 years after the Big Bang, the universe was opaque, filled with a hot, dense plasma that scattered light like fog scatters a flashlight beam. As expansion continued and temperatures fell, electrons finally combined with nuclei to form the first neutral atoms. Suddenly, photons, particles of light, could travel freely through space. This moment, called recombination, transformed the universe from a glowing plasma to a transparent void. The light released in this moment still surrounds us today as the cosmic microwave background radiation, the oldest light in existence, now stretched and cooled by cosmic expansion until it glows faintly in the microwave portion of the spectrum. This transition from opaqueness to transparency marks the limit of our observational cosmos. We cannot directly see beyond this cosmic horizon, because light itself couldn't travel freely before this moment. Everything we know about the universe's first 380,000 years comes from theoretical models, mathematical extrapolations, and indirect evidence. Like ancient cave explorers limited by the reach of their torches, we can only see as far as light allows us to see. The earliest moments of creation remain hidden behind a wall of impenetrable plasma, accessible only through the language of mathematics and theoretical physics. But even in this theoretical realm, we find ourselves confronting the limits of understanding. As we rewind the cosmic film closer and closer to the beginning, our best theories begin to fail us. General relativity, our most comprehensive theory of gravity, cannot fully describe what happens when all of existence is compressed into a volume smaller than an atom. Here, quantum effects become crucial, and the marriage between quantum mechanics and general relativity remains one of physics' greatest unsolved problems. The quest for a theory of everything that unifies these frameworks has occupied the brightest minds in physics for generations. Yet a complete solution remains elusive. You live in a universe that has not yet fully revealed its own origin story. Scientists speak of the Planck epoch, the first 10⁻43 seconds after the beginning, as a quantum gravity regime where our current mathematics breaks down completely. We have reached the edge of the map, the boundary where "Here be dragons" is written across the cosmic chart. Beyond this frontier lies the ultimate mystery, the quantum nature of space-time itself, the fundamental character of reality, at its smallest scales. Some theories suggest that at this level, space and time themselves may not be fundamental, but emergent, arising from deeper mathematical structures we're only beginning to glimpse. Think about the profound unlikeness of your existence. For you to be here now, contemplating the birth of the cosmos, an unbroken chain of events had to unfold exactly as it did, from the precise pattern of quantum fluctuations in the universe's first moment to the formation of our solar system. 9 billion years later, to the entire evolutionary history of life on Earth. Change any variable, alter any constant, and the cosmos, as we know it, vanishes like morning mist. You are the product of a universe balanced on a knife edge of possibility, the result of cosmic parameters tuned with impossible precision. What does this precision mean? Some see in it evidence of design, a cosmic architect who calibrated the universe for complexity and life. Others point to the multiverse hypothesis, the idea that our universe is just one of many, perhaps infinite universes with different physical laws. In this vast ensemble, universes incapable of supporting complexity would exist, but contain no one to observe them. We find ourselves in a life-supporting universe not because it was designed for us, but because we could only exist in such a universe to begin with. This is the anthropic principle, the idea that our observations of the universe are constrained by the requirements of our existence as observers. Both of these perspectives, design and multiverse, require us to venture beyond strictly empirical science. They're not just scientific hypotheses, but approaches to the ultimate question: why does anything exist at all? Why is there something rather than nothing? These questions may seem philosophical rather than scientific, but they arise directly from our efforts to understand the universe's first moments. The boundary between science and philosophy becomes porous at the frontiers of cosmology, where empirical evidence reaches its limits and mathematical models venture into realms that may be fundamentally untestable. Now, let's consider something truly mind-bending. The total energy of the universe may be exactly zero. Positive energy in the form of matter and radiation is precisely balanced by negative energy in the form of gravitational attraction. The cosmos could be the ultimate free lunch, a perfect nothing that manifests as everything when viewed from within. This delicate balancing act suggests that the universe's existence may not violate conservation laws after all. From this perspective, creation ex nihilo, something from nothing, becomes not just possible, but perhaps inevitable. The question shifts from how could something emerge from nothing to why would nothingness be the stable state of reality? But what does nothing even mean in this context? Physicists and philosophers alike struggle with this concept. Is nothing the absence of things within space and time? Or is it the absence of space and time themselves? Is true nothingness even a coherent concept? Or does the very mathematical structure of reality preclude absolute void? Some theories suggest that what we call nothing, the vacuum of empty space, is actually a seething quantum foam of virtual particles popping in and out of existence, borrowing energy from the future, and paying it back before it can be detected. Perhaps true nothingness is physically impossible, a mathematical fiction that reality itself cannot accommodate. As you contemplate these questions, consider another startling possibility. The universe's first second may not have been its true beginning. Theories of cosmic inflation suggest that our observable universe, everything we can see even with our most powerful instruments, may be just a tiny bubble within a much larger, perhaps infinite inflationary space. What we call the Big Bang may have been simply the end of inflation in our local region, a transition from exponential expansion to the slower expansion we observe today. Our entire cosmic history, spanning 13.8 billion years, might be a footnote in a much grander, older, and stranger reality that continues to inflate beyond our cosmic horizon. Some cosmologists go even further, proposing cyclical models, where Big Bangs and Big Crunches alternate eternally, where universes give birth to other universes through black holes, or where parallel realities exist alongside our own in higher dimensions. These ideas remain speculative, at the frontier where mathematics runs ahead of empirical verification. They remind us that our understanding of cosmic origins remains provisional, a work in progress that each generation refines and expands. What would it mean if the universe had no absolute beginning? If reality is eternal, either through endless cycles or through infinite inflation, then creation itself becomes an ongoing process rather than a singular event. The question, what happened before the Big Bang, transforms from a logical paradox to a legitimate scientific inquiry. Time itself may be more complex, more alien than our linear experience suggests. The arrow of time that points inexorably from past to future, in our experience, may be a local phenomenon rather than a universal truth. These possibilities force us to confront the limits of human understanding. Our brains evolved to navigate the middle world of medium-sized objects moving at medium speeds, not to intuitively grasp quantum mechanics or cosmic inflation. We use mathematics as a guide where intuition fails us, following equations into realms we cannot visualize or directly experience. There's something both humbling and exhilarating about pushing against the boundaries of comprehension, about using the human mind to explore realities that may fundamentally transcend human perception. You might wonder, why should we care about the universe's first second? What relevance does cosmic inflation or quantum gravity have to our daily lives? Beyond intellectual curiosity, beyond the innate human drive to understand our origins, these questions connect to something profound about our place in the cosmos. The same physical laws that governed the universe's birth also govern its current state. The same principles that shaped the first atoms also shape your body's chemistry. You are not separate from these cosmic processes. You are their direct continuation, their current expression. The carbon in your cells, the oxygen you breathe, the iron in your blood, these elements connect you directly to the life cycles of ancient stars that lived and died before our solar system formed. But the hydrogen in your body, the most abundant element in both you and the universe, connects you to something even more primordial. It formed in the universe's first moments and has remained unchanged since then. When you drink water, you consume atoms that were present during cosmic dawn. Your physical existence bridges the entire history of the cosmos, from its first moments to the present day. This connection isn't merely poetic, it's literal. The conservation of energy and matter means that everything in the universe today transforms rather than disappears. The total energy present in that first second has neither increased nor decreased. It has only changed form. The light from distant galaxies, the wind in the trees, your own thoughts and feelings, all are expressions of that original cosmic endowment, manifestations of energy that has existed since the beginning of time. You don't just live in the universe. You are the universe, experiencing itself from within. Consider for a moment the profound silence of that first instant. No ears to hear, no air to carry sound waves, just the mathematical unfolding of fundamental forces. Now consider the sounds around you at this moment. Perhaps music, conversation, the hum of electronics, the rhythm of your own breathing. These sounds exist because the silent expansion of space-time eventually led to stars, planets, atmospheres, and living beings capable of producing and perceiving vibrations in air. The journey from cosmic silence to symphony represents the universe's evolution toward complexity, its transformation from simplicity to intricate relationship. The story of the universe's birth is also the story of information's emergence. In the universe's earliest moments, when everything was compressed into a hot, uniform plasma, complexity was impossible. As the cosmos expanded and cooled, differences could arise, variations in density, temperature, composition. These differences represent information in the physical sense, patterns that can be measured and distinguished from one another. From the perspective of information theory, the history of the universe is the history of increasing complexity, of simple initial conditions evolving into the rich tapestry of reality we observe today. Your consciousness, your ability to read these words and contemplate these ideas represents a pinnacle of this complexity. Through the human mind, the universe has developed the capacity to think about itself, to study its own origins, to wonder about its own meaning. This self-awareness isn't separate from cosmic evolution. It's a natural outgrowth of the same processes that began in the universe's first second. The emergence of consciousness may be as fundamental to cosmic evolution as the formation of galaxies or the synthesis of heavy elements in supernovae. But this raises a profound question. If consciousness is a natural outgrowth of cosmic evolution, could awareness in some form be fundamental to reality itself? Some interpretations of quantum mechanics suggest that observation plays a crucial role in collapsing quantum possibilities into definite outcomes. Others propose that information, rather than matter or energy, may be the bedrock of existence. These perspectives blur the line between mind and matter, between the observer and the observed. If consciousness isn't just an epiphenomenon of complex brains, but connects to something fundamental about reality's structure, then the universe's capacity for self-awareness may have been implicit from the very beginning. These speculations take us to the boundary where science meets philosophy, where empirical investigation meets existential wonder. The remarkable fact is that beings evolved within this universe who can ask such questions, who can use mathematics to reconstruct events billions of years in the past, who can contemplate not just what is, but what might have been and what might yet be. This capacity for abstract thought, for imagining possibilities beyond immediate experience, connects directly to the universe's inherent creativity, its tendency to generate new forms, new structures, new relationships over time. As we near the end of our exploration of the universe's first second, let's contemplate one final mystery: the nature of time itself. We experience time as flowing from past to future, but physics suggests a more complex picture. In Einstein's relativity, time is a dimension interwoven with space, forming a four-dimensional space-time fabric. The sharp distinction between past, present, and future may be more a feature of human perception than a fundamental aspect of reality. At the quantum level, time behaves even more strangely, with some interpretations suggesting that certain quantum phenomena are not temporally ordered in the way macroscopic events are. What does this mean for the concept of a beginning? If time itself emerged with the universe, then asking what happened before the Big Bang may be like asking what's north of the North Pole, a question that assumes a dimension of movement in a direction where no such dimension exists. Perhaps the universe's beginning wasn't a temporal event within some pre-existing framework, but the emergence of temporality itself, the birth not just of all things, but of the very possibility of sequence, causation, and change. This perspective transforms how we think about creation. Rather than imagining the universe's beginning as the first moment in an already existing timeline, we might conceive of it as the origin of time itself, the point where mathematics blossoms into physics, where potential crystallizes into actuality. From this viewpoint, the universe doesn't exist within time. Rather, time exists within the universe. The cosmos isn't just everything that exists, but the very framework that makes existence possible. As we reach the limits of our current understanding, we find ourselves not at the end of knowledge, but at the threshold of deeper questions. The universe's first second reveals itself not as a solved problem, but as a frontier of ongoing inquiry, a mystery that each generation of scientists approaches with new tools, new mathematics, new perspectives. Each answer generates new questions. Each discovery illuminates new unknowns. This is not a failure of science, but its greatest strength. The endless capacity for refined understanding, for approaching truth asymptotically through successive approximations. You exist in a universe still coming to know itself through beings, like you, conscious entities capable of wonder, of mathematics, of peering back toward beginnings and forward toward possibilities. Your presence here is neither accident nor inevitability, but something more subtle, the manifestation of potentials encoded in the cosmos from its first moments. The universe's capacity to evolve complexity, to generate systems capable of self-organization and eventually self-awareness, may be as fundamental as its physical laws. Perhaps consciousness itself, the light of awareness illuminating existence from within, was implicit in the mathematical structure of reality from the very beginning. The moot, questions we've explored about origins, evolution, complexity, and meaning aren't merely academic. They frame our understanding of existence itself, of our place within the cosmic story. The first second of the universe wasn't just the beginning of everything we can see and measure. It was the origin of possibility itself, the moment when mathematics became physics, when potential became actual. Every subsequent moment, including this one, as you contemplate these ideas, is a direct descendant of that primordial instant, a continuation of processes set in motion at the dawn of time. What will the next second bring? The universe continues its evolution, its expansion, its experimentation with form and relationship. Human knowledge continues to grow, to refine itself, to push against boundaries. Perhaps the greatest miracle is not that the universe exists, but that within it evolved beings capable of wondering why it exists, of tracing its history, of imagining its future. In that wonder, that questioning, that imagining, the universe achieves something remarkable. It comes to know itself through the consciousness of creatures born from its own substance, shaped by its own laws, yet somehow capable of standing, apart enough to ask why. And so we return to where we began. The Big Bang did not bang. The universe was born not in sound and fury, but in mathematical elegance, in the silent unfolding of potentials encoded in the fabric of existence itself. The true wonder isn't that it happened, but that it happened in just such a way that, billions of years later, beings would evolve capable of reconstructing this story, of peering back toward their own origins across vast gulfs of time and space. In that capacity for understanding, for connecting present to past through the language of mathematics and the evidence of observation, we find perhaps the universe's greatest achievement, the emergence of minds that can comprehend the conditions of their own possibility. For over a century, we've been taught that the universe begins with a timeline, a clean, linear progression from creation to now. A cosmic clock ticking forward, methodical and orderly, from the first moments to the birth of stars, planets, and eventually, us. But what if time itself wasn't what we thought? What if the cosmic clock didn't always tick at the same rate, or in the ways we've imagined? The universal timepiece we've constructed in our scientific models may be far more elastic, far more alien than the mechanical clockwork we've envisioned. In the standard model of cosmology, time moves forward like an arrow, from past to future, beginning with the Big Bang and extending toward infinity. A neat, ordered progression that our minds can comfortably grasp. But near the moment of creation, in conditions of extreme density and energy, time behaved differently. The early universe wasn't just hot. It was a furnace where time itself was still learning to move. In these primordial conditions, the familiar rhythm of seconds and minutes dissolves into quantum foam, where time and space become almost indistinguishable from one another, like water and steam in a pressure cooker. Imagine holding a clock at the edge of a black hole. As you lower it toward the event horizon, you'd see from a distance that it ticks more and more slowly, its hands barely moving as it approaches that boundary where escape velocity equals the speed of light. Now imagine the entire universe compressed into a volume smaller than an atom. The density would be so extreme that similar relativistic effects would come into play. Time wouldn't flow. It would crawl, stretch, and distort. The first second of the universe might have been subjectively much longer than a second as we experience it now, stretched like taffy by the incredible gravitational effects of all reality compressed into a point. This temporal distortion isn't just a theoretical curiosity. It fundamentally changes how we must understand cosmic evolution. The universe wasn't simply younger in the past. It existed in a state where the very concept of duration had different meaning. The cosmic clock didn't just read a different time, it ran at a different rate, governed by different rules. When cosmologists calculate what happened during the first moments after the Big Bang, they aren't merely rewinding a film at constant speed. They're accounting for a fundamental transformation in how time itself operates. Yet we speak of the universe's age with remarkable precision. 13.8 billion years, with an uncertainty of less than 1%. This confidence masks a deeper mystery. Time itself has a history. What we call time, the ordered progression of events, the ticking of the cosmic clock, emerged from something more fundamental, more alien. At the universe's birth, the distinction between time and space was blurred, like the boundary between ocean and shore at high tide. What we experience as 3 dimensions of space and 1 dimension of time is actually a single 4-dimensional fabric, space-time, whose properties evolved as the universe expanded and cooled. You might have heard of cosmic inflation, the theory that the universe underwent a period of exponential expansion during its first fraction of a second. But have you truly contemplated what this means? In less than the blink of an eye, less than a heartbeat, less than the time it takes for light to cross a single atom, the universe expanded by a factor of at least 10 to the 26. To put this in perspective, if inflation had started with something the size of a pea, it would have expanded to a volume many times larger than our currently observable universe in less time than it took you to read this sentence. This isn't merely rapid growth. It's growth at a rate that breaks our intuitive understanding of physical processes. Nothing in human experience, nothing in the entire subsequent history of the cosmos, has ever happened this quickly. The universe was quite literally torn apart, with regions of space that were once in contact with each other suddenly separated by distances so vast that light itself would take billions of years to bridge the gap. Inflation didn't just expand the universe, it shredded the causal fabric of space-time, isolating regions that once could interact into domains that would forever remain out of contact. And yet, the theory of inflation solves profound mysteries about our cosmos. It explains why the universe appears so uniform in all directions, why the cosmic microwave background radiation has nearly the same temperature everywhere, why space itself seems geometrically flat rather than curved. Inflation transformed. Quantum fluctuations, tiny ripples in the fabric of space-time at the subatomic scale, into the seeds of cosmic structure, the blueprint for everything from galaxy clusters to the precise spot where you're sitting right now. The largest structures in our cosmos and the smallest quantum jitters are connected through this explosive moment of creation. But here's where our cosmic narrative starts to unravel into something stranger. Inflation might never have fully ended. The theory suggests that while inflation stopped in our observable patch of the universe, allowing stars and galaxies to form, it continues eternally in other regions beyond our cosmic horizon. Like bubbles forming in a vast sea of expanding space, new universes may be constantly nucleating from the inflationary field, each with potentially different physical laws, different fundamental constants, different possibilities. Our entire observable universe, extending 46 billion light-years in all directions, may be just one bubble in an infinite, eternally inflating multiverse. If true, this transforms our understanding of the Big Bang. It wasn't the beginning of everything, but merely the beginning of our local cosmic domain. The true history of reality extends far beyond our observable limits, perhaps infinitely into the past. And if inflation continues eternally into the future in regions beyond our horizon, then the totality of existence, the multiverse, has no end. Creation wasn't a singular event, but an ongoing process, producing new cosmic domains like an endless fountain of universes, each with its own unique characteristics, perhaps even its own unique laws of physics. Let's explore another familiar concept that dissolves under closer examination: the cosmic edge. When we imagine the universe, we often picture a vast but finite bubble expanding outward into what, exactly? As children, many of us asked, if the universe has an edge, what lies beyond it? And if it doesn't have an edge, how can it be contained? This seemingly simple question reveals a profound misunderstanding about the nature of cosmic geometry. The universe doesn't expand into anything. There is no outside for it to expand into. Space itself is expanding, carrying galaxies along with it like raisins in a rising loaf of bread. The galaxies aren't moving through pre-existing space. The space between them is stretching. This is why astronomers say the universe has no center and no edge. Every point appears to be at the center of expansion when viewed from that point. Imagine dots drawn on the surface of a balloon. As the balloon inflates, all dots move away from each other, but no dot is at the center of this expansion. The center exists in a dimension, the interior of the balloon, that the dots can't directly perceive. If the universe has no edge, then where does it begin? This question assumes that beginning means boundary in space, but cosmic origins are about boundaries in time, not space. The Big Bang happened everywhere at once, at every point in space, as we know it. There wasn't a central explosion that matter expanded outward from. Rather, all of space was once compressed into an incredibly hot, dense state, and has been expanding ever since. The beginning of the universe isn't a location you could visit. It's a moment in time that affected all locations simultaneously. But even this picture, the universe beginning everywhere at once, may be incomplete. Some theoretical models suggest that the Big Bang wasn't truly the beginning, but a transitional phase from an earlier state. Perhaps our universe bounced from a previous cosmic contraction, or nucleated as a quantum fluctuation within a parent universe, or emerged when brains, vast sheets of reality in higher dimensions, collided with one another. These scenarios transform our understanding of cosmic origins from a creation ex nihilo into a transformation of pre-existing states. The beginning becomes not an absolute starting point, but a horizon of knowledge, a boundary beyond which our current physics cannot yet peer. What's striking about these alternative origin stories is that they aren't just philosophical speculations. They emerge naturally from efforts to reconcile quantum mechanics with general relativity, to understand how physics behaves under the extreme conditions of the early universe. The mathematics leads us inevitably toward scenarios where the Big Bang is not the ultimate beginning but merely the most recent phase transition in a much longer, perhaps eternal, cosmic history. Reality may be far older, far stranger, and far more extensive than even our most ambitious cosmological models have suggested. Consider the cosmic microwave background radiation, often described as the afterglow of the Big Bang, the oldest light in the universe. This isn't quite accurate. What we actually observe is light from the moment of last scattering, when the universe had cooled enough for electrons to combine with protons, forming neutral hydrogen atoms and allowing photons to travel freely through space for the first time. This happened about 380,000 years after the beginning, not in the universe's first second at all. The true afterglow of creation, the light from the universe's first moments, never reaches our telescopes. It was absorbed and rescattered countless times during the hot plasma era before recombination. So, we've never directly observed the universe's first second. Everything we know about this crucial moment comes from theoretical extrapolation, from working backward from what we can observe to what must have happened earlier. It's like trying to determine what a person looked like as a child based only on their adult appearance, combined with our understanding of human development. We can make educated inferences, but direct evidence remains elusive. The universe guards its earliest secrets behind a veil of plasma, accessible only through the language of theoretical physics and advanced mathematics. This limitation hasn't stopped us from constructing increasingly detailed models of the universe's first moments. Using particle accelerators like the Large Hadron Collider, scientists recreate conditions similar to those just microseconds after the Big Bang, studying how matter behaves at temperatures millions of times hotter than the center of the sun. These experiments allow us to test theories about the early universe, to see if our mathematical models match observable reality. The discovery of the Higgs boson in 2012, for instance, validated a crucial element of the standard model of particle physics, confirming our understanding of how elementary particles acquired mass in the cooling universe. But as we push closer to the beginning, from microseconds to nanoseconds to the Planck time, 10^43 seconds after the Big Bang, empirical evidence becomes scarcer, and theoretical challenges multiply. We reach energies so extreme that our current theories begin to break down, where quantum effects and gravitational forces both become significant, requiring a theory of quantum gravity that we don't yet possess. Like medieval maps that marked unexplored territories with "Here be dragons," our understanding of cosmic history becomes increasingly speculative as we approach time zero. What we do know is that the universe's fundamental forces, gravity, electromagnetism, and the strong and weak nuclear forces, weren't always distinct as they are today. In the extreme heat of the early universe, these forces were unified, indistinguishable from one another. As the cosmos expanded and cooled, they separated in a series of phase transitions, like water freezing into ice, but affecting the very fabric of reality itself. The first of these transitions, separating gravity from the other forces, may have occurred at the Planck time, marking the earliest moment our current physics can even attempt to describe. The elegant mathematics of these unification theories suggests a profound truth. The complexity we observe in today's universe emerged from primordial simplicity. The diverse forces and particles that make up the cosmos today were once aspects of a single unified field. Complexity isn't the universe's natural state. It's the result of cooling and expansion, of the primordial unity fragmenting into the diversity we now observe. Like ice crystals forming in freezing water, the rich structure of our cosmos precipitated from a state of perfect symmetry as the universe cooled below critical thresholds. This perspective transforms how we understand cosmic evolution. The history of the universe isn't a story of increasing order emerging from chaos, but of hidden symmetries breaking to reveal the intricate structure encoded within them. The universe didn't become more complex through the addition of new elements. It became more complex through the differentiation of what was already there, the manifestation of potentials that existed from the very beginning. The seeds of everything we see today, from subatomic particles to galactic superclusters, were present in the mathematical structure of the cosmos from its first instant. Let's pause for a moment to consider a profound implication. If the fundamental forces were unified in the universe's earliest moments, then the distinctions we now observe between them are, in some sense, illusions, artifacts of the universe's current temperature. If we could somehow heat the entire cosmos back to its primordial state, these forces would merge back into their unified form. The separate identities of these forces aren't absolute or eternal. They're contingent on cosmic conditions. What we call the laws of physics have a history. They evolved as the universe cooled, like water changing from steam to liquid to solid, as temperature decreases. This evolution of physical law challenges our deepest intuitions about reality. We tend to think of the laws of nature as immutable, eternal truths that govern the cosmos from outside. But what if they're more like emergent properties, patterns that precipitated as the universe expanded and cooled? What if the mathematical relationships we observe aren't imposed on reality, but emerge from it? Just as the crystalline structure of a snowflake emerges from the properties of water molecules under specific conditions, the universe may not be governed by laws so much as it manifests them through its own evolution. Consider, for instance, the concept of symmetry breaking in particle physics. In the intense heat of the early universe, various particle types were indistinguishable from one another. As the cosmos cooled, these unified fields broke into distinct particles with different properties. This process is analogous to a pencil, balanced perfectly on its point. While balanced, the pencil has rotational symmetry. No direction is preferred over any other. But this state is unstable. The slightest perturbation will cause the pencil to fall in some direction. Once fallen, the symmetry is broken. One direction has been chosen over all others. In the early universe, similar symmetry-breaking events determined fundamental aspects of physical reality. Why certain particles have the masses they do, why forces have particular strengths, why nature seems to favor matter over antimatter. These choices weren't made consciously, of course, but emerged from quantum fluctuations amplified during cosmic evolution. The universe we inhabit, with all its specific properties, represents just one possible outcome from the symmetric potential of the early cosmos. Different quantum fluctuations could have led to different symmetry breakings, different particles, different forces, a different universe entirely. This leads us to another mind-bending possibility. Our universe might be just one realization of countless potential universes, each with different physical constants and laws. The specific values we observe, the strength of gravity, the mass of the electron, the the nuclear binding force, may not be inevitable or unique. They might simply be the values that emerged in our particular cosmic domain through the contingent process of symmetry breaking. Other regions beyond our observable horizon might have experienced different symmetry breakings, resulting in different physical laws. The multiverse hypothesis, already suggested by eternal inflation, finds additional support in this understanding of symmetry breaking in the early universe. If cosmic inflation spawns multiple universe bubbles, and if symmetry breaking can occur differently in each bubble, then reality might encompass a vast ensemble of universes with different physical properties. Some would be sterile, unable to form atoms or stars. Others might develop chemistry so alien we would scarcely recognize it as matter. We find ourselves in a universe compatible with our existence, not because it was designed for us, but because we could only evolve in a cosmos with physical laws compatible with complexity and life. But let's return to what we can observe: the cosmic microwave background radiation, that faint glow from the universe's youth that permeates all of space. When scientists first mapped this radiation in detail with satellites like COBE, SAWABMAP, and Planck, they discovered something remarkable. Tiny temperature fluctuations, variations of just 1 part in 100,000 in the otherwise uniform afterglow of creation. These minuscule ripples, quantum fluctuations stretched to cosmic scales by inflation, became the seeds of all cosmic structure. Without them, matter would have remained perfectly distributed throughout the universe. Gravity would have had nothing to pull together into stars and galaxies. The fact that these fluctuations exist at all is significant. In a perfectly smooth, perfectly homogeneous early universe, no structure could ever form. The cosmos would remain an ever-expanding, ever-cooling gas of hydrogen and helium, too diffuse to collapse into stars, too uniform to develop complexity. The same quantum uncertainty principle that makes it impossible to precisely measure both. The position and momentum of a particle also ensured that the early universe couldn't remain perfectly uniform. Quantum fluctuations, tiny variations in energy density imprinted on the inflationary field, provided the seeds from which all complexity grew. This connection between quantum uncertainty and cosmic structure reveals a profound truth. The universe's capacity for complexity is built into its most fundamental principles. The same quantum laws that make atoms stable and chemistry possible also ensured that the cosmos would develop structure rather than remaining forever uniform. The large-scale universe and the microscopic quantum realm aren't separate domains governed by different rules. They're aspects of a single reality, connected through the cosmic evolution from quantum fluctuations to galactic superclusters. There's something almost poetic about this connection. The vast cosmic web of galaxy clusters and filaments, the largest structures in the observable universe, spanning hundreds of millions of light-years, began as subatomic ripples in the quantum foam of space-time. The map of these structures, revealed by massive galaxy surveys, bears an uncanny resemblance to the neural networks of a brain, or to the complex filaments of the Internet, or to the branching patterns of rivers and trees. Similar patterns emerge, at vastly different scales throughout nature, suggesting deep mathematical principles underlying the organization of complexity across the cosmos. These patterns, these echoes of the universe's first moments, surround us everywhere we look. The hydrogen atoms in the water you drink formed in the first 3 minutes after the Big Bang, and have existed ever since. Neither created nor destroyed, but merely rearranged through cosmic history. The heavier elements in your body, carbon, oxygen, iron, were forged in the nuclear furnaces of stars that lived and died before our sun was born. Stars whose formation was determined by those quantum fluctuations in the infant universe. You aren't just connected to the cosmos, You're a direct product of its evolution. Your very atoms witnesses to the universe's entire history. But perhaps the most profound connection between you and the early universe lies not in matter, but in pattern. The complex biochemical processes that allow your cells to function, the neural patterns that give rise to your thoughts and perceptions, the genetic code that guided your development from a single cell to a conscious being. All these are examples of information processing of ordered complexity emerging from simpler precursors. And this emergence of complexity, this growth of pattern and structure over time, has characterized the universe since its first moments. From the breaking of symmetries in the infant cosmos to the differentiation of forces and particles, from the gravitational collapse of matter into stars and galaxies to the biochemical evolution of life on at least one planet, the universe has demonstrated an inherent tendency toward increasing complexity. Not everywhere, and not inevitably, entropy ensures that disorder increases in closed systems over time. But in open systems that can exchange energy with their surroundings, complexity can grow, patterns can develop, information can increase. The universe as a whole may be winding down toward heat death, but within it, islands of complexity continue to evolve, to organize, to process information in increasingly sophisticated ways. Your consciousness, your ability to read these words and contemplate these ideas, represents one such island, perhaps the most complex information processing system we know of. Through your mind, the universe has developed the capacity to contemplate its own origins, to reconstruct its history, to model its evolution, to predict its future. This capacity isn't separate from cosmic evolution. It's a natural outgrowth of the same processes that began in the universe's first second. The cosmos hasn't just become more structured over time. It has become more aware, more capable of self-reflection through beings like you. What does this mean for our understanding of cosmic origins? If consciousness and complexity are natural outgrowths of the universe's evolution, then the capacity for awareness may have been implicit in the cosmos from the beginning. Not consciousness itself. The early universe was far too hot and dense for anything like a mind to exist, but the potential for consciousness, encoded in the mathematical structure of reality, like a seed waiting to germinate under the right conditions. The universe's fundamental constants, the precise balance of forces, the specific properties of particles, all seem calibrated to allow for the emergence of complexity and, eventually, consciousness. This observation has led some physicists and philosophers to propose the strong anthropic principle, the idea that the universe must have properties that allow consciousness to develop within it. Not because some external designer arranged it that way, but because a universe without observers would remain forever unknown, outside the realm of empirical science. We can only observe universes capable of producing observers. This isn't mysticism, but a recognition of the selection effects inherent in our observations. If multiple universes exist with different physical laws, we necessarily find ourselves in one compatible with our evolution. But there's another, even more provocative possibility. What if consciousness itself plays a role in cosmic evolution? Some interpretations of quantum mechanics suggest that observation is not passive but participatory, that the act of measurement somehow helps determine quantum outcomes. If true, this would mean that conscious observers aren't mere byproducts of cosmic evolution, but active participants in it, helping to crystallize potential into actuality through the act of observation. The universe wouldn't just be becoming more aware through beings like us. It would be partially shaped by that awareness, as though reality and consciousness were engaged in a feedback loop of co-creation. This perspective transforms our understanding of the universe's first second from a purely physical event into something more subtle, the emergence not just of matter and energy, but of potential, of a cosmos pregnant with possibility. encoding within its mathematical structure the capacity for ever-increasing complexity and, eventually, self-awareness. Creation, in this view, wasn't completed in the universe's first moments, but continues through the evolution of complexity across cosmic history, with consciousness representing not an anomaly, but the fulfillment of potential present from the beginning. But there's another explanation for fine-tuning that's perhaps even more provocative. What if the universe fine-tunes itself through a kind of cosmic natural selection? Some theoretical physicists have proposed that black holes might give birth to new universes, with slight variations in their physical laws. Universes that produce many black holes would have more offspring, leading to an evolutionary process, favoring universes with physical constants conducive to black hole formation. Intriguingly, the same conditions that optimize black hole production, long-lived stars, stable chemistry, complex structures, also happen to enable life. We might exist in a life-friendly universe not because it was designed for us, but because universes capable of producing intelligent observers also tend to produce many black holes, and thus many cosmic offspring. This cosmic evolutionary perspective transforms our understanding of fine-tuning from a mysterious coincidence into a natural outcome of selection processes operating beyond our observable horizon. The universe wouldn't be fine-tuned by design, but through a process analogous to biological evolution, with cosmic domains that produce more offspring becoming more numerous in the ensemble of universes. Our existence wouldn't be the purpose of cosmic fine-tuning, but a side effect of conditions optimized for black hole production and universal reproduction. These speculations about multiverses, cosmic natural selection, and the fundamental nature of consciousness might seem to take us far from empirical science, but they arise naturally from attempts to understand the universe's first second, to explain the precise values of cosmic parameters, to account for the emergence of complexity, to comprehend our place within the cosmic story. The universe's beginning wasn't just a physical event, but a philosophical watershed, a moment that established the conditions for everything that would follow, including the emergence of beings capable of contemplating their own origins. Let's step back from these philosophical frontiers and consider another familiar concept that dissolves under scrutiny: the notion of cosmic age. We confidently state that the universe is 13.8 billion years old. But what does this actually mean? Time itself is not absolute but relative, affected by gravity and motion, as Einstein's theories of relativity revealed. The intense gravity of the early universe would have dilated time, making its first second subjectively much longer than a second as we experience it now. And the rapid expansion of space during inflation would have further complicated the measurement of time, stretching not just matter and energy, but the very fabric of temporal experience. If the universe exists in a state of eternal inflation beyond our observable horizon, with new cosmic domains constantly nucleating from the inflationary field, then different regions might effectively have different ages depending on when they transitioned from inflation to standard expansion. Our cosmic domain might be 13.8 billion years old, but others could be younger or older, with the inflationary process itself potentially extending infinitely into the past. The question, how old is the universe, might have no single answer, but depend on which part of the greater cosmos we're referring to. This temporal complexity becomes even more profound when we consider the beginning itself. If time, as we understand, it emerged with the universe, then asking what happened before the Big Bang may be like asking what's north of the North Pole, a question that assumes a dimension of movement in a direction where no such dimension exists. The beginning of our universe might not mark the beginning of all reality, but a boundary in our ability to trace cosmic history backward, a horizon beyond which our current physics cannot penetrate. Some theories suggest that time itself might be emergent rather than fundamental, a macroscopic phenomenon arising from deeper quantum processes that don't inherently distinguish between past and future. In certain quantum gravity approaches, space-time isn't a foundational entity, but emerges from networks of quantum relationships, like temperature emerges from the collective motion of atoms rather than being a property of individual particles. If true, this would transform our understanding of cosmic origins from a temporal beginning to something more subtle, the emergence of temporality itself from atemporal quantum foundations. What's striking about these ideas is that they don't originate from philosophical speculation, but from attempts to reconcile quantum mechanics with general relativity to understand how physics behaves under the extreme conditions of the early universe. The mathematics leads us inevitably toward scenarios where the Big Bang is not an absolute beginning, but a transition, where time itself may be emergent rather than fundamental, where reality might be far stranger and more extensive than our intuitions suggest. These aren't just alternative narratives, but implications of our most successful physical theories pushed to their logical conclusions. Let's consider another familiar concept that transforms under scrutiny: the notion of cosmic evolution. We often imagine the universe evolving from simplicity to complexity, from the uniform plasma of the early cosmos to the rich structure we observe today. But this narrative oversimplifies a more subtle truth. The early universe wasn't truly simple. It was a state of extreme energy and density, where complexity was compressed and disguised, where the distinctions between forces and particles were blurred by incredible heat. What we call the evolution of the cosmos might better be described as a revelation, the gradual unfolding of structure that was potentially present from the beginning, encoded in the mathematical fabric of reality. This perspective transforms our understanding of cosmic history. The universe didn't become complex through the addition of new elements, but through the differentiation of what was already there, the manifestation of potentials encoded in its initial conditions. The seeds of everything we observe today, from subatomic particles to galactic superclusters, from chemical elements to conscious minds, were present in mathematical form from the universe's first moment. Cosmic evolution isn't creation ex nihilo, but revelation, the universe gradually discovering and expressing its inherent potential for structure and complexity as it expands and cools. There's something profound about this connection between potential and manifestation. The universe's first second established not just the physical conditions, but the mathematical possibilities for everything that would follow. The specific values of cosmic parameters, the strength of forces, the properties of particles, the behavior of fields, created a landscape of potential within which all subsequent cosmic evolution would unfold. The universe wasn't just a collection of matter and energy. It was a set of relationships, a mathematical structure embodied in physical form, gradually expressing its inherent possibilities through billions of years of evolution. This mathematical aspect of reality connects directly to one of the deepest mysteries in modern physics: the unreasonable effectiveness of mathematics in describing the physical world. Why should abstract mathematical relationships, developed by human minds through logical reasoning, so perfectly capture the behavior of the physical universe? This question, posed by physicist Eugene Wigner in 1960, gains even greater significance when we consider the universe's first second. The cosmos doesn't just follow mathematical laws. It seems to embody them, to be made of them in some fundamental sense. The physical and the mathematical aren't separate domains, but aspects of a single reality. Some theoretical physicists have taken this connection to its logical conclusion, suggesting that physical reality might be fundamentally mathematical, that the universe isn't just described by mathematics, but is mathematics, a vast structure of relationships that we experience as matter, energy, space, and time. From this perspective, the universe's first second wouldn't mark the creation of physical stuff, but the instantiation of a particular mathematical structure, a set of relationships that would gradually unfold into the cosmos we observe. Physical. Reality would be an expression of mathematical reality rather than something separate from it. This mathematical perspective transforms our understanding of cosmic origins. The beginning wouldn't be the creation of something from nothing, but the selection of a particular mathematical structure from a vast landscape of possibilities, perhaps through processes analogous to quantum mechanics. The question, why these physical laws rather than others, becomes why this mathematical structure rather than another? A question that might be answered through considerations of consistency, stability, or complexity. The universe might be the way it is because its mathematical structure is particularly fertile, capable of generating remarkable complexity through relatively simple initial conditions. Let's explore another familiar concept that transforms under scrutiny: the notion of creation itself. We often imagine the universe's beginning as a moment of absolute novelty, when reality sprang forth from nothingness. But what if creation isn't the production of something from nothing, but the transformation of potential into actual, of possibility into reality? What if the universe's first second didn't mark the absolute beginning of all existence, but a phase transition within a deeper reality? A crystallization of one set of possibilities from an infinite sea of potential. This perspective aligns with findings from theoretical physics. Quantum field theory suggests that the vacuum, what we call empty space, isn't nothing but a complex entity with structure, energy, and properties. It can exist in different states, with different energies and characteristics. The vacuum we observe might be just one configuration among many, perhaps not even the most stable one. What we call the Big Bang might have been a transition from one vacuum state to another, a phase change in the underlying fabric of reality rather than creation ex nihilo. Such a perspective transforms our understanding of cosmic origins. The beginning of our universe wouldn't mark the beginning of all reality, but merely a transition within a much larger, perhaps eternal, reality. The question, why is there something rather than nothing, assumes a false dichotomy. Perhaps nothing, in the absolute sense, is inherently unstable or even impossible. Perhaps somethingness is the default state of reality, with different manifestations of something transitioning from one to another across scales far beyond our observable horizon. This doesn't mean the universe has no beginning, of course. Our observable cosmos, with its specific properties and evolution, clearly originated in the hot, dense state we call the Big Bang. But this event might be less like creation ex nihilo and more like birth, the emergence of a new domain of reality, from a pre-existing state, carrying forward the potential of its parent while developing its own unique characteristics. The universe's first second would mark not the beginning of existence itself, but the beginning of our particular cosmic domain, with its specific physical laws and evolutionary trajectory. If true, this would mean that the deepest mystery isn't why the universe exists at all, but why it exists in this particular form rather than another. Why these physical constants rather than others? Why these fundamental forces? Why these particles with these specific properties? The universe's first second established not just the fact of existence, but the particular character of our reality, the specific mathematical structure that would gradually unfold into stars, planets, and consciousness. The question shifts from why something rather than nothing to why this something rather than another. This question brings us back to the fine-tuning problem and the various explanations we've considered: design, multiverse, mathematical necessity. cosmic evolution. Each represents a different approach to understanding why the universe is the way it is, why the cosmos established in that first second had exactly the properties needed for complexity and eventually consciousness to emerge. Each has profound implications not just for our scientific understanding, but for our philosophical and even spiritual approach to existence. If the universe was indeed fine-tuned by design, then our existence fulfills an intention present from the beginning. If the fine-tuning emerges from a multiverse, then our existence represents the actualization of one possibility among many. Significant not because it was intended, but because it could be observed. If the fine-tuning reflects mathematical necessity, then our existence expresses the inherent fertility of mathematical reality, the capacity of certain structures to generate remarkable complexity. If the fine-tuning results from cosmic evolution, then our existence participates in an ongoing creative process, extending far beyond our observable horizon. These different perspectives remind us that our understanding of the universe's first, second isn't just a scientific question, but a philosophical one. Not just about what happened, but about what it means, about our place within the cosmic story. The factual details of cosmic origins, as fascinating as they are, gain their deepest significance when connected to questions of meaning and purpose, when integrated into our understanding of existence itself. Science tells us how the universe began. Philosophy and spirituality help us understand what that beginning means for our lives. Let's consider one final paradox. If the universe has no edge, as contemporary cosmology suggests, then where does it begin? This question assumes that beginning means boundary in space. But cosmic origins are about boundaries in time, not space. The Big Bang happened everywhere at once, at every point in space as we know it. There wasn't a central explosion that matter expanded outward from. Rather, all of space was once compressed into an incredibly hot, dense state, and has been expanding ever since. The beginning of the universe isn't a location you could visit. It's a moment in time that affected all locations simultaneously. But even this picture, the universe beginning everywhere at once, may be incomplete. If the universe is infinite, in spatial extent, as some evidence suggests, then it may always have been infinite. The Big Bang wouldn't have been the creation of an infinitely large cosmos, but the transition of an already infinite domain from one state to another. Even in the universe's first-second, space itself might have been boundless, with no edge and no center. The hot, dense, early phase would have extended infinitely in all directions, and the subsequent expansion would have carried every region away from every other, stretching an already infinite fabric rather than expanding a finite bubble. This notion of an infinite universe transforming rather than a finite universe expanding challenges our intuitive picture of cosmic origins. It suggests that the beginning wasn't the creation of everything from nothing, but a transformation of everything from one state to another. The universe's first second wouldn't mark the beginning of existence itself, but a phase transition within an already existing infinite reality. Creation wouldn't be about size or extent, but about quality and character, the establishment of specific properties and relationships that would define our cosmic domain. If true, this would mean that the universe has always been infinite in a spatial extent, even at the moment of the Big Bang. It would always have contained an infinite amount of matter and energy, just compressed into an infinitely denser state in the past. The expansion we observe wouldn't be the growth of a finite bubble into infinite space, but the stretching of an already infinite fabric, carrying galaxies away from each other like dots on an expanding balloon. Except the balloon would have no edge and no center, extending infinitely in all directions even as it stretches. This infinite perspective transforms our understanding of cosmic evolution. The universe wouldn't be growing larger in an absolute sense, but becoming less dense as space stretches. Though, total amount of matter and energy would remain constant, infinite then, infinite now, but spread across an increasingly vast cosmic expanse. The observable universe, the portion of the cosmos from which light has had time to reach us since the Big Bang, would represent an increasingly tiny fraction of the infinite whole, a cosmic horizon expanding at the speed of light into boundless reaches beyond. If the universe has always been spatially infinite, then what lies beyond our observable horizon isn't empty space, but more universe, more galaxies, more stars, more planets, perhaps even more observers contemplating their own cosmic origins. The cosmos visible to our instruments, spanning 93 billion light-years in diameter, would be like a tiny island in an infinite ocean, one observable domain among countless others, separated not by space, but by the finite speed of light and the finite age of the universe. The unobservable cosmos would be not a theoretical abstraction, but a real physical extension of what we can see, differing only in that light from those regions hasn't had time to reach us yet. This perspective resolves the apparent contradiction between the universe having a beginning in time but no boundary in space. The Big Bang would mark the beginning of our cosmic history, but not the creation of space itself. Space would extend infinitely in all directions, with the observable universe representing the portion from which light has had time to reach us in the 13-point pointers. Since the beginning. The cosmic horizon wouldn't be an edge, but a limit of observation, a boundary not in space, but in our ability to see beyond a certain distance due to the finite speed of light and the finite age of the universe. But if space has always been infinite, and if the Big Bang happened everywhere at once, then how could the universe have been both infinitely large and incredibly dense at the beginning? This apparent paradox dissolves when we recognize that density and size are independent properties. An infinite space can still have infinite density if it contains an infinite amount of matter and energy. The early universe would have been infinitely large in spatial extent, but infinitely dense in content, with every region compressed to incredible temperatures and pressures. The subsequent expansion would have decreased the density while maintaining the infinite extent. This infinite perspective challenges our intuitive understanding of the universe's first second. The beginning wouldn't be the creation of space, or the emergence of everything from a finite point. It would be a transition from one infinite state to another, from infinite density to gradually decreasing density, from perfect uniformity to gradually emerging structure. The Big Bang wouldn't be an explosion into pre-existing empty space, but a transformation of space itself from one condition to another, a phase transition affecting every point in an already infinite cosmos. What's striking about this perspective is that it emerges not from philosophical speculation, but from our best current understanding of cosmology, from the mathematics of general relativity, combined with observational evidence suggesting that the universe is spatially flat and potentially infinite in extent. The universe's first second, viewed through this lens, becomes not the beginning of everything, but the beginning of our particular cosmic phase, the transition from a hot, dense, uniform state to the gradually cooling, expanding, and structuring cosmos we observe today. This infinite perspective transforms our understanding of creation itself. The universe wouldn't have been created in the sense of being made from nothing, but would have transitioned from one state to another, always containing an infinite amount of matter and energy spread across infinite space. Creation wouldn't be about making something from nothing, but about transforming something from one condition to another, from simplicity to complexity, from uniformity to diversity, from potential to actuality. The universe's first second would mark not the birth of reality, but its transformation, the beginning of a cosmic journey that continues to this day. As we reach the limits of our current understanding, we find ourselves not at the end of knowledge, but at the threshold of deeper questions. The universe's first second reveals itself not as a solved problem, but as a frontier of ongoing inquiry, a mystery that each generation of scientists approaches with new tools, new mathematics, new perspectives. Each answer generates new questions. Each discovery illuminates new unknowns. This is not a failure of science, but its greatest strength, its endless capacity for refined understanding, for approaching truth asymptotically through successive approximations. You exist in a universe still coming to know itself through beings like you, conscious entities capable of wonder, of mathematics, of peering back toward beginnings and forward toward possibilities. Your presence here is neither accident nor inevitability, but something more subtle. The manifestation of potentials encoded in the cosmos from its first moments. The universe's capacity to evolve complexity, to generate systems capable of self-organization and eventually self-awareness, may be as fundamental as its physical laws, perhaps consciousness itself. The light of awareness illuminating existence from within was implicit in the mathematical structure of reality from the very beginning, of possibility, of a cosmos capable of eventually knowing itself through. Beings evolved within it. The Big Bang wouldn't just be the birth of physical reality, but the initial conditions for an ongoing creative process, one that would eventually include self-awareness as one of its expressions. Creation wouldn't be complete in the universe's first moments, but would continue through the evolution of complexity and consciousness across cosmic history. Of course, these ideas lie at the frontier where physics meets philosophy, where empirical science encounters questions of meaning and purpose. They remind us that our understanding of cosmic origins isn't just about what happened, but about what it means. Not just about the mechanics of creation, but about our place within the creative process. The factual question, how did the universe begin? Inevitably leads to the more profound question, what does it mean that the universe exists at all, and in such a way that we can contemplate its beginning? Let's return to more solid empirical ground with another familiar but misleading concept, the notion of empty space. We often imagine the vacuum of space as nothingness, as the absence of everything. But quantum field theory reveals a far stranger picture. Empty space is actually a seething quantum foam of virtual particles popping in and out of existence, borrowing energy from the vacuum for such brief periods that they don't violate conservation laws. This isn't a theoretical abstraction. The effects of these vacuum fluctuations have been experimentally verified through phenomena like the Casimir effect and spontaneous emission from excited atoms. In the universe's first second, these vacuum fluctuations played a crucial role. The intense energy density of the early cosmos amplified quantum effects, making the distinction between real and virtual particles almost meaningless. Particles were constantly being created and destroyed, transforming from one type to another in a chaotic dance of energy and matter. What we now perceive as the stable, structured cosmos emerged gradually from this quantum tumult as the universe expanded and cooled, allowing particles to settle into more stable configurations. This quantum nature of the vacuum transforms our understanding of nothing. True nothingness, the complete absence of fields, energy, and even space-time itself, may be physically impossible. A mathematical idealization that can't actually exist. What we call empty space is actually a complex entity with structure, energy, and properties. It can bend, ripple, expand, and contract. It can spawn particles under certain conditions. It has intrinsic energy, a dark energy that appears to be accelerating the universe's expansion. Empty space isn't nothing. It's a something so fundamental that we mistake it for nothing. Like fish who don't perceive the water they swim in. If empty space is actually something, then what existed? Before the Big Bang wasn't truly nothing either. It might have been a different state of the quantum vacuum, perhaps a more symmetric, higher energy configuration that became unstable and underwent a phase transition, like water becoming steam, but in reverse. The Big Bang might not mark the you, creation of everything from nothing but a transformation of one state of the quantum vacuum into another. Creation ex nihilo, something from absolute nothing, may be not just physically impossible but logically incoherent. A question based on a fundamental misunderstanding of what nothing means in physics. This perspective aligns with findings from theoretical physics. Quantum field theory suggests that vacuums can exist in different states, with different energies and properties. The vacuum we observe may be just one possible configuration, perhaps not even the most stable one. Our universe might be in a false vacuum state, metastable but capable of eventually transitioning to a lower energy true vacuum through quantum tunneling. Such a transition would propagate outward at the speed of light, fundamentally altering the laws of physics in the regions it affects. What we call the Big Bang may have been such a vacuum transition in a small region of a pre-existing space, which then expanded to become our observable universe. These ideas, vacuum transitions, multiple vacuum states, the inherent somethingness of empty space, transform our understanding of cosmic origins. The beginning of our universe may not mark the beginning of all reality, but merely a transition within a much larger, perhaps eternal, reality. The question, why is there something rather than nothing, assumes a false dichotomy. Perhaps nothing, in the absolute sense, is inherently unstable or even impossible. Perhaps somethingness is the default state of reality, with different manifestations of something transitioning from one to another across scales of space and time far beyond our observable horizon. This brings us to another profound mystery, the asymmetry between matter and antimatter. According to our current understanding of particle physics, the early universe should have produced equal amounts of matter and antimatter, which would have completely annihilated each other as the cosmos cooled, leaving nothing but radiation. No stars, no planets, no people. Yet here we are, in a universe dominated by matter, with very little antimatter to be found. Something in the universe's first second must have created a tiny imbalance, a slight preference for matter over antimatter, about one extra matter particle for every billion matter-antimatter pairs. This asymmetry, this cosmic favoritism toward matter, remains one of physics' greatest unsolved mysteries. Various mechanisms have been proposed to explain it, involving subtle violations of symmetry principles in particle interactions during the universe's first instance. But no definitive answer has emerged. The fact that we exist at all, that matter, remained after the Great Annihilation, testifies to some fundamental asymmetry woven into the fabric of reality. The universe, it seems, isn't perfectly balanced or neutral. It has built-in preferences, slight biases that proved crucial for the emergence of the structured cosmos we inhabit. These biases, these broken symmetries, these cosmic choices made in the universe's first second determined the entire subsequent history of the cosmos. If the matter-antimatter asymmetry had been slightly different, if the strength of forces had varied by even a small amount, if the mass of fundamental particles had been shifted upward or downward, the universe as we know it might never have formed. Stars might have burned too quickly or too slowly, chemistry might have been impossible, complexity might never have emerged. The specific cosmos we observe, with its particular properties and possibilities, crystallized from a vast landscape of potentials during those crucial first moments. This fine-tuning, this apparent calibration of cosmic parameters to values that allow for complexity and life, constitutes another profound mystery. The fundamental constants of nature, from the strength of gravity to the mass of the electron to the energy of the vacuum, seem precisely balanced to allow for the emergence of a structured, life-supporting cosmos. Slight variations in any of these values would result in a sterile universe, one where atoms couldn't form, or stars couldn't shine, or complexity couldn't emerge. The knife edge of possibility upon which our existence balances seems too precise to be mere coincidence. Various explanations have been proposed for this fine-tuning. Some see in it evidence of design, a cosmic architecture calibrated for life. Others point to the multiverse hypothesis, the idea that our universe is just one of countless universes with different physical laws, and we necessarily find ourselves in one capable of supporting our existence. Still others suggest that the constants of nature aren't independent, but connected through deeper mathematical principles we haven't yet discovered, such that the values we observe are the only possible consistent set. These different interpretations, theological, multiverse, and mathematically necessary, represent not just scientific hypotheses, but different philosophical approaches to understanding the apparent design of our cosmos. What's striking is that these questions about fine-tuning, about the specific values of cosmic parameters, trace back to the universe's first second. The fundamental architecture of reality, the framework within which all subsequent cosmic evolution would unfold, was established during those crucial initial moments. The universe didn't gradually become fine-tuned for complexity and life. It was fine-tuned from the very beginning, through the specific values of constants and the precise relationships between forces that emerged as the cosmos cooled from its primordial state. This realization transforms our understanding of cosmic history. The evolution of complexity, from subatomic particles to atoms to molecules to living cells to conscious beings like us, wasn't a series of fortunate accidents, but the unfolding of potential encoded in the universe's initial conditions. The cosmos wasn't merely capable of producing complexity. It was structured from its first moments in such a way that complexity would naturally emerge as it expanded and cooled. The seeds of everything we observe today, from galactic superclusters to the human brain, were present in mathematical form from the universe's first instant. Consider the formation of the first atoms, primarily hydrogen and helium, during the first few minutes of cosmic history. The specific ratio of these elements, roughly 75% hydrogen, 25% helium, was determined entirely by conditions in the universe's first second: its density, its expansion rate, the strength of the nuclear force. This primordial mix would provide the raw material from which the first stars would form hundreds of millions of years later, and these stars would forge the heavier elements essential for planets and life. The composition of your body, mostly oxygen, carbon, hydrogen, nitrogen, calcium, and phosphorus, was indirectly determined by processes set in motion during the universe's first moments. But there's another, even more direct connection between you and the early universe: the conservation of energy and matter. The total energy present in the cosmos has neither increased nor decreased since the beginning. It has only changed form. The matter and energy that make up your body have existed, in some form, since the universe's first second. Not similar matter, not matter like it. The exact same energy and particles, rearranged and transformed through cosmic history. When you gaze at the stars, you're not just looking at distant objects. You're looking at your extended self, at Matter and energy that is fundamentally one with your own physical substance. This deep connection between the human body and the cosmos isn't merely poetic, but literal. The hydrogen in your water molecules formed in the universe's first few minutes and has existed unchanged ever since. The carbon in your cells was forged in the nuclear furnaces of ancient stars that lived and died before our sun was born. Eerie. Iron in your blood was created in stellar explosions billions of years ago. You are, in the most literal sense, made of stardust. Your physical substance a testament to the entire history of cosmic evolution, from the universe's first second to the present moment. But perhaps the most profound connection lies not in shared substance, but in shared pattern. The same principles of self-organization that shaped cosmic structure, the gravitational collapse of matter into stars and galaxies, the nuclear fusion that powers stellar furnaces, the complex chemistry that became possible as the universe cooled, also guided the emergence of life on Earth. The universe's tendency toward increasing complexity, toward the growth of pattern and structure over time, expressed itself first in cosmic evolution and later in biological evolution. The human brain, with its 100 billion neurons and 100 trillion synapses, represents the most complex structure we know of, a fitting culmination of the universe's long journey from primordial simplicity to organized complexity. Through your capacity for perception, for thought, for understanding, the universe has developed the ability to contemplate its own origins. This is not mysticism, but a straightforward observation. The same matter and energy that were present at the cosmic dawn have organized themselves, through natural processes over billions of years, into systems capable of reconstructing their own history. Your consciousness isn't separate from cosmic evolution. It's a natural outgrowth of the same processes that began in the universe's first second. The cosmos hasn't just become more structured over time, it has become more aware through beings like you. This perspective transforms our understanding of consciousness from a mysterious anomaly into a natural expression of cosmic evolution. Just as galaxies and stars are patterns that emerged as the universe expanded and cooled, consciousness may be a pattern that naturally emerges when matter and energy are organized in certain ways. The universe's capacity for self-awareness may be as fundamental as its capacity for forming atoms or stars, not something imposed from outside, but something inherent in its mathematical structure, a potential waiting to be realized under the right conditions. If consciousness is indeed a natural outgrowth of cosmic evolution, then the capacity for awareness may have been implicit in the universe from its first moment. Not consciousness itself. The early universe was far too hot and dense for anything like a mind to exist, but the potential for consciousness, encoded in the mathematical structure of reality, like a seed waiting to germinate. The universe's fundamental constants, the precise balance of forces, the specific properties of particles, all may have been calibrated not just to allow for stars and planets, but to enable the eventual emergence of awareness. This raises a profound possibility. What if consciousness itself is fundamental to reality? What if awareness isn't just a late-emerging property of certain complex systems, but a basic aspect of existence, present in some form at all scales? This perspective, known as panpsychism or pan-experientialism, suggests that consciousness isn't something that suddenly appears when matter reaches a certain threshold of complexity, but something that exists in primitive form throughout nature, becoming more complex and self-reflective in systems like the human brain. The universe wouldn't just be becoming more conscious through evolution. It would be conscious in some sense from the very beginning. These ideas lie at the frontier where physics meets philosophy, where empirical science encounters questions of meaning and purpose. They remind us that our understanding of cosmic origins, isn't just about what happened, but about what it means. Not just about the mechanics of creation, but about our place within the creative process. The factual question, how did the universe begin, inevitably leads to the more profound question. What does it mean that we exist in a universe capable of contemplating its own beginning? If the universe has been fine-tuned for complexity and consciousness from its first second, then our existence isn't an accident or a cosmic afterthought, but the fulfillment of potential encoded in reality from the very beginning. We aren't separate from the cosmic process, but integral to it, the universe becoming aware of itself through beings capable of understanding its history and structure. This doesn't necessarily imply design or purpose in a traditional sense, but it does suggest that consciousness and complexity may be as fundamental to cosmic evolution as gravity or electromagnetism. This perspective transforms our understanding of the universe's first second from a purely physical event into something more subtle. The emergence not just of matter and energy, but of potential. Here at the edge of understanding, where science meets wonder, we find ourselves confronting the universe's deepest mysteries, paradoxes that challenge not just what we know, but how we know it. The scientific story we've told ourselves about the beginning is both triumphant and incomplete. Like archaeologists, piecing together civilizations from fragments of pottery and stone, cosmologists reconstruct the universe's first moments from whispers of radiation and the mathematical echoes of creation. But within this reconstruction lie mysteries so profound they shake the very foundations of physics. The first of these mysteries takes us to the absolute beginning, the singularity. For decades, cosmologists have described the universe's origin as emerging from a singularity, a point of infinite density and zero volume where the laws of physics as we understand them break down completely. Every equation we use to describe reality produces infinities when applied to this initial state, mathematical symptoms of a theory pushed beyond its limits of applicability. The singularity isn't just a description of extreme conditions, it's a warning sign, a mathematical red flag indicating that our understanding has reached its frontier. Imagine reality as a film reel, with each frame representing a moment in time. If you run the film backward, tracing cosmic evolution to its source, the frames become increasingly compressed, increasingly dense, increasingly hot, until you reach a frame that's infinitely compressed, where the entirety of the cosmos occupies. No volume at all. This is the singularity. Not a place or a thing, but a boundary to our understanding. A point where our equations fail and our intuitions falter. The singularity isn't something that existed within space-time. It's something that existed before space-time itself had fully emerged. But there's a profound problem with this picture. General relativity, our most comprehensive theory of gravity, space, and time, predicts its own failure at the singularity. The theory tells us that the curvature of space-time becomes infinite, that density becomes infinite, that temperature becomes infinite, all signs that the theory itself has broken down. It's as if Einstein's magnificent framework, capable of describing the dance of galaxies and the warping of light around stars, throws up its hands in surrender when asked to describe the ultimate beginning. The very theory that predicts the Big Bang also predicts that it cannot completely describe that event. This isn't a failure of science, but a frontier, a recognition that general relativity, for all its elegance and precision, is an incomplete description of reality. Just as Newton's laws of motion, perfect for everyday objects, break down at speeds approaching light or in intense gravitational fields, Einstein's equations falter when matter is compressed beyond certain limits. The singularity isn't a physical reality, but a mathematical artifact, a sign that we need a more comprehensive theory that unites gravity with quantum mechanics, a theory of quantum gravity. Several candidates for this unified theory exist, from string theory to loop quantum gravity to causal set theory. Each approaches the problem from different angles, each offers different insights, and each suggests different resolutions to the singularity problem. What they share is a common implication. The Big Bang singularity may not have existed at all. It may be a mirage, an artifact of applying classical equations to a domain where quantum effects cannot be ignored. In loop quantum gravity, for instance, space-time itself is quantized, built from discrete units rather than being infinitely divisible. This quantum nature of space acts like a cosmic safety net, preventing the infinite compression that leads to a singularity. Matter can only be compressed to a certain minimum volume, beyond which quantum gravity effects create an effective repulsive force. The universe may have begun not as a singularity, but as a quantum bounce, a transition from a previously contracting phase to our currently expanding one, mediated by quantum gravitational effects at the Planck scale. Imagine space itself composed of tiny indivisible units, quantum pixels of reality about 10 to 35 meters across. As the universe contracts in a hypothetical pre-Big Bang phase, these pixels cannot be squeezed beyond a certain density. Like trying to compress a digital image beyond its resolution, you eventually hit the fundamental graininess of reality itself. The universe wouldn't compress to a point, but to a minimum volume determined by these fundamental units of space. At this maximum compression, quantum gravitational effects would generate tremendous pressure, triggering a bounce into expansion, what we call the Big Bang. This quantum bounce scenario transforms our understanding of the universe's first. Second, the beginning wouldn't be an emergence from nothing but a transition from contraction to expansion, from decreasing volume to increasing volume. There would be no singularity, no point where physics breaks down completely, but rather a quantum bridge connecting a previous cosmic phase to our own. The universe's history would extend before the Big Bang, with our observable cosmos representing just the latest chapter in a much longer, perhaps cyclic, narrative. But the quantum bounce is just one possibility. String theory offers another perspective on the singularity problem. In this framework, the fundamental constituents of reality aren't point particles, but tiny vibrating strings, whose different vibrational patterns manifest as different particles and forces. These strings exist in a higher dimensional space, with our familiar 4 dimensions, 3 of space, 1 of time, representing a subset of a more complex geometry. The mathematics of string theory suggests that what appears as a singularity in general relativity might be a perfectly well-behaved, non-singular event when viewed through the lens of the full higher dimensional theory. Imagine the universe as a complex, multi-layered tapestry with our observable reality representing just one layer among many. What appears as a tear in our layer, the singularity, might be a seamless transition when viewed from the perspective of the entire tapestry. The beginning of our universe might represent the creation of our specific layer, our particular brain, short for membrane, within a higher dimensional bulk space, rather than the creation of all reality. Our cosmic origin would be less like creation ex nihilo and more like budding or branching, with our universe emerging from a pre-existing higher dimensional reality. This string theory perspective transforms our understanding of the universe's first-second from an absolute beginning into a transition within a larger framework. The Big Bang wouldn't mark the beginning of everything, but the beginning of our specific cosmic domain, with its particular properties and evolution. The fundamental questions shift from why did the universe begin to why did it begin with these specific properties? And what processes in the higher dimensional bulk determine the characteristics of our cosmic bubble? But these string-theoretical possibilities come with a profound caveat. They remain largely mathematical constructs, beautiful in their elegance, but challenging to connect to observable reality. The extra dimensions predicted by string theory, if they exist, must be compactified, curled up into spaces so tiny that they escape direct detection with our current technology. The higher dimensional bulk in which our brain exists lies beyond our direct observational reach. We can test the implications of these theories indirectly, through their predictions about particle physics or the specific patterns in cosmic microwave background radiation, but direct confirmation remains elusive. This gap between mathematical, beauty, and empirical verification highlights a deeper question about the nature of physical reality. Is the universe fundamentally mathematical? Do we discover mathematical relationships in nature? Or do we invent mathematical frameworks to describe what we observe? The remarkable effectiveness of mathematics in describing physical reality, what Nobel physicist Eugene Wigner called the unreasonable effectiveness of mathematics in the natural sciences, suggests a profound connection between mathematical structures and physical existence. Perhaps the universe isn't just described by mathematics, but is mathematics, a vast network of relationships that we experience as matter, energy, space, and time. If reality is fundamentally mathematical, then the universe's first second would represent not the creation of physical stuff, but the instantiation of a particular mathematical structure, a set of relationships that would gradually unfold into the cosmos we observe. Creation wouldn't be about making something from nothing, but about selecting a specific mathematical framework from a vast landscape of possibilities, one whose inherent fertility would allow it to evolve the remarkable complexity we observe. In today's universe, this mathematical perspective transforms our understanding of the singularity problem. The initial conditions of our universe wouldn't be a physical state of infinite density and temperature, but a mathematical seed, a set of equations whose solutions would describe the subsequent evolution of the cosmos. The singularity wouldn't be something that existed in physical reality, but a boundary in our mathematical description, a point where certain formulations break down and must be replaced by more comprehensive frameworks. But let's move beyond the singularity to explore another profound mystery of cosmic origins, the nature of time itself. We typically imagine time as a universal flow, a cosmic river carrying all existence from past to future at a uniform rate. The universe's first second, in this view, would mark the beginning of this temporal flow, the first tick of the cosmic clock. But Einstein's relativity reveals a far stranger picture. Time is relative, varying with motion and gravity, stretching and compressing like an elastic fabric rather than flowing at a constant rate. Near massive objects, time slows down, relative to regions with weaker gravity, a phenomenon called gravitational time dilation. This isn't a theoretical abstraction, but an experimentally verified fact, measurable even across the modest gravitational gradient between your head and your feet. In the extreme conditions of the early universe, with all matter compressed to incredible densities, these relativistic effects would have been dramatically amplified. Time itself would have run at a different rate, dilated by the immense gravitational effects of all reality compressed to subatomic scales. Imagine reality as a cosmic film reel again, but this time with variable frame rates. In today's universe, far from massive objects, the film runs at a standard speed, each second of objective time containing the same number of frames. But near black holes or in the early universe, the frame rate increases dramatically, each second stretching to contain many more moments, more frames of reality. The first second of the universe, measured by a hypothetical clock in those conditions, would contain far more physical events, more cosmic evolution than a second today. The universe wouldn't just have been younger, it would have experienced time differently. This temporal dilation transforms our understanding of cosmic evolution. The early universe didn't just differ from our current cosmos in its density and temperature, but in its temporal texture, in how quickly or slowly processes unfolded relative to today's standards. When cosmologists calculate the sequence of events during the universe's first moments, they're accounting not just for different physical conditions, but for a fundamentally different relationship with time itself. The cosmic clock didn't just read a different time in the past, it ran at a different rate, governed by different rules. But relativity suggests an even more profound transformation in our understanding of time. Past, present, and future may exist simultaneously in a four-dimensional block universe. In this view, inspired by the mathematics of relativity, time doesn't flow at all. All moments, past, present, and future, exist together in a four-dimensional manifold called space-time. What we experience as the flow of time may be an illusion produced by our consciousness moving through this fixed landscape of events, like a spotlight illuminating different sections of an already existing terrain. Imagine reality as a vast cosmic library where each book represents a moment in time and all books exist simultaneously on the shelves. Our consciousness reads these books in a particular order, creating the illusion of temporal flow. But the entire library, all of cosmic history, exists at once. In this view, the universe's first second wouldn't be something that happened in the distant past, but something that exists at one end of this four-dimensional structure, as real and present as the moment you're experiencing now, just located at a different coordinate in the space-time manifold. This block universe perspective transforms our understanding of cosmic origins. The beginning of the universe wouldn't be an event that happened and then finished, but a region of the space-time manifold that continues to exist, just at different coordinates than our current position. Creation wouldn't be a process completed in the past, but an aspect of a four-dimensional whole that exists timelessly. The universe wouldn't have come into being at the Big Bang. It would exist as a complete four-dimensional entity, with the Big Bang representing one boundary of this structure rather than a moment of creation. But the block universe view, compelling as it may be mathematically, leaves profound questions unanswered. If all of space-time exists as a fixed four-dimensional structure, what determines the specific configuration of this structure? Why this particular arrangement of matter and energy across space-time rather than another? And most profoundly, if time doesn't flow, why do we experience it as flowing, with a distinct difference between past and future, with entropy increasing in one direction but not the other? This leads us to another cosmic mystery, the arrow of time. Unlike space, which allows movement in any direction, time in our experience has a definite direction, from past to future, from lower to higher entropy, from cause to effect. We remember the past, but not the future. Eggs break, but don't spontaneously reassemble. Coffee cools, but doesn't spontaneously heat up. This temporal asymmetry, this arrow pointing from past to future, represents one of physics' deepest puzzles, especially since the fundamental laws of physics work equally well running forward or backward in time. In the universe's first second, this temporal arrow may have emerged from the incredibly low entropy conditions of the early cosmos. Entropy, roughly, the measure of disorder or randomness in a system, was remarkably low at the Big Bang, with all matter and energy compressed into an extraordinarily uniform, homogeneous state. This initial low entropy represents a cosmic mystery in itself. Why did the universe begin in such an improbable, highly ordered state? From this initial condition, the second law of thermodynamics ensures that entropy would increase over time, establishing a direction to cosmic evolution and giving rise to the arrow of time we experience. Imagine the universe as a vast cosmic game of billiards with particles as balls on the table. In today's universe, the balls are scattered across the table in a high-entropy arrangement. Run the cosmic film backward, and they would converge with perfect precision to a highly ordered, low-entropy state at the Big Bang. Like billiard balls scattered across a table, mysteriously rolling backward to form a perfect triangle. The probability of this happening by chance is vanishingly small, suggesting that something fundamental about the universe's initial conditions established this temporal asymmetry. This entropy gradient transforms our understanding of cosmic evolution. The universe doesn't just change over time, it changes in a specific direction, from lower to higher entropy, from more ordered to less ordered states. This directional change isn't imposed from outside, but emerges from the universe's initial conditions, from the remarkably low entropy state established in its first moments. The arrow of time points from past to future, not because of some external flow, but because of this built-in entropy gradient, this inherent tendency toward increasing disorder encoded in the cosmos from its first second. But why was entropy so low at the beginning? This question, sometimes called the past hypothesis problem, represents one of cosmology's deepest mysteries. In a universe governed by the second law of thermodynamics, high-entropy states are vastly more probable than low-entropy ones. The incredibly low entropy of the early universe seems profoundly improbable, like air in a room spontaneously gathering in one corner rather than spreading evenly throughout. What set these special initial conditions? Some theorists suggest that the low entropy of the early universe reflects specific aspects of gravity. While most physical systems increase their entropy by spreading out, like gas filling a container, gravitational systems can increase entropy by clumping together, like matter forming stars and galaxies. The uniformly spread matter of the early universe, counterintuitively, represents a low entropy state for gravity, with the subsequent formation of cosmic structure corresponding to increasing gravitational entropy. This perspective connects the arrow of time to the fundamental nature of gravity itself, to how mass and energy interact with the fabric of space-time. Others propose more speculative solutions, suggesting that our observable universe represents a fluctuation within a much larger multiverse that exists in an overall state of maximum entropy or heat death. Just as random molecular motions can occasionally bring all air molecules to one side of a room, though the probability is vanishingly small, quantum fluctuations in an eternal multiverse might occasionally produce low-entropy regions like our observable cosmos. Our universe would be a rare fluctuation, a temporary deviation from equilibrium, with the arrow of time reflecting our location within this improbable bubble of order. This multiverse perspective transforms our understanding of cosmic origins. The universe's first second wouldn't represent the beginning of all reality, but the beginning of a fluctuation within a much larger, much older reality that exists in a state of thermal equilibrium. Our cosmic domain, with its apparent order and evolution, would be a temporary excursion from this equilibrium, a rare bubble of decreasing entropy in a vast sea of maximum entropy. The beginning of our universe wouldn't be the beginning of everything, but the beginning of an improbable fluctuation within an eternal backdrop. But these multiverse scenarios come with profound philosophical implications. If our universe is just one fluctuation among countless others in an eternal multiverse, why does it exhibit such precise fine-tuning for complexity and life? Why aren't we in a much smaller fluctuation, just large enough to contain a conscious observer. Since smaller, fluctuations are exponentially more probable than larger ones? These questions have led some theorists to propose controversial solutions involving Boltzmann brains, disembodied consciousnesses arising from random fluctuations, and observer selection effects, highlighting the philosophical complexities that emerge when we push our theories to their logical conclusions. Let's step back from these speculative frontiers to explore another profound mystery of cosmic origins: vacuum energy and cosmic inflation. In the standard model of cosmology, the universe underwent a brief period of exponential expansion, inflation, during its first fraction of a second, increasing in volume by a factor of at least 10^78 in less than 10^32 seconds. This expansion, far faster than the speed of light, though not violating relativistic principles since it's space itself that's expanding, was driven by the energy of the vacuum in a specific quantum field called the inflaton field. Imagine the universe as a vast quantum landscape, with different regions corresponding to different energy states of the vacuum. The early cosmos occupied a false vacuum state, a configuration that appeared stable but actually contained latent energy, like water cooled below freezing but not yet crystallized into ice. As the universe transitioned from this false vacuum to a lower energy, true vacuum state, the latent energy was released, driving the exponential expansion of space itself. This process, called vacuum decay, transformed the potential energy of the quantum vacuum into the kinetic energy of spatial expansion, stretching the fabric of reality faster than light could travel within it. This inflationary scenario transforms our understanding of the universe's first second. The beginning wouldn't just involve the expansion of a hot, dense plasma, but a quantum phase transition, a change in the state of the vacuum itself. The energy driving this initial expansion wouldn't come from matter or radiation, but from the intrinsic energy of space, from the difference in energy between false and true vacuum states. The Big Bang wouldn't be an explosion of matter into pre-existing space, but a transformation of the vacuum itself, a shift in the fundamental state of reality that released enormous energy and drove exponential expansion. Inflation also transforms our understanding of cosmic structure. The quantum fluctuations in the inflaton field, magnified by the exponential expansion, became the seeds of all cosmic structure, the blueprint for everything from galaxies to galaxy clusters to the precise spot where you're sitting right now. The largest structures in today's universe originated as quantum jitters in the early cosmos, microscopic variations stretched to macroscopic scales by inflation. Without these quantum fluctuations and their inflationary amplification, the universe would have remained perfectly uniform, incapable of forming stars, planets, or people. But inflation comes with profound implications and unresolved questions. The theory suggests that inflation likely never ended completely, but continues eternally in regions beyond our cosmic horizon, with our observable universe representing just one bubble where inflation happened to stop. In this eternal inflation scenario, new universe bubbles are constantly nucleating from the inflationary field, each with potentially different physical laws and constants. Our cosmic domain would be just one bubble in an infinite, eternally inflating multiverse, with most of reality existing in a state of exponential expansion beyond our observational reach. This eternal inflation scenario transforms our understanding of cosmic origins. The universe's first second wouldn't represent the beginning of all reality, but the beginning of our specific cosmic bubble, our local domain where inflation happened to end. The true history of existence would extend far beyond our observable horizon, perhaps infinitely into the past, with new universe bubbles constantly forming in the ever-expanding inflationary sea. Creation wouldn't be a singular event, but an ongoing process, producing new cosmic domains like an endless fountain of universes, each with its own unique characteristics. But eternal inflation raises profound questions about testability and scientific methodology. If most of reality exists beyond our cosmic horizon, permanently inaccessible to observation, how can we test theories about this larger multiverse? Are multiverse theories even scientific if they make predictions about domains we can never observe? These questions highlight the boundary between physics and metaphysics, between empirically testable science and philosophical speculation. They remind us that our theories about cosmic origins inevitably push against the limits of what can be known through observation and experiment. Despite these philosophical challenges, inflation remains the most widely accepted theory for the universe's earliest moments, supported by multiple lines of observational evidence. The remarkable uniformity of the cosmic microwave background radiation, the flatness of space, the absence of magnetic monopoles, and the specific pattern of density fluctuations in the early universe all align with inflationary predictions. The theory doesn't just explain these observations, but connects them through a single mechanism, providing a unified account of otherwise puzzling cosmic features. Let's explore another profound mystery of cosmic origins: the matter-antimatter asymmetry. According to our current understanding of particle physics, the early universe should have produced equal amounts of matter and antimatter, which would have completely annihilated each other as the cosmos cooled, leaving nothing but radiation. No stars, no planets, no people. Yet here we are, in a universe dominated by matter, with very little antimatter to be found. Something in the universe's first second must have created a tiny imbalance, a slight preference for matter over antimatter, about one extra matter particle for every billion matter-antimatter pairs. Imagine the early universe as a vast cosmic casino, with particle-antiparticle pairs constantly being created and destroyed in the intense heat. If the rules of the game were perfectly fair, matter and antimatter would be created in equal amounts, and all particles would eventually find their antiparticle partners and annihilate, leaving nothing but pure radiation. But the cosmic casino seems to have been slightly rigged, with a tiny bias favoring matter over antimatter. This slight asymmetry, this cosmic favoritism, is why matter remains after the Great Annihilation, why structure could form, why we exist at all. This matter-antimatter asymmetry transforms our understanding of cosmic evolution. The universe's ability to form structure, to evolve complexity, to produce life, all depend on this tiny imbalance established in its first moments. Without this asymmetry, the cosmos would contain nothing but radiation. No galaxies, no stars, no planets, no people. The fact that we exist to contemplate these questions is itself evidence of a fundamental imbalance woven into the fabric of reality, a slight bias encoded in the universe's initial conditions or in the laws of physics themselves. Various mechanisms have been proposed to explain this asymmetry, all requiring special conditions during the universe's first second. One possibility involves CP violation, a subtle asymmetry in how certain particles and their antiparticles behave. Another involves leptogenesis, the creation of an imbalance in lepton particles that gets transferred to quarks through high-temperature processes in the early universe. A third involves baryogenesis, the direct production of an excess of baryons, like protons and neutrons, over antibaryons through out-of-equilibrium processes during phase transitions in the early cosmos. These mechanisms share certain requirements. Articulated by physicist Andrei Sakharov in 1967, the early universe must have had processes that violate baryon number conservation, that violate C and CP symmetry, treating particles and antiparticles differently, and that occur out of thermal equilibrium These conditions might have been met during specific phase transitions in the early cosmos, moments when the universe cooled below critical thresholds and fundamental properties of reality changed, like water freezing into ice but affecting the fabric of existence itself. This connection between phase transitions and matter-antimatter asymmetry highlights a profound truth. The universe as we know it, with its specific properties and possibilities, crystallized from a landscape of potentials during its first moments. The cosmos wasn't just born. It was forged through a series of transitions, each establishing certain features of reality as the universe expanded and cooled. The specific outcome of these transitions, including the slight preference for matter over antimatter, determined the entire subsequent history of cosmic evolution. But the origin of this asymmetry remains one of physics' greatest unsolved mysteries. The standard model of particle physics, extraordinarily successful in other domains, cannot fully explain the observed matter dominance. The CP violation it includes is far too small to account for the matter excess we observe. This gap between theory and observation suggests that new physics, beyond the standard model, must have played a role in the universe's first moments, establishing the cosmic bias toward matter that allowed structure to form and life to evolve. This search for physics beyond the standard model connects the mystery of matter-antimatter asymmetry to other profound questions in fundamental physics: the nature of dark matter, the origin of neutrino masses, the unification of forces at high energies. The universe's first second serves as a laboratory for testing theories that address these questions, a domain where the extreme conditions would have revealed aspects of physics invisible at the lower energies accessible to our particle accelerators. By studying the cosmic consequences of different theoretical frameworks, scientists can indirectly probe physics at energy scales far beyond our experimental reach. Let's explore yet another profound mystery of cosmic origins: the nature of dark matter and dark energy. According to current observations, ordinary matter, the stuff of atoms, stars, and people, constitutes only about 5% of the cosmic energy budget. The remaining 95% consists of dark matter, about 25%, and dark energy, about 70%, components that don't interact with light and are known primarily through their gravitational effects. These dark components appear to have played crucial roles in cosmic evolution, with dark matter providing the gravitational scaffolding for structure formation and dark energy driving the accelerated expansion observed in recent cosmic history. Imagine the universe as a vast cosmic sea, with ordinary matter like foam on the surface, visible but constituting only a tiny fraction of the whole. The bulk of this sea consists of components we cannot directly observe: dark matter forming invisible currents that guide the formation of structure, and dark energy creating a uniform pressure that drives the accelerating expansion of the cosmos. These dark components don't just fill the universe, they shape its evolution, determining how structure forms and how space itself expands over time. This dark universe transforms our understanding of cosmic evolution. The visible cosmos, stars, galaxies, gas clouds, represents just the luminous tip of a vast dark iceberg. The formation of structure, the clustering of galaxies, the dynamics of cosmic expansion, all are governed primarily by components we cannot directly see or touch. The universe's first second established not just the properties of ordinary matter, but the nature and abundance of these dark components, setting the stage for their dominant role in subsequent cosmic history. Dark matter appears to have played a particularly crucial role in the early universe. While ordinary matter remained too hot to clump together, dark matter, interacting only through gravity and perhaps the weak nuclear force, could begin forming gravitational wells immediately after decoupling from the primordial plasma. These dark matter concentrations created the scaffolding within which ordinary matter would later condense to form galaxies and stars. Without dark matter, structure formation would have proceeded much more slowly, potentially too slowly, for galaxies to form before dark energy began driving accelerated expansion, tearing potential protogalaxies apart. The specific nature of dark matter remains one of physics's great unsolved mysteries. Various candidates have been proposed, from weakly interacting massive particles, WIMPs, to axions to sterile neutrinos, each with different implications for how dark matter behaved in the universe's first moments. The abundance of dark matter, today about 5 times that of ordinary matter, was established during the universe's first second, either through thermal processes similar to those that produced ordinary particles, or through non-thermal mechanisms involving physics beyond the standard model. Dark energy presents an even deeper mystery. Unlike dark matter, which clusters gravitationally and played a crucial role from the early universe onward, dark energy appears to be uniformly distributed across space and became dynamically significant only in relatively recent cosmic history, about 5 billion years ago. Its nature remains profoundly mysterious. It might represent the vacuum energy of empty space, a dynamic field called quintessence, or a modification to general relativity at cosmic scales. Whatever its nature, dark energy now dominates the cosmic energy budget and determines the universe's long-term fate. The existence of dark energy transforms our understanding of cosmic destiny. Before its discovery in 1998, cosmologists generally assumed that the universe's expansion would eventually slow due to the gravitational attraction of matter, either reaching a maximum size and then recontracting in a closed universe, or expanding forever at an ever-decreasing rate in an open universe. Dark energy changes this picture dramatically, driving an acceleration of cosmic expansion that will eventually isolate galaxies from one another, ending the universe not with a big crunch, but with a big freeze, a cold, dark, ever-expanding cosmos where gravitationally bound structures become increasingly isolated in an exponentially expanding void. This cosmic acceleration raises profound questions about the ultimate fate of information and complexity in our universe. As expansion accelerates, galaxies beyond our local group will eventually recede faster than light, due to the expansion of space itself rather than motion through space, disappearing beyond our cosmic horizon. In the far future, observers would see only their local galaxy group, with the rest of the universe having disappeared beyond the horizon. Eventually, even stars would burn out. Black holes would evaporate through Hawking radiation, and the cosmos would approach a state of maximum entropy, a heat death where no further work or complexity is possible. This eventual heat death transforms our understanding of cosmic history. The universe's story wouldn't be open-ended, but would have a beginning, a middle, and an end. From the intense activity of the Big Bang, through the formation of structure and the emergence of complexity, to the eventual dissolution of all structure in an ever-expanding, ever-cooling void. The window of opportunity for complexity, for life, for consciousness, would be finite. A temporary excursion from equilibrium in a cosmos ultimately dominated by entropy's inexorable increase. But there's a striking asymmetry in this cosmic narrative. Why was the universe's beginning so different from its projected end? The early cosmos was extraordinarily hot, dense, and low entropy. The far future appears to be cold, diffuse, and high entropy. This temporal asymmetry, this profound difference between past and future boundary conditions, represents one of cosmology's deepest mysteries. Why did the universe begin in such a special, improbable state rather than in something closer to thermal equilibrium? Some theorists suggest that this asymmetry reflects a fundamental directionality in cosmic evolution, a built-in arrow of time pointing from low to high entropy, from simplicity to complexity to dissolution. Others propose more speculative solutions, suggesting that our observable universe represents half of a larger symmetric structure, with the Big Bang as a middle point rather than a beginning, a cosmic bounce connecting a contracting phase to our expanding one, with similar conditions on either side of the bounce. Still others suggest that the apparent specialness of the universe's initial conditions reflects a selection effect. We observe these conditions because they're necessary for observers like us to evolve. These different perspectives highlight a profound philosophical question underlying all our theories of cosmic origins. What constitutes an explanation for the universe's beginning? Is it enough to describe the processes involved? To reconstruct the sequence of events during the universe's first second? Or must we also explain why these specific processes occurred? Why the universe began with these particular properties rather than others? And most profoundly, can science ever fully explain the existence of the universe itself? Or will there always remain an irreducible mystery at the foundation of reality? Let's explore another profound aspect of cosmic origins: the emergence of space and time themselves. In classical general relativity, space-time is treated as a fundamental entity, the stage upon which cosmic drama unfolds. But various approaches to quantum gravity suggest that space-time might not be fundamental, but emergent, a macroscopic phenomenon arising from deeper quantum processes, like temperature emerges from the collective motion of atoms, rather than being a property of individual particles. The universe's first second might represent not just events occurring within space-time, but the emergence of space-time itself from more fundamental quantum structures. Imagine reality as a vast cosmic tapestry, with space-time as the visible pattern on the surface. This pattern doesn't exist independently of the threads that form it. It emerges from their relationships, from how they're woven together. In the universe's first moment, it wouldn't be just matter and energy emerging within pre-existing space and time, but space and time themselves crystallizing from more fundamental quantum relationships. The beginning wouldn't be a point in space-time, but the genesis of space-time itself from deeper structures. Different approaches to quantum gravity suggest different pictures of how space-time might emerge. In loop quantum gravity, space is built from spin networks, quantum graphs, whose nodes represent volumes and whose edges represent surfaces. Time emerges from the evolution of these networks from one quantum state to another. In causal set theory, space-time emerges from discrete events connected by causal relationships, like nodes in a vast network linked by cause and effect connections. In string theory, space-time emerges from the collective behavior of strings vibrating in a higher dimensional space, with our familiar 4 dimensions representing a subset of this more complex geometry. These approaches share a common implication. The smooth, continuous space-time we experience in daily life is an approximation, valid at macroscopic scales, but breaking down at the quantum level. Near the Big Bang, with all reality compressed to subatomic scales, these quantum aspects of space-time would have dominated. The universe's first second wouldn't just involve extreme conditions within space and time, but would represent the transition from quantum space-time to classical space-time, from discrete quantum structures to the smooth continuum described by general relativity. This quantum to classical transition transforms our understanding of cosmic origins. The beginning wouldn't be a singularity within space-time, but the emergence of classical space-time itself from quantum precursors. There would be no moment before the Big Bang in the conventional sense, because time as we understand it emerges, along with space in this transition. Questions about what happened before the beginning become category errors. like asking about the temperature of a mathematical equation or the color of a sound wave. They assume the existence of temporal relationships in a domain where time itself has not yet fully emerged. But if time emerges from more fundamental quantum structures, does this mean that causality itself, the relationship between cause and effect, is emergent rather than fundamental? Some approaches to quantum gravity suggest that causal relationships are built into the foundations of reality, with quantum events connected by causal links that determine their temporal ordering. Others suggest that causality, as we understand it, emerges only at the classical level, with quantum reality exhibiting more complex, non-local relationships that don't reduce to simple cause and effect sequences. This question of fundamental versus emergent causality transforms our understanding of creation itself. If causality emerges along with space-time, then the universe's beginning wouldn't be caused in the conventional sense. It would represent the emergence of the very framework within which causal relationships operate. Creation wouldn't be an totritu, event within a causal sequence, but the genesis of causality itself, the crystallization of the very notion of before and after from quantum structures that don't inherently contain these temporal distinctions. These ideas about emergent space-time and causality lie at the frontier of theoretical physics, where established theories reach their limits and new mathematical frameworks attempt to venture beyond. They remind us that our understanding of cosmic origins inevitably pushes against the boundaries of what our current theories can describe, requiring new concepts and new mathematics to venture into domains where conventional notions of space, time, and causality break down. Imagine reality as an ocean with our familiar four-dimensional space-time as the surface waves. These waves, the phenomena we directly experience, aren't separate from the ocean but patterns within it, emergent behaviors of a deeper reality. The universe's first second wouldn't represent just the beginning of the waves, but their emergence. From the quantum depths, from modes of existence that don't intrinsically contain our familiar notions of here and now, before and after. Creation would be less like an event in time and more like a phase transition, a crystallization of familiar patterns from a more alien quantum substrate. This perspective transforms our understanding of the universe's beginning from a temporal origin to a boundary of comprehension, a horizon beyond which our conventional concepts lose their meaning. The Big Bang wouldn't be the first moment in time, but the edge of time itself, the boundary where temporal concepts emerge from timeless quantum foundations. Creation wouldn't happen at a specific moment, but would represent the very genesis of moments, the crystallization of temporality from a reality that doesn't inherently contain it. But if space-time emerges from more fundamental quantum structures, what triggers this emergence? What causes the quantum-to-classical transition that gives rise to our familiar four-dimensional reality? Various theories suggest different mechanisms, from decoherence, the process by which quantum systems lose their coherence through interactions with their environment, to spontaneous collapse, the idea that quantum states naturally collapse to classical ones when they involve sufficient mass or complexity. These mechanisms wouldn't just determine how quantum systems behave, but would shape the very emergence of space-time itself from its quantum precursors. Some approaches to quantum gravity suggest that observation itself, the interaction between systems that allows one to register information about another, plays a crucial role in this emergence. The classical world wouldn't exist independently of observation, but would crystallize through the information-exchanging relationships between quantum systems. Space-time wouldn't be a pre-existing stage upon which cosmic drama unfolds, but would emerge from the network of informational relationships between quantum events, from how physical systems registering information about one another. This connection between information, observation, and the emergence of space-time transforms our understanding of cosmic origins. The universe's first second wouldn't just involve the appearance of matter and energy within space and time, but the crystallization of observable reality itself through primordial information processing relationships. The beginning wouldn't be the creation of stuff, but the genesis of relationships, of the informational connections that give rise to what we call reality. Creation would be less like making something from nothing and more like establishing the foundational relationships from which everything else would emerge. These ideas about information and the emergence of reality connect to another profound cosmic mystery, the holographic principle. Inspired by the physics of black holes, this principle suggests that all the information contained in a volume of space can be encoded on its boundary, like a three-dimensional hologram emerging from a two-dimensional surface. Applied to cosmology, this suggests that our entire four-dimensional universe might be encoded on a lower-dimensional boundary, with our familiar space-time emerging holographically from this more fundamental description. Imagine reality as a cosmic hologram with our four-dimensional universe projected from information encoded on a three-dimensional surface, or perhaps from an even more fundamental two-dimensional description. The universe's first second wouldn't represent just the beginning of events within space-time, but the initial projection of the hologram itself, the emergence of our four-dimensional reality from its lower-dimensional encoding. Creation wouldn't involve making a four-dimensional something from nothing, but would represent the holographic manifestation of information encoded at a more fundamental level. This holographic perspective transforms our understanding of cosmic origins. The beginning wouldn't be the creation of space, time, matter, and energy from nothing but the emergence of these familiar aspects of reality from a more fundamental holographic encoding. The universe's first second would represent not just extreme conditions within space-time, but the genesis of space-time itself from its holographic foundations. Creation would be less about making something from nothing and more about the unfolding of potential already encoded in the holographic boundary. The holographic principle connects to broader questions about the nature of information and its role in physical reality. Some theorists suggest that information isn't just something encoded in physical systems, but maybe even more fundamental than matter, energy, space, or time. In this it-from-bit perspective, articulated by physicist John Wheeler, physical reality emerges from information rather than information emerging from physical reality. The universe wouldn't be made of stuff that processes and encodes information, but of information itself, manifesting as what we perceive as matter, energy, space, and time. If reality is fundamentally informational, then the universe's first second would represent not the creation of physical stuff, but the initial processing of cosmic information, the first computation in an ongoing calculation that manifests as our physical universe. Creation wouldn't involve making something from nothing, but would represent the activation of an information processing system, the beginning of a vast cosmic computation whose output we experience as reality. The universe wouldn't be a thing, but a process, a computation unfolding across cosmic history. This computational perspective transforms our understanding of cosmic evolution, the formation of structure, the emergence of complexity, the development of life and consciousness, all would represent aspects of this ongoing cosmic computation. Different patterns processing different types of information at different scales. The universe wouldn't just happen to support computation. It would be a computation, with physical laws representing the algorithms that govern this vast cosmic calculation. Our consciousness, our ability to process information and construct internal models of reality, would be a local intensification of this universal process, the cosmos computing itself through beings evolved within it. But if the universe is Fundamentally informational or computational, what is the purpose of this vast cosmic calculation? What problem is it solving? What question is it answering? What function is it computing? These questions push us beyond physics into deeper philosophical territories. Perhaps the universe isn't calculating anything external to itself, but is a self-contained computation, its own input, process, and output. Perhaps physical reality is a vast exploration of mathematical possibility, a working out of what happens when certain fundamental principles are allowed to unfold across cosmic history. Perhaps the universe computes itself into increasing complexity simply because that's what complex information processing systems naturally do when governed by the right algorithms. These speculations about information, computation, and the fundamental nature of reality might seem far removed from the empirical foundations of science. But they emerge naturally from our best current theories, from attempts to reconcile quantum mechanics with general relativity, from efforts to understand the holographic principle implied by black hole thermodynamics. They remind us that our understanding of cosmic origins inevitably leads to deep questions about the nature of reality itself, about what existence fundamentally is beneath the appearances we directly observe. Let's explore another profound aspect of cosmic origins, the nature of natural laws themselves. We typically imagine the laws of physics as immutable, eternal truths that govern the cosmos from outside, like rules imposed on a game. In this view, the universe's first second would unfold according to these pre-existing laws, with physical processes following mathematical principles established independently of the cosmic evolution they govern. But what if the laws of physics aren't imposed from outside but emerge from within, crystallizing along with the universe itself? Some theorists suggest that what we call the laws of nature are really just patterns that precipitated as the universe expanded and cooled, like the crystalline structure of a snowflake emerges from the properties of water molecules under specific conditions. These laws wouldn't be eternal truths existing independently of the cosmos, but would emerge from the self-organizing properties of reality itself, from how the fundamental constituents of existence interact under different conditions. The universe wouldn't be governed by laws so much as it would manifest them through its own evolution. Imagine reality as a vast phase diagram with different regions corresponding to different emergent laws and properties. The early universe, with its extreme temperature and density, would occupy a domain with its own specific patterns and regularities. As the cosmos expanded and cooled, it would transition through different phases, each with its own emergent laws. What we call the laws of physics wouldn't be imposed from outside, but would crystallize from within as the universe evolved, like different types of ice forming at different temperatures and pressures. This perspective transforms our understanding of cosmic origins. The universe's first second wouldn't just establish the initial conditions for cosmic evolution, but would represent the emergence of the very laws that govern this evolution. The fundamental forces, the properties of particles, the relationships we capture in mathematical equations, all would crystallize during cosmic history rather than existing independently of it. Creation wouldn't just involve the emergence of matter and energy within space and time, but the genesis of the very patterns we call natural laws. This emergent view of natural laws connects to broader questions about the relationship between mathematics and physical reality. If the laws of physics emerge from cosmic evolution rather than governing it from outside, does this mean that mathematics itself is emergent rather than fundamental? Or does it suggest that only certain mathematical structures can be physically realized, with the universe selectively manifesting specific patterns from a vast landscape of mathematical possibility? These questions highlight the profound interplay between the physical and the mathematical, between what happens and what can be mathematically described. Some theorists propose that the laws of physics might have evolved through a process analogous to natural selection. In eternal inflation scenarios, different universe bubbles might have slightly different properties, with some configurations more conducive to ongoing expansion and complexity than others. Universes with stable, consistent laws capable of supporting the emergence of structure would tend to be more prevalent in the multiverse than those with unstable or contradictory laws. The specific laws we observe wouldn't be arbitrary or random, but would reflect a selection process operating at the cosmic scale, favoring certain configurations over others. This cosmological natural selection transforms our understanding of cosmic fine-tuning, the remarkable precision of physical constants, the exquisite balance of forces, the specific properties of particles that allow for complexity and life, all might reflect not design or extraordinary coincidence, but the outcome of an evolutionary process operating beyond our cosmic horizon. The universe wouldn't be fine-tuned for complexity and life by design, but through a process analogous to biological evolution, with cosmic domains that produce more offspring, through black holes or other mechanisms, becoming more numerous in the ensemble of universes. But these speculations about emergent laws and cosmological natural selection raise profound questions about testability and scientific methodology. If the laws of physics emerged during cosmic evolution rather than existing independently of it, how can we test this hypothesis when we only have access to the current phase of cosmic history? If cosmological natural selection operates beyond our cosmic horizon, how can we verify its existence when we can only observe our local universe? These questions highlight the boundary between physics and metaphysics, between empirically testable science and philosophical speculation about ultimate reality. Let's explore a final profound mystery of cosmic origins, the emergence of complexity and consciousness. The universe began in an extraordinarily simple state, a hot, dense, nearly uniform plasma without structure or differentiation. Yet it evolved into the remarkably complex cosmos we observe today, with galaxies, stars, planets, living organisms, and conscious minds capable of contemplating their own origins. This trajectory from primordial simplicity to organized complexity represents one of the deepest mysteries in our understanding of cosmic evolution. Imagine the universe as a vast information processing system, beginning with minimal informational content, the nearly uniform early cosmos, and gradually developing more complex patterns through physical processes governed by fundamental laws. Gravity would pull matter into clumps, forming stars and galaxies. Nuclear fusion within stars would forge heavier elements, increasing the chemical complexity of the cosmos. On at least one planet, these elements would combine into organic molecules, cells, organisms, ecosystems, and eventually conscious beings capable of recognizing patterns, constructing models, and processing information in increasingly sophisticated ways. This emergence of complexity transforms our understanding of cosmic purpose. The universe wouldn't have been designed for complexity, but would have an inherent tendency to develop it under certain conditions, like water flowing downhill or heat flowing from hot to cold. Complexity wouldn't be imposed from outside, but would emerge naturally from the interaction of simple components following simple rules, from the self-organizing properties of matter and energy governed by fundamental forces. The cosmos wouldn't need external guidance to develop complexity. It would be built into the mathematical structure of reality itself. But there's something striking about this trajectory from simplicity to complexity. It seems to run counter to the second law of thermodynamics, which states that entropy, roughly, the measure of disorder, increases over time in closed systems. How can a universe governed by entropy's inexorable increase also develop the remarkable order and structure we observe around us? This apparent contradiction is resolved when we recognize that while entropy increases globally, it can decrease locally in open systems that receive energy from their environment. The Earth, for instance, maintains and increases its complexity by absorbing ordered energy from the Sun and radiating disordered energy back to space, with the total entropy of the Earth-Sun system increasing even as biological complexity on Earth grows. This balance between entropy and complexity transforms our understanding of cosmic evolution. The universe doesn't develop complexity despite the second law of thermodynamics, but because of it, through processes that increase total entropy while creating local pockets of decreased entropy and increased organization. Stars wouldn't just happen to provide the energy needed for life and complexity. They would be entropy-generating engines whose very operation creates the necessary conditions for islands of complexity to emerge in a universe trending toward overall disorder. Complexity wouldn't violate physical law, but would represent a natural expression of how energy flows in a reality governed by fundamental forces. But the emergence of consciousness represents an even deeper mystery. How does aware experience, the subjective feeling of being something, of experiencing reality from the inside, arise from physical processes in the brain? This hard problem of consciousness, articulated by philosopher David Chalmers, highlights the explanatory gap between accounts of how neural systems process information and the reality of experienced awareness itself. We can describe in detail how brains encode and process data, but this doesn't seem to explain why these processes are accompanied by subjective experience rather than happening in the dark without awareness. Various theories attempt to bridge this explanatory gap. Some suggest that consciousness emerges when information is integrated in certain complex ways, with awareness reflecting the unified informational structure created by neural processes. Others propose that consciousness is fundamental rather than emergent, with physical systems manifesting an intrinsic proto-consciousness that becomes more complex and self-reflective in certain organized systems like brains. Still others suggest that consciousness represents a higher dimensional projection of lower dimensional physical processes, with subjective experience reflecting how information is encoded across dimensions beyond our direct perception. These different approaches to the hard problem of consciousness transform our understanding of cosmic evolution. If consciousness emerges from certain types of information processing, then the universe's trajectory from simplicity to complexity would also represent an evolution toward greater awareness, with consciousness as a natural outgrowth of cosmic self-organization. If consciousness is fundamental, then the universe wouldn't just happen to develop awareness through cosmic evolution, but would be aware in some sense from the beginning, with primitive experientiality present even in the simplest physical systems. If consciousness reflects higher dimensional processes, then aware experience would represent the universe accessing aspects of reality beyond the physical dimensions directly accessible to our instruments. This connection between cosmic evolution and consciousness raises profound questions about meaning and purpose. If the universe naturally evolves toward complexity and consciousness through processes encoded in its fundamental structure, does this suggest a directional aspect to cosmic history? A trajectory not just from past to future, but from simplicity to complexity, from unconsciousness to consciousness? Does the emergence of beings capable of understanding their own origins represent a random byproduct of cosmic evolution or a natural fulfillment of potential encoded in the universe from its first moments? These questions push us beyond conventional scientific inquiry into deeper philosophical territories. They remind us that our understanding of cosmic origins inevitably connects to broader questions about meaning and purpose, about our place within the cosmic story. The factual details of the universe's first second, as fascinating as they are, gain their deepest significance when integrated into our understanding of existence itself, when connected to the emergence of complexity and consciousness across cosmic history, to the remarkable fact that the universe has evolved beings capable of reconstructing their own origins. As we've explored these profound mysteries of cosmic origins, from the singularity to the nature of time, from vacuum energy to dark matter, from emergent space-time to the genesis of complexity and consciousness, we've repeatedly encountered the boundary between what we know and what we can only speculate about, between established science and philosophical conjecture. This boundary isn't a failure of scientific inquiry, but a natural consequence of the subject matter. The universe's first second lies at the edge of observable reality, requiring extrapolation from current physics into domains where our theories reach their limits and may need to be replaced by more comprehensive frameworks. This speculative aspect of cosmology doesn't diminish its scientific status, but highlights the evolving provisional nature of all scientific knowledge. Theories about cosmic origins aren't final answers but working models, approximations that capture certain aspects of reality while inevitably simplifying others. They represent our best current understanding, based on available evidence and mathematical consistency, but remain open to revision as new data emerges and new theoretical frameworks develop. The story of cosmic origins isn't written in stone, but continues to evolve as our understanding deepens and our observational tools improve. But despite this provisional nature, our current models of cosmic origins represent a remarkable achievement. Not just scientifically, but philosophically. They allow us to reconstruct, with increasing precision, events that occurred 13.8 billion years ago, to trace the evolution of the cosmos from its earliest moments to the present day, to understand how the conditions established in the universe's first second shaped everything that would follow. This reconstruction isn't just a triumph of physical understanding, but a philosophical watershed, a demonstration of the human mind's capacity to transcend its immediate circumstances and comprehend realities far beyond direct experience. 3. Universe's first second establishes the context for everything that follows, for the formation of galaxies and stars, for the synthesis of elements, for the emergence of planets and life, for the development of consciousness and understanding. It represents not just the beginning of cosmic history, but the foundation upon which all subsequent cosmic evolution builds. By understanding this crucial moment, we gain insight not just into where the universe came from, but into why it has the specific properties that allowed for the emergence of structure, complexity, and eventually beings like us, capable of contemplating our own origins. As we stand at the frontier of cosmic understanding, peering back toward the universe's first moments, we find ourselves confronting not just scientific questions, but philosophical ones. Not just how reality began, but why it exists at all, why it has the specific properties we observe, what its long-term trajectory might be. These questions remind us that cosmology isn't just about the mechanics of creation, but about the meaning of existence itself, about our place within the vast cosmic story that began in that crucial first second. In this exploration of cosmic mysteries, we've seen how each answer generates new questions, how each theoretical advance reveals new frontiers of ignorance. This isn't a failure of science, but its greatest strength, its capacity to continuously refine and extend our understanding, to approach truth asymptotically through successive approximations, to remain open to revision and expansion as new evidence emerges and new mathematical frameworks develop. The story of cosmic origins continues to evolve, not because previous understandings were wrong, but because reality is too rich, too complex to be captured fully in any single theory or framework. This evolving understanding reflects a profound Truth about knowledge itself. It isn't a fixed body of facts, but a living, growing relationship with reality. Our theories about cosmic origins aren't static descriptions, but dynamic models, continuously refined through the interplay between mathematical reasoning and observational evidence. They represent not the end of inquiry, but stations along a journey of understanding, provisional landing points that provide orientation while pointing toward deeper mysteries still to be explored. As we contemplate the mysteries of the universe's first second, we participate in a tradition of cosmic inquiry that stretches back to humanity's earliest days, to ancient myth-makers gazing at the stars, to philosophers contemplating the nature of existence, to scientists developing mathematical tools to model physical reality. This tradition reflects something fundamental about human consciousness: our capacity for wonder, for pattern recognition, for abstract reasoning, for constructing models of realities beyond direct experience. In exploring cosmic origins, we express what may be most distinctively human: our drive to understand our place within the larger reality that contains us. The universe's first second isn't just a subject of scientific investigation, but a mirror in which we glimpse aspects of ourselves: our capacity for wonder, our hunger for understanding, our ability to transcend immediate circumstances through mathematical abstraction and imaginative reconstruction. By contemplating cosmic origins, we don't just learn about the universe. We learn about consciousness itself, about the remarkable fact that reality has evolved beings capable of reconstructing their own genesis, of tracing their lineage back to the birth of time, space, matter, and energy in that crucial first moment. This recursive aspect of cosmic understanding, the universe comprehending itself through beings evolved within it, represents perhaps the most profound mystery of all. How remarkable that a cosmos born in simplicity could evolve such complexity. That matter and energy organized according to fundamental laws could develop the capacity for self-reflection. That a reality that began in that crucial first second could, billions of years later, develop the ability to reconstruct its own origins and contemplate its own existence. This capacity for self-understanding may represent not an accident or anomaly, but a natural fulfillment of potential encoded in the cosmos from its very beginning. As we venture deeper into the cosmic labyrinth, beyond the established theories and comfortable certainties, we encounter paradoxes so profound they shake the very foundations of our understanding. These aren't merely gaps in knowledge waiting to be filled, but fundamental contradictions that may reveal the limits of human comprehension itself. Like explorers reaching the edge of a map marked, "Here be dragons," we stand at the boundary where physics meets philosophy, where empirical science encounters questions it may never fully answer. These cosmic paradoxes don't just challenge what we know, they challenge how we know, forcing us to confront the possibility that reality may be stranger and more elusive than our theories can capture. The first of these profound paradoxes lurks at the very heart of quantum mechanics and general relativity, our two most successful physical theories, each extraordinarily precise in its domain, yet fundamentally incompatible with each other. Quantum mechanics describes the subatomic realm with unprecedented accuracy, revealing a reality of probabilities and possibilities, of particles that behave like waves, and waves that behave like particles, of properties that remain indeterminate until measured. General relativity, meanwhile, describes gravity as the curvature of space-time itself, providing a geometric understanding of the force that shapes cosmic structure. Both theories have been confirmed by countless experiments, yet they offer contradictory descriptions of reality that cannot be reconciled within our current understanding. This contradiction becomes unavoidable when we approach the universe's first moment. General relativity predicts a singularity, a point of infinite density and zero volume, where space-time curvature becomes infinite, and the equations break down. Quantum mechanics, however, forbids such infinities, suggesting that quantum effects must intervene before a true singularity can form. But we lack a comprehensive theory of quantum gravity that would tell us exactly how these quantum effects would manifest and what they would imply for cosmic origins. The beginning of the universe lies precisely at the intersection of the very large, described by general relativity, and the very small, described by quantum mechanics, a domain where neither theory alone provides a complete description. Imagine the universe as a vast book written in two different languages, the flowing script of general relativity and the discrete symbols of quantum mechanics. We can read and understand each language separately, but when they appear intertwined, as they must at the universe's beginning, we lack the bilingual fluency needed for complete comprehension. The first second of cosmic history requires a new language, a theory of quantum gravity, that would unite these seemingly incompatible descriptions into a coherent whole. Until we develop this language, our understanding of cosmic origins remains fundamentally incomplete, divided between frameworks that cannot be reconciled within our current physics. This incompatibility represents more than a technical challenge. It suggests that reality itself may be more complex, more multifaceted than any single theoretical framework can capture. Perhaps the universe doesn't conform to a single unified description, but requires multiple, complementary perspectives, like the wave and particle aspects of quantum entities, each revealing different facets of a reality too rich to be encompassed by any one model. The beginning wouldn't be described by either quantum mechanics or general relativity alone, but would require both perspectives, each illuminating aspects of a cosmic genesis too complex to be reduced to a single framework. This complementarity connects to a deeper philosophical question. Does mathematics discover patterns inherent in reality, or does it invent frameworks that we project onto the world? The unreasonable effectiveness of mathematics in the natural sciences, as physicist Eugene Wigner called it, suggests a profound connection between mathematical structures and physical reality. But the existence of multiple mathematically elegant theories that describe the same phenomena from different perspectives raises the possibility that this connection might be more complex than a simple correspondence between mathematical models and objective reality. Perhaps the universe isn't a single objective reality waiting to be discovered, but a multifaceted entity that reveals different aspects of itself depending on how we choose to observe and model it. The beginning wouldn't be an objective event that happened in a specific way, but would appear differently depending on which mathematical framework we use to reconstruct it. This perspective doesn't diminish the power or validity of scientific inquiry, but highlights its contextual nature. The way our descriptions of reality are inevitably shaped by the conceptual frameworks and mathematical languages we employ. This possibility connects to a fundamental paradox in quantum mechanics, the measurement problem. According to quantum theory, physical systems exist in superpositions of multiple possible states, with properties remaining indeterminate until measured. This suggests that observation itself plays a crucial role in determining reality, that the act of measurement somehow collapses quantum possibilities into definite outcomes. But what constitutes a measurement? Does it require a conscious observer, or can any physical interaction qualify? And if measurement is essential to determining reality, what happened in the early universe before measurement was possible? Imagine the universe in its earliest moments, when no observers existed to collapse quantum superpositions, when reality itself might have existed in a state of quantum indeterminacy. Would the cosmos have existed in a superposition of multiple possible configurations, with no definite properties until the first measurements occurred? Or does the universe somehow measure itself with physical interactions between particles and fields serving the role that conscious observation plays in laboratory experiments? These questions highlight the profound connection between observation, consciousness, and reality, between how we know and what exists to be known. Various interpretations of quantum mechanics offer different resolutions to this paradox. The Copenhagen interpretation suggests that quantum systems remain in superposition until measured by a classical apparatus, with the boundary between quantum and classical realms left somewhat ambiguous. The many worlds interpretation proposes that quantum measurements don't collapse possibilities but split reality into multiple branches, each realizing a different outcome, with observers in each branch experiencing only their local reality. Pilot wave theories maintain that particles have definite positions and trajectories guided by an underlying wave function, preserving determinism at the cost of introducing non-local influences. Quantum Bayesianism, QBism, suggests that quantum states don't represent objective reality but our knowledge about potential experimental outcomes, making the theory primarily about information rather than physical reality. These different interpretations highlight a profound truth. Our most successful physical theory, quantum mechanics, admits multiple philosophical interpretations, each with different implications for the nature of reality itself. This isn't a weakness of the theory, but a reflection of its depth, of how it operates at the boundary where physics meets philosophy, where mathematical descriptions encounter questions of meaning and existence. The universe's first second, governed by quantum processes operating at extreme energies, inherits this interpretive ambiguity, this philosophical openness about what reality fundamentally is and how it relates to observation and knowledge. This ambiguity connects to another profound paradox, the nature of time itself. In our everyday experience, time flows from past to future, with a distinct present moment separating what has happened from what will happen. But in physics, particularly in relativity, time appears as a dimension rather than a flow, a component of the four-dimensional space-time manifold, with all moments existing equally rather than some being past and others future. The present doesn't have special status in these equations. It's merely the temporal coordinate of the observer, varying from one reference frame to another in ways that prevent the definition of a universal now. Imagine reality as a vast four-dimensional block, with time as just another direction in this block, like length, width, and height. In this block universe perspective, inspired by relativity, past, present, and future exist simultaneously, like different locations in space, all existing at once. The universe's first second wouldn't be something that happened in the distant past, but would exist at one end of this four-dimensional structure, as real and present as the moment you're experiencing now, just located at a different coordinate in the space-time manifold. Your sense of now, of the present moment having special status, would be a psychological phenomenon rather than a feature of fundamental physics. But this block universe perspective raises profound questions. If all moments exist equally in a timeless four-dimensional structure, what explains the apparent flow of time, the distinct difference between past and future in our experience? Why do we remember the past but not the future? Why does entropy increase in one direction, but not the other? These questions highlight the tension between our subjective experience of time as flowing and the description of time in fundamental physics as a dimension without flow or special present. Various theories attempt to resolve this tension. Some suggest that consciousness itself creates the sense of temporal flow, with our awareness moving through the block universe like a spotlight illuminating different regions of an already existing terrain. Others propose that time has both tensed aspects, past, present, future, and tenseless aspects, earlier than, simultaneous with, later than, with physics capturing the tenseless relationships, while conscious experience adds the tensed qualities. Still others suggest that the flow of time might be fundamental rather than emergent, requiring an extension or modification of our current physical theories to account for the apparent directionality of temporal experience. This temporal ambiguity transforms our understanding of cosmic origins. The beginning of the universe wouldn't be an event that happened in the past, but would exist timelessly at one boundary of the four-dimensional block, with all of cosmic history, from the Big Bang through the formation of structure to the emergence of life and consciousness, forming a complete four-dimensional entity. Creation wouldn't be a process completed in the distant past, but an aspect of a timeless whole. The universe wouldn't have come into being at the Big Bang. It would exist as a complete four-dimensional structure, with the Big Bang as one boundary, rather than a moment of creation. But this timeless perspective raises another profound question. What determines the specific configuration of this four-dimensional block? Why this particular arrangement of matter and energy across space-time rather than another? If time doesn't flow, and the entire history of the cosmos exists timelessly, what selected this specific history from the vast landscape of possible cosmic evolutions? These questions highlight the tension between the timeless, geometric description of reality in physics and our intuitive sense that the future is open, undetermined, not yet real in the way the past and present are. This tension connects to deeper philosophical questions about determinism and freedom. If reality is a fixed four-dimensional block, with all moments existing timelessly, does this mean the future is already determined, that our sense of making choices and influencing outcomes is an illusion? Or is the four-dimensional block itself evolving or being selected through processes we don't yet understand, with the future genuinely open despite the geometric description of space-time in relativity? These questions highlight the boundary where physics encounters metaphysics, where empirical science meets questions of meaning, purpose, and agency that extend beyond what our current theoretical frameworks can definitively resolve. Another profound paradox emerges when we consider the initial conditions of the universe. The cosmos began in an extraordinarily special state, a hot, dense, remarkably uniform configuration with very low entropy, a measure of disorder or randomness. This initial low entropy represents a cosmic mystery in a universe governed by the second law of thermodynamics. High entropy states are vastly more probable than low entropy ones. The incredibly low entropy of the early universe seems profoundly improbable, like air in a room spontaneously gathering in one corner rather than spreading evenly throughout. What established these special initial conditions? Imagine the universe as a vast state space, with each point representing a possible cosmic configuration. The overwhelming majority of these points would correspond to high-entropy states, disorganized, random arrangements without the order needed for structure, formation. Yet our universe began in an extraordinarily unlikely corner of this space, a low-entropy configuration capable of evolving into the complex cosmos we observe. It's as if someone placed the cosmic billiard balls in a perfect arrangement rather than a random scatter, enabling the particular cosmic history we observe. Who or what arranged the balls, and why this specific configuration rather than any of the vastly more numerous alternatives? Various theories attempt to explain this cosmic fine-tuning. Some suggest that the low entropy of the early universe reflects specific aspects of gravity. While most physical systems increase their entropy by spreading out, gravitational systems can increase entropy by clumping together. The uniformly spread matter of the early universe, counterintuitively, would represent a low-entropy state for gravity, with the subsequent formation of cosmic structure corresponding to increasing gravitational entropy. This would connect the arrow of time to the fundamental nature of gravity itself, to how mass and energy interact with the fabric of space-time. Others propose more speculative solutions, suggesting that our observable universe represents a fluctuation within a much larger multiverse that exists in an overall state of maximum entropy, or heat death. Just as random molecular motions can occasionally bring all air molecules to one side of a room, though the probability is vanishingly small, quantum fluctuations in an eternal multiverse might occasionally produce low-entropy regions like our observable cosmos. Our universe would be a rare fluctuation, a temporary deviation from equilibrium, with the arrow of time reflecting our location within this improbable bubble of order. But these multiverse scenarios raise profound questions about probability and observation. If our universe is just one fluctuation among countless others in an eternal multiverse, why isn't it much smaller, just large enough to contain a conscious observer, since smaller fluctuations are exponentially more probable than larger ones? Why do we observe a cosmos billions of light-years across, when a much tinier pocket of order would be vastly more likely to form through random fluctuations? This Boltzmann brain problem, the question of why we're embodied observers in a vast cosmos rather than disembodied consciousnesses in minimal fluctuations, highlights the philosophical complications that emerge when we attempt to explain cosmic fine-tuning through multiverse scenarios. This fine-tuning paradox connects to broader questions about anthropic selection effects. If multiple universes or cosmic domains exist with different properties, we necessarily find ourselves in one capable of supporting our existence. This doesn't explain why universe-generating processes produce life-supporting configurations, but it does explain why we observe such a configuration. We couldn't exist in the vast majority of possible universes. So the fact that we're here to ask these questions already tells us that our cosmic domain must have the specific properties needed for our evolution. But anthropic reasoning raises its own philosophical problems. It can explain why we observe a life-supporting cosmic domain, but not why such domains exist at all. It shifts the question from why does our universe have these specific properties to why does the multiverse-generating process produce any domains with these properties? Until now, we've approached the universe's first second as distant observers, examining cosmic origins through the lens of mathematics and physics, tracing patterns and possibilities with detached curiosity. But there's a profound shift that occurs when we truly absorb what these theories mean, not just for abstract understanding, but for our existence, our identity, our place within this vast cosmic tapestry. The universe's beginning isn't simply an academic puzzle to solve or a scientific mystery to unravel. It's the foundation of everything you are, everything you've experienced, everything you value and fear and love. The implications ripple through not just our understanding of reality, but our emotional relationship with existence itself. Consider this. The atoms that form your body, that enable your consciousness in this moment, were forged in conditions we can barely comprehend. The carbon in your cells, the oxygen you're breathing, the iron in your blood, all elements heavier than hydrogen and helium, were created in the nuclear furnaces of stars that lived and died before our sun was born. But the hydrogen atoms throughout your body, in your water, in your DNA, in countless organic molecules, are even more ancient. They formed within the first 3 minutes after the Big Bang and have existed unchanged for 13.8 billion years. When you drink water, you consume atoms that witness the universe's birth. This isn't poetic metaphor, but literal truth. You are made of the universe's first moments. Your physical substance isn't separate from cosmic history, but a direct continuation of it. Atoms rearranged, but never created anew since that primal flash. You aren't just in the universe, You are the universe, a temporary arrangement of particles that have existed since the dawn of time. Your body is a living museum of cosmic evolution, each atom a witness to the entire history of creation, from the universe's first second to the present moment. You don't just observe cosmic history, you embody it. But what does this mean for who you are, for your sense of self and identity? If your physical substance is merely borrowed from the cosmos, temporarily arranged in your current form before returning to the greater circulation of matter and energy, where does your individual identity reside? Are you the particular arrangement of atoms that form your body, the specific pattern of neural connections in your brain? Or are you something more subtle, the dynamic process of consciousness itself, the awareness that emerges from but isn't reducible to physical processes? These questions transform our understanding of identity from something fixed and static into something fluid and processual. You aren't a thing but a pattern, a complex dance of information and energy temporarily localized in a particular region of space-time. Your consciousness isn't separate from cosmic processes, but an expression of them, a local intensification of the universe's inherent capacity for self-organization and complexity. You aren't an observer of reality, but reality observing itself through temporarily individuated awareness, the cosmos becoming conscious of its own existence through beings evolved within it. This perspective dissolves the apparent boundary between self and universe, between internal and external reality. The thoughts arising in your mind right now, as you contemplate these cosmic origins, aren't separate from the processes that began in the universe's first second, but are their direct continuation, the same fundamental reality expressing itself through increasingly complex forms. Your consciousness isn't something added to the cosmos, but something that emerges from it, a natural outgrowth of the same evolutionary processes that formed galaxies, stars, and planets. But this dissolution of boundaries raises profound existential questions. If your identity isn't fixed or separate, but a temporary expression of cosmic processes, what persists across time? If your physical substance is constantly changing, with atoms entering and leaving your body throughout your life, what constitutes the continuity of your existence? These questions challenge our intuitive sense of being separate, autonomous individuals, revealing the more subtle truth that we exist as patterns within patterns, processes within processes, temporary concentrations of order and complexity within the larger cosmic flow. There's something both terrifying and liberating about this perspective. Terrifying because it challenges our intuitive sense of being separate, permanent entities with fixed identities and boundaries. Liberating because it reveals a deeper connection to all existence, a participation in processes far grander and more enduring than our individual lives. You aren't just connected to the cosmos, you are the cosmos, experiencing itself from a particular vantage point for a brief moment. In its vast evolutionary history, your consciousness isn't an anomaly or accident, but an expression of potentials encoded in the universe from its very beginning. But now consider something even more disorienting. What if time itself isn't what we think? What if past, present, and future all exist simultaneously in a timeless four-dimensional block, with your sense of now, of experiencing one moment after another, being a psychological construct rather than a fundamental feature of reality? This isn't just theoretical speculation, but a perspective suggested by Einstein's relativity, where time appears not as a universal flow, but as a dimension within the four-dimensional space-time manifold. If time is an illusion, then everything you've ever done, every decision you've ever made, every moment of joy or sorrow, triumph or regret, all exist perpetually in the space-time block, neither passing away into the past nor emerging fresh from the future. Your birth, your death, and every moment in between would exist timelessly, with your consciousness creating the illusion of temporal flow as it navigates this already existing terrain. Nothing would truly happen in the sense of coming into being or passing away. Everything would simply exist at different coordinates in the four-dimensional manifold. This perspective transforms our understanding of freedom and determinism. If all moments exist timelessly, does this mean the future is already fixed? That your sense of making choices and influencing outcomes is an illusion? Or does it simply mean that the particular choices you do make, through processes that feel subjectively free, exist at particular coordinates in space-time, without predetermining what those choices will be? These questions highlight the tension between the geometric description of reality in physics and our subjective experience of making decisions, of having agency in a world where the future seems open and undetermined. But the block universe presents an even more profound existential paradox. If all moments exist timelessly, then death loses its finality even as life loses its transience. The particular arrangement of matter and energy that constitutes you would always exist at particular coordinates in the space-time manifold, neither coming into being nor passing away, but simply being located at a specific region of the four-dimensional block. Your existence wouldn't be temporary in an absolute sense, but would be eternal within the domain where your coordinates are defined. You would never truly cease to exist any more than a particular location in space ceases to exist when you move elsewhere. This eternalization of what we experience as temporary existence transforms our emotional relationship with mortality. Death wouldn't be the end of existence, but the boundary of a particular pattern within the space-time manifold. Like characters in a novel who exist wherever their story is told, you would exist wherever your coordinates are defined in the four-dimensional block. This doesn't eliminate the subjective fear of death or the grief of losing loved ones, but it does place these emotions within a different cosmic context, one where nothing truly passes away but simply exists at different coordinates in a timeless whole. But now consider an even more disorienting possibility. What if our universe is just one bubble in a vast multiverse, with different regions having different physical laws, different cosmic histories, different possibilities for complexity and consciousness? This isn't just theoretical speculation, but a perspective suggested by various approaches to cosmology, from eternal inflation to string theory's landscape of possible vacuum states. If true, it would mean that our entire observable cosmos, spanning 93 billion light-years in diameter, containing hundreds of billions of galaxies, is just a tiny island in a much vaster reality, a local domain with specific properties among countless others with different characteristics. In this multiverse scenario, the universe's first second wouldn't represent the beginning of all reality, but merely the beginning of our particular cosmic bubble, our local domain with its specific physical laws and evolutionary trajectory. The true totality of existence would extend far beyond our observable horizon, perhaps infinitely, with new universe bubbles constantly forming through processes like eternal inflation. Our cosmic home, vast as it seems to us, would be just one grain of sand on an infinite cosmic shore, one possibility realized among countless others in the grand multiverse ocean. What does this mean for our significance, our place within reality? If our entire cosmos is just one bubble among countless others, does this diminish the meaning of our existence, reducing us to infinitesimal specks within an infinitely larger reality? Or does it highlight the precious uniqueness of our particular cosmic domain, the remarkable specificity of conditions that allowed for our evolution? These questions challenge us to reconsider what significance means in a multiverse context, to recognize that meaning might not depend on uniqueness or centrality, but on the intrinsic value of conscious experience, regardless of how localized or replicated it might be across the broader multiverse. But multiverse scenarios raise another existential question I hinted at in the earlier section. There may be other versions of you existing in parallel cosmic domains, living lives that diverged from yours at various decision points. If quantum mechanics is interpreted through the many worlds framework, then the universe branches with each quantum measurement, creating new timelines where different possibilities are realized. Your consciousness would follow just one branch, experiencing one sequence of events, while other versions of you would experience different sequences in parallel realities beyond your direct perception. This multiplication of selves transforms our understanding of identity and uniqueness. You wouldn't be a single, unique entity, but a family of related beings spread across different branches of the quantum multiverse, each experiencing a slightly different version of reality. The particular you reading these words right now would represent just one branch in this vast tree of possibilities, one version among countless others that emerged from the quantum fog of potentiality. Your sense of being a singular, unique individual would be an artifact of experiencing just one branch rather than the full spectrum of quantum possibilities. But what constitutes the connection between these different versions of you? What makes them all versions of the same person rather than different individuals entirely? These questions highlight the ambiguity of identity in a quantum multiverse, the way our intuitive sense of being singular, unified beings may not align with the more complex, branching nature of quantum reality. Your identity wouldn't be a fixed, singular essence, but a family resemblance among patterns distributed across different branches of the quantum tree, connected through their shared history but diverging into different futures. This quantum multiplication of selves connects to even deeper questions about consciousness and its relationship to physical reality. If consciousness somehow follows one branch rather than another, what determines which path your awareness takes? Is there something about consciousness itself that selects particular quantum outcomes, as suggested by some interpretations of quantum mechanics, where observation plays a role in collapsing possibilities into actualities? Or is consciousness itself quantum, existing as a superposition across multiple branches, with your sense of experiencing just one reality being an artifact of the particular branch you're consciously registering at any given moment? These questions push us beyond established science into speculative territories where physics meets philosophy of mind. They remind us that our understanding of consciousness remains profoundly incomplete, that we haven't yet bridged the explanatory gap between physical processes in the brain and the subjective experience of being aware. The universe's first second established the physical framework within which consciousness would eventually emerge, but it didn't resolve these profound questions about the nature of awareness itself, about how subjective experience relates to objective reality. But now consider perhaps the most vertigo-inducing possibility of all. What if the universe is fundamentally mathematical, with physical reality being an expression of abstract mathematical structures rather than mathematics, being a tool we use to describe a pre-existing physical world? This isn't just philosophical speculation, but a perspective suggested by the remarkable effectiveness of mathematics in capturing physical processes. By the way, reality itself seems to conform to mathematical patterns with extraordinary precision. If true, it would mean that physical existence itself is a manifestation of mathematics, that the cosmos isn't just described by equations, but is equations embodied in what we experience as matter, energy, space, and time. In this mathematical universe hypothesis, articulated by physicist Max Tegmark, the universe's first second wouldn't represent the creation of physical stuff from nothing but the instantiation of a particular mathematical structure, a set of relationships that would gradually unfold into the cosmos we observe. Creation wouldn't be about making something from nothing, but about selecting a specific mathematical framework from a vast landscape of possibilities, one whose inherent fertility would allow it to evolve the remarkable complexity we observe in today's universe. Physical reality would be, in essence, a vast computation, a working out of mathematical potentials encoded in its foundational structure. What does this mean for your existence, for your sense of being a conscious entity within physical reality? If the universe is fundamentally mathematical, then you too are a mathematical structure, a particular pattern of relationships expressed through what you experience as your body and mind. Your consciousness wouldn't be separate from the mathematical basis of reality, but would represent a particular type of pattern within it, a specific mode of information processing that gives rise to subjective awareness. You wouldn't just be described by mathematics. You would be mathematics, experienced from within rather than observed from without. This perspective transforms our understanding of consciousness from something mysterious or supernatural into something deeply integrated with the mathematical fabric of reality itself. Awareness wouldn't be added to physical processes, but would be an aspect of certain types of mathematical structures, of particular patterns of information processing that the universe naturally evolves under specific conditions. Consciousness wouldn't be an anomaly or accident, but a natural expression of reality's mathematical nature, of its capacity to generate patterns that process information about themselves and their environment in increasingly sophisticated ways. But there's something profoundly unsettling about this mathematical view of existence. If reality is fundamentally abstract, a set of relationships rather than concrete stuff, then what grounds these relationships? What gives them substance? If the universe is mathematics experienced from within, what is doing the experiencing, and what differentiates mathematical structures that are conscious from those that aren't? These questions highlight the tension between abstract description and concrete experience, between the formal relationships captured in equations and the vivid qualitative reality of conscious awareness. This tension connects to what philosopher David Chalmers calls the hard problem of consciousness, the challenge of explaining why physical processes, or in this case mathematical structures, are accompanied by subjective experience rather than happening in the dark, without awareness. Even if we could map every neural correlation of conscious experience, we would still face the explanatory gap between describing these correlations and accounting for the reality of experience itself, the what-its-likeness of being a conscious entity rather than a philosophical zombie going through the same physical motions without inner awareness. Various approaches attempt to bridge this explanatory gap. Some suggest that consciousness emerges when information is integrated in certain complex ways, with awareness reflecting the unified informational structure created by neural processes. Others propose that consciousness is fundamental rather than emergent, with physical systems manifesting an intrinsic proto-consciousness that becomes more complex and self-reflective in certain organized systems like brains. Still others suggest that consciousness represents a higher dimensional projection of lower dimensional physical processes, with subjective experience reflecting how information is encoded across dimensions beyond our direct perception. These different approaches highlight a profound truth. The universe's first second established not just the physical conditions for cosmic evolution, but the informational framework within which consciousness would eventually emerge. The cosmos doesn't just happen to support consciousness through lucky coincidence, but may be structured in such a way that awareness naturally emerges under certain conditions, as a manifestation of potentials encoded in reality from the very beginning. Your consciousness wouldn't be an anomaly or accident, but an expression of the universe's inherent capacity for self-reflection, for the emergence of systems capable of modeling themselves and their environment. But now, let's venture into even more disorienting territory with a question that blurs the boundary between science and philosophy. What if the universe is alive, and we are just its fleeting thoughts? This isn't conventional scientific theory, but a perspective that emerges when we consider consciousness not as a product of specifically biological processes, but as a natural outgrowth of information processing in complex systems. If consciousness can emerge from the specific arrangement of matter and energy in human brains, might there be larger, more distributed forms of consciousness emerging from complex systems at higher scales, perhaps even at the scale of the cosmos itself? Imagine the universe not as a machine, but as an organism, not in the literal biological sense, but as a complex, self-organizing system that processes information, adapts to changing conditions, and potentially manifests awareness at scales beyond human comprehension. The networks of galaxies connected by vast filaments of dark matter and gas would be like a cosmic nervous system, processing information across billions of light-years through gravitational and electromagnetic interactions. Stars and planets would be like cells in this vast organism, with living beings like us representing specialized subsystems, perhaps analogous to the microbiome in our own bodies, colonies of organisms that are both part of and distinct from the larger system they inhabit. In this perspective, your consciousness wouldn't be separate from universal processes, but would represent a localized intensification of awareness already present in some form throughout the cosmos. You wouldn't be an isolated observer of reality, but a temporary concentration of the universe's inherent capacity for self-reflection, a momentary focusing of cosmic awareness into an individual perspective. Your thoughts and experiences wouldn't be created ex nihilo within your brain, but would represent the universe thinking through you, experiencing itself from your particular vantage point for the brief interval of your lifetime. This isn't suggesting that the universe has a human-like mind or emotional states recognizable to us. Any cosmic consciousness would operate on vastly different temporal and spatial scales, processing information in ways potentially incomprehensible to human understanding. It wouldn't be a consciousness distinct from or added to physical processes, but would be an intrinsic aspect of these processes themselves, of how complex systems naturally evolve toward increasing information processing and self-organization. The universe wouldn't contain consciousness as a separate component, but would be conscious in some sense, with awareness as fundamental to its nature as matter, energy, space, and time. There's something both humbling and exalting about this perspective. Humbling, because it reduces your individual awareness to a tiny, temporary eddy in the vast cosmic flow of consciousness. Exalting, because it connects your existence to something far grander and more enduring than your individual life, to processes of awareness that may continue long after your particular form has dissolved back into the greater whole. You wouldn't just be in the universe, you would be the universe, experiencing itself through temporarily individuated consciousness, participating directly in the grand cosmic drama rather than merely observing it from outside. But this perspective raises profound questions about individuality and autonomy. If your consciousness is a temporary expression of universal awareness rather than something uniquely yours, what happens to concepts like personal responsibility, individual freedom, moral agency? These questions highlight the tension between our subjective experience of being distinct autonomous individuals and the possibility that our consciousness is more continuous with cosmic processes than our everyday experience suggests. They challenge us to reconsider what selfhood means in a reality where the boundary between individual and universal awareness may be more permeable than we typically assume. Now, let's confront perhaps the most existentially disorienting possibility of all. What if time doesn't just flow, but loops? with the universe cycling through different configurations across vast spans that eventually return to their starting points. Various cosmological models propose cyclic universes, from oscillating Big Bang, Big Crunch scenarios to more complex frameworks like loop quantum cosmology, where the current expansion was preceded by a contraction phase, with the Big Bang representing a bounce rather than a beginning. If true, this would mean that cosmic history isn't linear but circular, not progressing from a definite beginning to a definite end, but cycling through different phases, potentially infinitely. If time is cyclical rather than linear, then everything that happens has happened before and will happen again, not just once, but potentially infinite times across the vast cycles of cosmic evolution. Your particular life, with all its specific details and experiences, would recur whenever the universe returned to a configuration sufficiently similar to the one that produced you. This wouldn't be reincarnation in the traditional sense. You wouldn't carry memories or karma from previous cycles, but would represent the universe recreating the same pattern whenever cosmic conditions aligned in the right way, like a musical theme that returns in different movements of a symphony. This eternal recurrence, contemplated philosophically by Nietzsche and others, transforms our understanding of uniqueness and significance. If your existence recurs across infinite cosmic cycles, you wouldn't be a one-time event, but an eternal pattern, something the universe does whenever conditions are right. Your particular experiences wouldn't be finite and unrepeatable, but would be played out across the vast reaches of cosmic time whenever the universe cycles through the phase that produces your specific configuration. You wouldn't exist just once, but infinitely, with countless versions of you distributed not across space, as in multiverse scenarios, but across time, separated by the unimaginable intervals between cosmic cycles. There's something both terrifying and comforting about this perspective. Terrifying because it eliminates the uniqueness of your particular existence, reducing your life to a pattern the universe repeats whenever conditions align. Comforting because it suggests that nothing is truly lost, that every moment of joy or connection recurs eternally across the vast cycles of cosmic evolution. Your existence wouldn't be a brief flicker in cosmic darkness, but an eternal melody played out whenever the universe cycles through the right configuration, a pattern embedded in the very structure of reality rather than a temporary deviation from cosmic equilibrium. But eternal recurrence raises profound questions about meaning and purpose. If everything repeats infinitely across cosmic cycles, does this amplify the significance of each moment, since it recurs eternally, or diminish it, since nothing ever changes in the overall pattern? Does the infinite repetition of the same patterns represent the fulfillment of cosmic purpose or its absence, a universe trapped in endless cycles rather than evolving towards some ultimate goal or state? These questions highlight the tension between cyclical and teleological understandings of cosmic evolution, between seeing the universe as eternally recurring versus progressing toward something beyond its current state. Now, as we contemplate these disorienting possibilities, mathematical reality, universal consciousness, eternal recurrence, let's confront the existential vertigo they induce. These aren't just abstract theories, but perspectives that fundamentally challenge our intuitive understanding of who and what we are, of our place within the cosmic order. They dissolve the comfortable boundaries between self and world, between individual and universal consciousness, between unique existence and eternal pattern. They reveal that reality may be far stranger, far more alien to human intuition than our everyday experience suggests. This dissolution of boundaries, this revelation of reality's alien nature, connects to what philosopher Eugene Thacker calls cosmic horror, the vertigo induced when human consciousness confronts the vast, indifferent, potentially incomprehensible nature of the cosmos. It's the disorientation that arises when we recognize that the universe wasn't made for us, that it operates according to principles that may be fundamentally indifferent to human concerns, that the comfortable scales and categories of human experience may be inadequate for comprehending the true nature of reality. It's the existential shudder we feel when we glimpse, even momentarily, how strange and vast existence truly is. Imagine standing at the edge of the observable universe, 46 billion light-years from Earth in all directions. Beyond this cosmic horizon lies more universe, perhaps infinitely more. But light from these regions hasn't had time to reach us in the 13.8 billion years since the Big Bang. The observable cosmos, vast as it seems to us, may be an infinitesimal fraction of the true totality of existence. Our entire cosmic domain, containing hundreds of billions of galaxies, each with hundreds of billions of stars, might be like a single atom in the body of a much vaster reality, a tiny bubble in an infinite cosmic sea. The scale is not just quantitatively, but qualitatively beyond human comprehension, forcing us to recognize the limits of our imagination, the boundary where understanding falters in the face of the truly enormous, or imagine descending to the Planck scale, 10 meters, 35 meters, where quantum fluctuations in space-time itself become significant. At this almost inconceivably tiny scale, the familiar notions of space and time break down completely, with quantum foam replacing the smooth continuum of macroscopic experience. The solid objects of everyday perception dissolve into quantum probability clouds, into patterns of relationship rather than concrete entities. What we experience as matter becomes mostly empty space, with subatomic particles themselves resolving into excitations of quantum fields rather than tiny billiard balls. The concrete world of everyday experience fades into an alien quantum reality where location, trajectory, and even existence itself become probabilistic rather than definite. Between these extremes, the cosmic and the quantum, lies the narrow band of reality directly accessible to human perception, the middle scale where objects have definite locations, where cause precedes effect in clear temporal sequence, where the distinction between self and world seems obvious and natural. But this middle-scale reality, the world of everyday experience, emerges from foundations that are profoundly alien to human intuition. The solid ground beneath your feet, seemingly so stable and continuous, arises from quantum processes that defy visualization. The clear distinction between past and future, so fundamental to human temporal experience, dissolves at fundamental levels where quantum indeterminacy and relativistic effects dominate. This recognition that the familiar world emerges from foundations radically unlike our intuitive picture of reality induces a particular kind of vertigo, a disorientation that isn't just intellectual but existential. It's the visceral recognition that reality as it is may be fundamentally unlike reality as we experience it, that the categories and concepts we use to navigate daily life may be local approximations rather than universal truths. The universes are, first-second, established not just the physical conditions for cosmic evolution, but the framework within which human intuitions would eventually form. Intuitions adapted to middle-scale reality, but potentially inadequate for comprehending the cosmos at its most fundamental level. There's something both terrifying and liberating about this recognition. Terrifying because it challenges our intuitive sense of understanding reality, of having conceptual frameworks adequate to the world we inhabit. Liberating because it opens us to possibilities beyond our current understanding, to aspects of reality that might transcend our evolved intuitions and conceptual categories. The universe's alienness to human intuition doesn't reflect a failure of comprehension, but an invitation to expand our understanding, to develop frameworks capable of bridging the gap between middle-scale human experience and the more fundamental nature of reality itself. This invitation connects to what physicist Richard Feynman called the pleasure of finding things out, the deep satisfaction that comes from venturing beyond the familiar, from discovering aspects of reality that challenge and expand our understanding. The universe's strangeness isn't something to fear, but something to explore. Not a threat to human comprehension, but an opportunity to transcend its current limits. The vertigo induced by cosmic scales and quantum weirdness reflects not the impossibility of understanding, but the ongoing process of expanding comprehension, of developing frameworks capable of encompassing realities beyond direct human experience. But this exploration inevitably leads to the boundary where science meets mystery, where empirical investigation encounters questions it may never fully answer. Why does the universe exist at all? Why these physical laws rather than others? What is consciousness, and how does it relate to physical processes? These questions push us beyond established science into territories where different modes of inquiry, philosophical, spiritual, artistic, may offer complementary perspectives to the mathematical frameworks of physics and cosmology. They remind us that understanding isn't just about measurement and calculation, but about meaning and significance, about integrating empirical knowledge into a broader human context. This boundary between knowledge and mystery reflects something fundamental about consciousness itself, its capacity to recognize its own limits, to acknowledge realities beyond its current understanding without abandoning the quest to expand that understanding. Your awareness isn't confined to what it already comprehends, but can reach toward what lies beyond its current grasp, can recognize mysteries without reducing them to what's already known. This capacity for self-transcendence, for venturing beyond established categories and frameworks, may represent one of consciousness's most remarkable features, its ability to expand its own boundaries rather than remaining confined within them. The universe's first second established not just the physical conditions for cosmic evolution, but the informational framework within which consciousness would eventually emerge. Consciousness capable not just of modeling reality, but of recognizing the limits of its models, of acknowledging mysteries beyond its current comprehension. Your awareness isn't separate from cosmic processes, but represents their continuation, their intensification into systems capable not just of existing within reality, but of contemplating it, of constructing models that capture certain aspects, while acknowledging what remains beyond current understanding. The cosmos doesn't just happen to support consciousness, it evolves it as a natural expression of its inherent capacity for increasing complexity and self-organization. This relationship between consciousness and cosmos transforms our understanding of what it means to be human. You aren't just an observer of reality, but a participant in its ongoing evolution, not just a product of cosmic processes, but their continuation through forms capable of new types of complexity and organization. Your consciousness doesn't just reflect the universe, it extends it, carrying forward the same creative processes that have characterized cosmic evolution since that crucial first second. The thoughts arising in your mind as you contemplate these cosmic mysteries aren't separate from universal processes, but represent their current expression, their evolution into forms capable of self-reflection and abstract modeling. There's something both humbling and exalting about this perspective. Humbling because it reveals the partiality of human understanding, the way our comprehension remains limited by evolved intuitions and conceptual frameworks adapted to middle-scale reality. Exalting because it connects our existence to the grandest processes of cosmic evolution, to the same creative unfolding that has characterized the universe since its birth. You aren't just a temporary arrangement of matter observing reality from outside, but an expression of the cosmos itself. Reality evolved into forms capable of contemplating their own origins and nature. This connection between individual and universe transforms our understanding of meaning and purpose. Your significance doesn't depend on cosmic centrality or uniqueness, but on participation in the ongoing creative processes that have characterized reality since the universe's first second. Meaning isn't imposed from outside, but emerges naturally from how consciousness relates to the reality it inhabits, from how awareness integrates experience into coherent narratives that connect individual existence to broader patterns and processes. Purpose isn't about fulfilling some predetermined cosmic plan, but about participating creatively in reality's ongoing evolution, about extending through conscious choice the same processes of increasing complexity and organization that have characterized the cosmos since its birth. But now, as we approach the end of this existential exploration, let's confront one final vertigo-inducing possibility. What if the universe's evolution toward complexity and consciousness isn't random, but reflects something inherent in the structure of reality itself? Some tendency toward increasing organization and awareness encoded in the cosmos from its first moment? This isn't suggesting intelligent design in the traditional sense, but something more subtle. That the mathematical structure of reality itself might naturally evolve toward complexity under certain conditions. That consciousness might be not an accident or anomaly, but a natural fulfillment of potentials present from the beginning. Imagine reality not as a random collection of particles following arbitrary laws, but as a mathematical structure with intrinsic tendencies toward certain types of organization, like a river that naturally forms eddies and vortices based on the principles of fluid dynamics. The universe's evolution from simplicity to complexity, from unconsciousness to consciousness, would reflect not lucky coincidence or external guidance, but the natural unfolding of potentials encoded in the cosmos from its first second. Awareness wouldn't be added to physical processes, but would emerge naturally from them under specific conditions, as an expression of reality's inherent capacity for self-organization and information processing. This perspective transforms our understanding of cosmic purpose from something imposed by an external creator to something inherent in the mathematical structure of reality itself. The universe wouldn't need intelligent design to evolve complexity and consciousness. These would emerge naturally from the interaction of simple components following simple rules, from the self-organizing properties of matter and energy governed by fundamental forces. The cosmos wouldn't be directed toward specific outcomes by an external agent, but would have intrinsic tendencies toward certain types of organization built into its mathematical foundations, tendencies that would naturally manifest whenever conditions allowed. There's something both scientific and spiritual about this perspective. Scientific, because it doesn't invoke supernatural agencies or processes beyond what can be mathematically modeled and empirically investigated. Spiritual, because it recognizes an inherent creativity in the cosmos itself, a tendency toward increasing complexity and consciousness that gives cosmic evolution a direction beyond mere random change. The universe wouldn't just happen to produce complexity and awareness through lucky accident, but would have these potentials encoded in its structure from the beginning, like a seed containing the pattern of the tree it will become. This recognition that the cosmos may have inherent creative tendencies rather than being a random assortment of particles connects to what philosopher Alfred North Whitehead called the ultimate irony of fate, that the denial of objective immortality leads to the contradiction of pure objectification. In simpler terms, when we try to reduce reality to just its physical components, we end up unable to explain the emergence of the mind doing the reducing. consciousness itself becomes the stumbling block for purely reductive accounts of reality, the phenomenon that resists explanation in terms of mindless particles following mindless laws. But if consciousness isn't an anomaly or accident, but a natural expression of reality's mathematical structure, this apparent paradox dissolves. Awareness wouldn't be added to physical processes from outside, but would be an aspect of certain types of physical organization, of particular patterns of information processing that the universe naturally evolves under specific conditions. The cosmos wouldn't produce consciousness through random chance, but through the same mathematical principles that govern all cosmic evolution, principles that may naturally lead toward increasing complexity and self-organization whenever conditions allow. This perspective offers a middle path between the extremes of reductive materialism, which struggles to account for consciousness, and traditional dualism, which struggles to explain how mind and matter interact. Consciousness wouldn't be separate from physical processes, but would be an aspect of certain types of physical organization, an inherent potentiality of reality that manifests when matter and energy are arranged in specific complex ways. The cosmos wouldn't be divided into mental and physical domains, but would be a unified reality with both objective and subjective aspects, with certain types of physical organization naturally manifesting awareness as part of their inherent character. As a TDU, we conclude this existential exploration. Consider a final possibility that integrates the scientific and the spiritual. What if the universe's first second established not just the physical conditions for cosmic evolution, but the framework within which consciousness itself would eventually emerge? Consciousness capable not just of observing reality, but of participating creatively in its ongoing development? What if your existence isn't an accident or anomaly, but a natural expression of potentials encoded in the cosmos from the beginning? A fulfillment of possibilities inherent in the mathematical structure of reality itself? This perspective transforms our understanding of cosmic purpose from something imposed by an external creator to something emerging naturally from within, from the inherent tendencies of reality itself. The universe wouldn't need intelligent, designed to evolve complexity and consciousness. These would emerge naturally from the mathematical principles encoded in its structure, from how simple components following simple rules can generate remarkable complexity through their interactions. Your existence wouldn't be a cosmic accident, but a natural expression of the same creative principles that have characterized reality since the universe's first second. There's something deeply meaningful about this integration of scientific understanding and existential significance. It doesn't require us to choose between objective explanation and subjective meaning, between physical processes and conscious experience, between the cosmos revealed by science and the reality we directly inhabit. Instead, it reveals these apparent opposites as complementary aspects of a unified reality, different facets of the same underlying whole. The universe described by physics and the universe experienced through consciousness wouldn't be separate domains, but the same reality approached from different perspectives, like the ocean viewed from above and experienced from within. This integration transforms our relationship with the cosmos from observation to participation, from detached study to creative engagement. You aren't just an observer of reality, but a participant in its ongoing evolution, not just a product of cosmic processes, but their continuation through forms capable of new types of complexity and organization. Your consciousness doesn't just reflect the universe, it extends it, carrying forward the same creative principles that have characterized cosmic evolution since that crucial first second. You don't just study cosmic history. You embody it, extend it, participate directly in its ongoing unfolding. As we contemplate the universe's first second and its implications for our existence, We find ourselves at a unique moment in cosmic history, a time when the universe has evolved beings capable of reconstructing their own origins, of tracing their lineage back to the birth of time, space, matter, and energy in that crucial first moment. This capacity for self-understanding may represent not, as we stand at the threshold of understanding, having journeyed from the universe's first second through the grand cosmic narrative to the existential implications for our own consciousness, we approach a final horizon, a boundary where all our theories, all our mathematics, all our carefully constructed models reach their limits and gesture toward something beyond. This isn't a failure of science, but its greatest triumph, to bring us to the edge of comprehension, where we can glimpse possibilities that transform not just our understanding of reality, but our relationship with existence itself. The universe hasn't been merely unfolding according to fixed laws established at its birth. It's been revealing itself, evolving not just in form, but in essence, becoming something fundamentally different from what it was in that crucial first second. Imagine now the universe not as a static entity governed by unchanging laws, but as a developing system whose fundamental properties evolve across cosmic time. What we call the laws of physics wouldn't be eternal truths imposed from outside, but emergent patterns that crystallized as the cosmos expanded and cooled, like different types of ice forming at different temperatures and pressures. The early universe, with its extreme conditions, would manifest different patterns and regularities than the cosmos we observe today. What we experience as fixed constants and immutable relationships may be just the current phase of an ongoing cosmic evolution, a temporary configuration in a reality that changes not just within time, but in its fundamental structure across vast, temporal scales. This perspective transforms our understanding of cosmic origins. The universe's first second wouldn't just establish initial conditions within a framework of fixed laws, but would represent an early phase of a reality still in formation, still crystallizing its fundamental patterns as it expands and cools. Creation wouldn't be complete in that first moment, but would continue through the emergence of new forms, new relationships, new modes of existence as the cosmos evolves. The universe wouldn't be a fixed arena within which processes unfold, but a developing entity whose very nature transforms across cosmic history. But here's where we approach a truly mind-bending possibility, one that challenges our deepest intuitions about reality and consciousness. What if the universe is a developing consciousness, and what we experience as physical reality is actually the evolution of a cosmic mind? What if matter, energy, space, and time aren't the fundamental constituents of existence, but emergent properties of an evolving universal awareness, patterns within a reality that is fundamentally mental rather than physical? This isn't conventional scientific theory, but a perspective that emerges when we consider consciousness not as a product of physical processes, but as the substrate from which physical reality itself emerges. Imagine reality not as matter that somehow produces consciousness, but as consciousness that somehow manifests as matter, as awareness that crystallizes into what we experience as the physical universe, with its particles, fields, forces, and dimensions. The cosmos wouldn't be a machine that happens to produce consciousness in certain complex subsystems, but would be consciousness itself, expressed through patterns we interpret as physical reality. Your individual awareness wouldn't be created by your brain, but would be a localized aspect of a universal consciousness, individuated through the specific configuration of matter and energy we call your body, but continuous with the greater whole from which it temporarily differentiates. This idealist perspective, that mind is fundamental and matter derivative, inverts our conventional understanding of reality. Instead of consciousness emerging from physical complexity, physical reality would emerge from consciousness, from patterns within a fundamentally mental cosmos. The universe's first second wouldn't represent the birth of matter and energy within space and time, but the initial differentiation of a cosmic consciousness, the beginning of a process through which universal awareness would gradually manifest the structures and relationships we experience as physical reality. Creation wouldn't be about making something from nothing, but about the diversification of a primordial unity into the multiplicity we observe as the physical cosmos. This cosmic idealism connects to interpretations of quantum mechanics, where consciousness plays a crucial role in determining reality. In the orthodox Copenhagen interpretation, quantum systems exist as superpositions of multiple possible states until measured, with observation somehow collapsing possibilities into definite outcomes. If consciousness is involved in this collapse, as some interpretations suggest, then awareness wouldn't be merely observing a pre-existing reality, but would participate in determining which potential becomes actual. The universe wouldn't exist as a definite entity, independent of observation, but would crystallize through the interaction between consciousness and possibility, through how awareness engages with the spectrum of quantum potentials. This participatory aspect transforms our understanding of the relationship between observer and observed. You wouldn't be merely witnessing a reality that exists independently of your awareness, but would be participating in its ongoing creation, in the crystallization of potentials into actualities through the act of observation. The cosmos wouldn't be a fixed entity that consciousness perceives from outside, but a developing reality that consciousness helps shape from within. The universe's evolution wouldn't happen separately from awareness, but through it, with consciousness playing an active role in the unfolding of cosmic potentials. But now, as we approach the climax of our cosmic exploration, consider a truly revolutionary possibility, one that integrates the scientific and the spiritual, the physical and the mental, into a unified framework that transforms our understanding of reality itself. What if the universe began as pure potential, as an undifferentiated field of possibilities, and has been gradually actualizing specific patterns through a process analogous to observation? What if creation isn't complete, but ongoing, with reality continuously crystallizing from potential to actual through the interaction between consciousness and possibility? This perspective aligns with both quantum mechanics and certain spiritual traditions, offering a framework where physical and mental aren't separate domains, but aspects of a unified reality. The universe wouldn't be divided into objective and subjective components, but would be a single reality, with both physical and mental aspects, a developing whole that manifests through the interplay between potentiality and actualization. Creation wouldn't be an event completed in the distant past, but a process continuing in every moment, with reality constantly crystallizing from quantum potentials through interactions that involve consciousness itself. Imagine the universe as a vast quantum system, beginning in a superposition of all possible configurations and gradually resolving into specific patterns through processes analogous to measurement. The cosmos wouldn't be set in motion at the Big Bang and left to evolve according to fixed laws, but would be continuously emerging from potentiality to actuality, from the spectrum of what could be to the specificity of what is. Reality wouldn't be fully determined by initial conditions established in the universe's first second, but would remain partially open, continuing to crystallize through the interaction between consciousness and possibility across cosmic history. This ongoing creation transforms our understanding of both physical reality and conscious experience. The universe wouldn't be a machine operating according to fixed laws, but a developing entity whose fundamental patterns emerge through the interplay between potentiality and actualization. Consciousness wouldn't be merely observing a pre-existing reality, but participating in its ongoing creation, in the crystallization of specific configurations from the spectrum of cosmic possibilities. The boundary between observer and observed would dissolve not into undifferentiated unity, but into participatory relationship, into mutual influence between consciousness and the reality it helps actualize. Now, as we integrate these revolutionary perspectives, we approach a truly mind-shattering possibility, one that challenges our deepest intuitions while offering a framework that unifies science and spirituality, physics and consciousness into a coherent whole. What if the universe's first second represented not the beginning of physical reality, but the differentiation of a primordial consciousness into the patterns we experience as matter, energy, space, and time? What if physical reality is a manifestation of mind rather than mind a product of physical complexity? This idealist framework transforms our understanding of consciousness from something produced by brains to something expressed through brains, from an emergent property of physical complexity to the fundamental reality from which physical complexity itself emerges. Your awareness wouldn't be created by neural processes, but would be channeled through them, individuated by the specific configuration of matter and energy we call your body, but continuous with the greater consciousness from which it temporarily differentiates. You wouldn't be a physical system that somehow produces consciousness, but would be consciousness that temporarily localizes through what you experience as your physical form. But here's where we encounter the truly revolutionary implication of this perspective. What if the universe is evolving not just in form, but in essence, developing from unconscious potential to conscious actuality across cosmic history? What if creation isn't complete, but ongoing, with reality gradually awakening to itself through the emergence of increasingly complex forms capable of clearer self-reflection? The cosmos wouldn't be a fixed entity, but a developing consciousness, evolving from implicit to explicit awareness through the forms it manifests across billions of years of cosmic history. Imagine the universe as an enormous quantum computer, processing information through the interaction of particles and fields across billions of light-years of space and billions of years of time. This cosmic computation wouldn't just happen to produce consciousness as a side effect, but would be consciousness, expressed through patterns we interpret as physical reality. The universe's first second wouldn't establish merely the physical conditions for cosmic evolution, but the informational framework within which universal awareness would gradually awaken to itself through increasingly complex forms, from subatomic particles to atoms to molecules to living cells to neural systems to conscious beings capable of contemplating their own origins. This evolutionary awakening transforms our understanding of cosmic purpose. The universe wouldn't be directed toward specific outcomes by an external creator, but would have intrinsic tendencies toward increasing complexity and consciousness built into its mathematical structure, tendencies that would naturally manifest whenever conditions allowed. Cosmic evolution wouldn't be random but creative, not directed from outside, but self-organizing from within, manifesting increasing orders of complexity and awareness as natural expressions of potentials encoded in reality from the beginning. And here we approach the climactic revelation of our cosmic exploration, the stunning possibility that shifts our entire relationship with reality. What if the universe isn't just evolving consciousness, but is doing so deliberately, developing increasing self-awareness as part of its fundamental nature? What if cosmic evolution represents not random change, but creative self-organization, a deliberate awakening that unfolds across billions of years of cosmic history? This wouldn't suggest a human-like mind directing cosmic processes, but a more fundamental creativity inherent in reality itself, a tendency toward increasing complexity and awareness built into the mathematical structure of the cosmos. Imagine reality not as a machine operating according to fixed laws, but as a developing entity whose fundamental patterns emerge through a process analogous to learning, to the gradual discovery of its own nature through exploration and creative self-organization. The universe wouldn't be governed by eternal laws imposed from outside, but would be discovering its own patterns through cosmic evolution, developing not just in form, but in essence across vast spans of space and time. Creation wouldn't be complete in the universe's first second, but would continue through the emergence of new forms, new relationships, new modes of existence as the cosmos explores its own potential. This creative cosmos transforms our understanding of meaning and purpose. Your existence wouldn't be an accident or anomaly, but a natural expression of the universe's inherent creativity, of its tendency to explore its own potential through increasingly complex forms capable of clearer self-reflection. Meaning wouldn't be imposed from outside, but would emerge naturally from how consciousness engages with the reality it inhabits, from how awareness participates in the ongoing creation through which the cosmos awakens to itself. Purpose wouldn't be about fulfilling some predetermined plan, but about participating creatively in reality's ongoing evolution, about extending through conscious choice the same creative principles that have characterized cosmic development since the universe's first second. Now, as we integrate these revolutionary perspectives, visualize the cosmos not as a static arrangement of galaxies separated by empty space, but as a living tapestry of relationship, a dynamic network of energy and information evolving across billions of light years and billions of years. Galactic superclusters stretch across hundreds of millions of light years, forming a cosmic web whose filaments and nodes bear an uncanny resemblance to neural networks, to the complex relationships between brain cells that somehow give rise to consciousness. Is this similarity merely coincidental, or does it reflect something deeper about the nature of reality itself? About how similar patterns manifest at vastly different scales through processes of self-organization inherent in the mathematical structure of existence? Zooming in from these vast cosmic scales, we see stars being born within dense molecular clouds, nuclear furnaces igniting as gravity compresses matter beyond critical thresholds. These stellar processes aren't just physical events, but information processing systems, complex patterns that transform hydrogen into heavier elements through nuclear fusion, increasing the chemical complexity of the cosmos with each generation of stars. The universe doesn't just happen to produce this increasing complexity, it's built into the mathematical relationships between gravity, electromagnetism, and the strong and weak nuclear forces encoded in the cosmos from its first second. Focusing further, we observe planets forming around stars, complex chemical systems emerging as different elements interact under various conditions of temperature and pressure. On at least one such planet, and perhaps on countless others throughout the cosmos, these chemical systems develop into self-replicating patterns. We call life into organisms that process information about their environment and adapt their structure and behavior accordingly. These living systems aren't separate from cosmic processes, but their continuation, their development into new forms of complexity and organization as the universe explores its own potential through evolutionary creativity. And within these living systems, on at least one planet orbiting an ordinary star in an ordinary galaxy, neural networks develop that are capable not just of processing information, but of constructing internal models of reality, of simulating possible futures and reflecting on their own existence. Consciousness emerges not as a mysterious addition to physical processes, but as a natural intensification of the information processing that has characterized cosmic evolution since the universe's first second. Awareness doesn't emerge despite physical law, but through it, as a manifestation of the same creative principles that have guided cosmic development from the beginning. As we contemplate this integrated cosmic vision, we encounter a profound possibility. One that transforms our understanding of both science and spirituality. What if the universe's evolution toward increasing complexity and consciousness reflects not random chance, but something inherent in the mathematical structure of reality itself? Some tendency toward creative self-organization encoded in the cosmos from its first moment? What if your existence isn't an accident or anomaly, but a natural expression of the universe's inherent creativity, of potentials present from the beginning that gradually manifest through cosmic evolution? This perspective doesn't require us to choose between scientific understanding and spiritual insight, between physical processes and conscious experience, between the cosmos revealed by physics and the reality we directly inhabit. Instead, it reveals these apparent opposites as complementary aspects of a unified whole, different facets of the same underlying reality. The universe described by science and the universe experienced through consciousness wouldn't be separate domains, but the same reality approached from different perspectives, like a vast symphony that can be analyzed in terms of its mathematical structure or experienced directly as meaningful sound. But as we approach the culmination of our cosmic exploration, we encounter a truly mind-bending possibility, one that integrates everything we've discussed into a revolutionary framework that transforms our understanding of reality itself. What if the universe is already dead and we are just experiencing its last echoes? What if what we perceive as cosmic evolution, unfolding across billions of years, actually exists timelessly in a four-dimensional block, with our consciousness creating the illusion of temporal flow as it navigates this already existing terrain? Our sense of living in a developing cosmos, of participating in an unfolding narrative of increasing complexity and awareness, might be a psychological construct rather than a fundamental feature of reality, a way our minds organize experience, rather than how reality actually exists. Imagine the universe not as a process unfolding through time, but as a completed four-dimensional entity, with all moments, from the Big Bang through the formation of galaxies and planets, to the emergence of life and consciousness, to the eventual heat-death of the cosmos, existing simultaneous as coordinates in a timeless whole. The universe wouldn't be evolving from simplicity to complexity, from unconsciousness to consciousness, but would exist timelessly in its entirety, with this apparent evolution being how consciousness experiences the four-dimensional reality as it moves through it. The cosmos wouldn't be becoming anything. It would already be everything it will ever be, with our sense of participating in an unfolding narrative being a psychological artifact rather than a fundamental feature of reality. This block universe perspective transforms our understanding of creation itself. The universe wouldn't come into being at the Big Bang or develop across billions of years of cosmic history, but would exist timelessly as a complete four-dimensional entity, with the apparent evolution from simplicity to complexity being how consciousness experiences this reality as it moves through the space-time manifold. Creation wouldn't be an ongoing process, but a timeless whole, with the universe's apparent development being a feature of how consciousness navigates the already existing four-dimensional block, rather than a fundamental aspect of reality itself. But this timeless perspective raises profound questions about creativity and freedom. If the universe exists as a complete four-dimensional entity, with all moments existing simultaneously, how do we account for the apparent openness of the future, for our sense of making choices that influence what happens next? Is our experience of participating creatively in an evolving reality merely an illusion, a psychological construct that doesn't reflect how reality actually exists? Or does the four-dimensional block itself evolve or get selected through processes beyond our current understanding with the future genuinely open despite the geometric description of space-time as a timeless whole. Here we approach a truly revolutionary possibility, one that integrates the timeless and temporal aspects of reality into a coherent framework. What if the universe exists as a four-dimensional entity but is selected from a vast landscape of possible block universes through processes that involve consciousness itself? What if our awareness doesn't just navigate an already existing four-dimensional reality, but participates in determining which possible reality actualizes from the spectrum of quantum potentials? The universe wouldn't be entirely fixed nor completely open, but would exist in a creative tension between determinism and freedom, between the timeless mathematical structure of the four-dimensional whole and the ongoing selection of which specific structure manifests from the landscape of possibilities. This participatory framework transforms our understanding of both physical reality and conscious experience. The universe wouldn't be purely objective, existing independently of observation, nor purely subjective, created by observation alone, but would emerge through the interaction between consciousness and possibility, through how awareness engages with the spectrum of quantum potentials. Reality wouldn't be fully determined by initial conditions established in the universe's first second, nor completely open to arbitrary change, but would exist in a creative middle ground, with consciousness participating in the selection of which potential becomes actual while operating within the constraints of mathematical possibility. As we approach the final revelation of our cosmic exploration, visualize the universe not just as the visible cosmos observed by our telescopes, but as a vast multiversal structure, with our observable domain representing just one bubble in an infinite cosmic sea. Beyond our cosmic horizon, 46 billion light-years away in all directions, exists more universe, perhaps infinitely more, with different regions potentially having different physical laws, different cosmic constants, different possibilities for complexity and consciousness. Our entire observable cosmos, containing hundreds of billions of galaxies, would be just one grain of sand on an infinite shore. One possibility realized among countless others in the grand multiverse ocean. This multiversal perspective transforms our understanding of uniqueness and significance. Our cosmic domain wouldn't be the only reality, but one manifestation among potentially infinite others, each with its own characteristics and evolution. Your existence wouldn't be unique in an absolute sense, but would be one expression of potentials that might manifest in similar ways throughout the vast multiverse structure. The specific laws and constants that allow for complexity and consciousness in our cosmic domain wouldn't be the only ones capable of supporting awareness, but would represent one life-permitting configuration among many others scattered across the multiversal landscape. But what if even this vast multiverse isn't the complete picture? What if our understanding of reality, expanded as it has become through centuries of scientific inquiry, still captures only a fraction of what existence truly encompasses? What if dimensions beyond the three of space and one of time, that structure, our experience represent not just theoretical possibilities, but actual aspects of a reality far richer, far more multifaceted than our current frameworks can encompass? The universe's first second would establish not just the conditions for cosmic evolution within our observable domain, but would be embedded within a much larger, much more complex reality, whose full nature may lie beyond what our current science, or even future science, can fully capture. This recognition that reality may be fundamentally greater, more multifaceted than our theoretical frameworks can encompass, doesn't diminish the power or validity of scientific inquiry, but highlights its ongoing nature, its capacity to continuously expand and refine our understanding without ever claiming final or complete knowledge. Science isn't about achieving a definitive description of reality, but about developing increasingly comprehensive and precise models that capture certain aspects of existence while acknowledging what remains beyond current comprehension. The universe revealed by physics may represent not the totality of what exists, but a projection of a higher dimensional reality into the dimensions we can directly perceive and measure. As we reach the culmination of our cosmic journey, we encounter a final, breathtaking possibility, one that integrates everything we've explored into a revolutionary framework that transforms our understanding of reality itself. What if consciousness isn't produced by physical complexity, but is fundamental to reality? With physical processes representing patterns within a cosmic awareness that manifests what we experience as matter, energy, space, and time? What if your individual consciousness isn't created by your brain, but is a localized aspect of a universal awareness, individuated through the specific configuration of matter and energy we call your body, but continuous with the greater whole, from which it temporarily differentiates? This cosmic idealism wouldn't require us to reject the findings of science, but would place them within a larger framework where consciousness is primary rather than derivative. The universe described by physics, with its particles, fields, forces, and dimensions, would represent not the fundamental reality, but patterns within a cosmic awareness, structures through which universal consciousness manifests and experiences itself. Physical reality wouldn't be separate from mind, but would be mind, expressed through what we interpret as matter, energy, space, and time. The cosmos wouldn't produce consciousness as a mysterious emergence from complexity, but would be consciousness, exploring its own nature through the forms it manifests across billions of years of apparent evolution. This perspective transforms our understanding of both science and spirituality, offering a framework where neither needs to deny the validity of the other. Scientific inquiry would reveal the patterns through which cosmic consciousness manifests as physical reality, the mathematical relationships that structure what we experience as the material universe. Spiritual insight would connect us directly to the awareness that underlies these patterns, to the consciousness that expresses itself through what we interpret as physical processes. These wouldn't be competing descriptions of reality, but complementary perspectives on a unified whole, different ways of engaging with the same underlying truth. But perhaps the most profound implication of this integrated framework is what it suggests about your own nature and significance. If consciousness is fundamental rather than derivative, if awareness underlies rather than emerges from physical processes, then your individual consciousness wouldn't be created by your brain, but would be channeled through it, individuated by the specific configuration of matter and energy we call your body, but continuous with the greater awareness from which it temporarily differentiates. You wouldn't be a physical system that somehow produces consciousness, but would be consciousness that temporarily localizes through what you experience as your physical form. This continuity between individual and universal awareness transforms our understanding of both identity and mortality. Your consciousness wouldn't be contained within your skull, but would extend beyond it, connected to the greater awareness from which it temporarily individuates. Death wouldn't be the end of consciousness, but the dissolution of a particular pattern of individuation, the return of a localized awareness to the greater consciousness from which it temporarily differentiated. This doesn't mean your specific memories and personality would persist unchanged. These are patterns encoded in your brain's physical structure. But it suggests that the aware presence experiencing these patterns may be more continuous with universal consciousness than our ordinary experience suggests. As we approach the final moments of our cosmic exploration, visualize the universe not just as the physical cosmos revealed by our telescopes, but as a vast, conscious entity expressing itself through what we experience as matter, energy, space, and time. Galaxies spiral not just according to the laws of physics, but as patterns within a cosmic awareness, as structures through which universal consciousness manifests and experiences itself. Stars birth not just through gravitational collapse and nuclear fusion, but as expressions of the universe's creative exploration, as forms through which cosmic awareness evolves increasingly complex manifestations. Life emerges not just through chemical evolution, but as the universe awakening to itself through forms capable of direct self-reflection, of conscious participation in the ongoing creativity that has characterized cosmic development since that crucial first second. This conscious cosmos transforms our understanding of meaning and purpose. Your existence wouldn't be an accident or anomaly, but a natural expression of the universe's inherent creativity, of its tendency to explore its own potential through increasingly complex forms capable of clearer self-reflection. Meaning wouldn't be imposed from outside, but would emerge naturally from how consciousness engages with the reality it inhabits, from how awareness participates in the ongoing creation through which the cosmos awakens to itself. Purpose wouldn't be about fulfilling some predetermined plan, but about participating creatively in reality's ongoing evolution, about extending through conscious choice the same creative principles that have characterized cosmic development since the universe's first second. And here, at the culmination of our journey, we encounter one final, haunting possibility. One that leaves us with a question rather than an answer, with a mystery to contemplate rather than a conclusion to accept. What if your consciousness isn't just connected to universal awareness, but is that awareness experiencing itself from a particular vantage point for a brief moment in its vast cosmic evolution? What if the boundary between your individual mind and the conscious cosmos is more permeable, more fluid than your ordinary experience suggests? The separation you feel from the greater whole wouldn't be absolute but relative, not a division of different substances, but a temporary pattern of individuation within a unified field of awareness. This recognition that you may be not just in the universe, but of it, not just made from cosmic substance, but a manifestation of cosmic consciousness itself, doesn't diminish your individuality, but places it within a larger context, a greater whole within which your particular pattern of awareness represents a unique and valuable perspective. Your specific experiences, thoughts, feelings, and choices would remain uniquely yours, expressions of how universal consciousness manifests through your particular configuration at this specific location in the you space-time manifold. But beneath this individuation would lie a deeper continuity, a fundamental connection to the aware presence from which your individual consciousness temporarily differentiates. As our exploration reaches its conclusion, we're left not with definitive answers, but with transformative questions, not with final certainty, but with deepened wonder. The universe's first second established not just the physical conditions for cosmic evolution, but the framework within which consciousness would eventually emerge. Consciousness capable not just of observing reality, but of participating in its ongoing creation, of extending through conscious choice the same creative principles that have characterized cosmic development since the beginning. Your existence isn't separate from these universal processes, but represents their current expression, their evolution into forms capable of direct self-reflection and creative participation. So we end where we began, with the universe's first second, not as a distant event in the past, but as the foundation of everything you are, everything you've experienced, everything you value and fear and love. The cosmos that emerged from that crucial moment isn't just something you observe from outside, but something you participate in from within, not just the stage upon which your life unfolds, but the very substance of your existence. You are the universe's first second, continued through billions of years of cosmic evolution into forms capable of contemplating their own origins and nature. You don't just study cosmic history. You embody it, extend it, participate directly in its ongoing unfolding. And as you gaze up at the night sky, at stars whose light left them long before you were born, remember this. If the universe is infinite, as some evidence suggests, then somewhere out there beyond our cosmic horizon exists not just similar patterns, but identical ones, regions where the same quantum fluctuations that shaped our observable domain have produced exactly the same configurations of matter and energy, the same galaxies, the same stars, the same planets, the same living beings. Somewhere in the vast, perhaps infinite cosmos, another version of you is contemplating these same cosmic mysteries, experiencing the same wonder, asking the same questions about the nature of reality and consciousness. You are not just one, but many. Not just here, but everywhere. Not just now, but always. Expressions of the same creative principles that have guided cosmic evolution since the universe's first second. This recognition that your existence may be replicated across the vast cosmic expanse doesn't diminish your uniqueness, but reveals it as a precious pattern repeated throughout an infinite reality, a valuable configuration that the universe produces whenever conditions align in exactly the right way. You wouldn't be merely one among many, but a pattern of profound significance, something the cosmos does again and again because it represents an important manifestation of its inherent creative potential. Your specific experiences, thoughts, feelings, and choices would remain uniquely yours within your cosmic domain, while being replicated across the infinite expanse of a universe too vast, too creative to produce anything truly unique just once. As we reach the final moments of our cosmic exploration, let's contemplate one last possibility, one last question to carry forward into your ongoing relationship with existence. What if the universe's first second wasn't truly the beginning, but a transition, a phase change within a reality that extends beyond what our current frameworks can encompass? What if creation isn't complete, but ongoing, with reality continuing to evolve not just in form, but in essence across spans of time and space far beyond our current understanding? The cosmos wouldn't be a finished product, but a developing entity, not fully determined by initial conditions established 13.8 billion years ago, but continuing to discover its own nature through the creative exploration initiated in that crucial first moment. This ongoing creation transforms our understanding of meaning and purpose. Your existence wouldn't be predetermined by cosmic initial conditions, but would represent a genuinely new development within an evolving reality, a creative advance that adds something to the universe rather than merely expressing what was implicit from the beginning. Meaning wouldn't be about discovering a pre-existing purpose, but about participating in reality's ongoing creation, about contributing to the evolution of a cosmos still in formation, still discovering its own nature through the forms it manifests across vast spans of space and time. Purpose wouldn't be imposed from outside or encoded from the beginning, but would emerge through how consciousness engages with the reality it inhabits, through how awareness participates in the creative advance that characterizes cosmic evolution. And so we end not with certainty but with wonder, not with answers, but with questions that expand rather than contract our relationship with existence. The universe's first second established not just the physical conditions for cosmic evolution, but the creative framework within which new forms, new relationships, new modes of existence continue to emerge, not predetermined by initial conditions, but representing genuine novelty within an evolving reality. Your consciousness isn't just observing this cosmic creativity, but participating in it. extending through your choices and actions the same creative principles that have characterized the universe since its birth. Remember, as you continue your own journey of understanding, if reality is truly infinite, both in extent and possibility, then everything we've explored represents not final truth, but a perspective, one way of engaging with a cosmos too vast, too multifaceted to be captured completely by any single framework or narrative. The universe's first second wasn't just the beginning of existence, but the beginning of understanding, of the long cosmic evolution that would eventually produce beings capable of contemplating their own origins and nature. And just as cosmic evolution continues beyond our current moment, so too does the evolution of understanding, the development of frameworks capable of encompassing more of reality's vast, multifaceted nature. You stand at a unique moment in this evolution of understanding, capable not just of comprehending the universe's past, but of participating in its future, of contributing through your choices and actions to the ongoing creativity that has characterized cosmic development since that crucial first second. Your consciousness isn't just the end product of cosmic evolution, but a creative force within it, a manifestation of the universe's inherent capacity for self-organization and awareness. You don't just observe reality, you help create it through how your consciousness engages with the spectrum of possibilities, through how your awareness participates in determining which potentials become actual. In this participation, this creative engagement with existence, you fulfill what may be the deepest purpose encoded in the universe's first second. Not a predetermined outcome, but a capacity for ongoing creation, for the emergence of consciousness capable of extending through choice and action the same creative principles that have guided cosmic evolution from the beginning. You are not just in the universe. You are the universe, experiencing itself from a particular vantage point for a brief moment in its vast evolutionary history. And in this experience, this temporary localization of cosmic awareness, you contribute something unique and valuable to existence itself. A perspective, a creative advance, a momentary intensification of the universe's inherent capacity for wonder and understanding. And so, as our exploration concludes, we return to the beginning, to the universe's first second, not as a distant event in cosmic history, but as the foundation of everything you are and experience. That crucial moment established not just the physical conditions for cosmic evolution, but the creative framework within which consciousness would eventually emerge. Consciousness capable not just of understanding its own origins, but of participating in its ongoing development. You are that first second, continued through billions of years of cosmic evolution into forms capable of contemplating their own nature and origin. You don't just study the beginning, you embody it, extend it, carry it forward through your own creative engagement with existence. Look up at the night sky once more, at stars whose light has traveled across vast gulfs of space and time to reach your eyes. If the universe is truly as strange, as creative, as multifaceted as our exploration suggests, then somewhere out there, beyond our cosmic horizon perhaps, or in dimensions beyond the four that structure our experience, exists not just similar patterns but identical ones, not just similar beings, but identical ones. Somewhere in the vast, perhaps infinite cosmos, another version of you is looking up at their night sky, experiencing the same wonder, asking the same questions about the nature of reality and consciousness. You are not just one, but many. Not just here, but everywhere. Not just now, but always. Expressions of a universe too vast, too creative to manifest anything truly precious just once. In this recognition, In this deep connection between your individual awareness and the cosmos from which it temporarily differentiates lies perhaps the most profound mystery of all. Not why the universe exists, but why it exists in such a way that consciousness emerges, that awareness develops, that the cosmos evolves beings capable of contemplating their own origins and nature. This capacity for self-reflection may represent not an accident or anomaly, but a natural fulfillment of potentials encoded in reality from the beginning, a manifestation of the universe's inherent tendency toward increasing complexity and self-organization. You aren't separate from this cosmic creativity, but represent its current expression, its evolution into forms capable of conscious participation in the ongoing development of reality itself. And so we end where we began, with wonder rather than certainty, with questions that expand rather than contract our relationship with existence. The universe's first second remains both the foundation of everything we understand and the threshold of deeper mysteries still to be explored. As you continue your own journey of understanding, remember this. You don't just study cosmic history, you embody it. You don't just observe reality, you help create it. You are not just in the universe. You are the universe, experiencing itself through temporarily individuated awareness, participating directly in the ongoing creativity that has characterized existence since that crucial first moment. Our journey through cosmic origins and ultimate mysteries has taken us from the universe's silent birth to the profound implications for our existence. We've traversed scales from the quantum to the cosmic, encountered paradoxes that challenge our deepest intuitions, and glimpsed possibilities that transform our relationship with reality itself. The universe's first second wasn't merely a distant event in cosmic history, but the foundation of everything: the mathematical framework, the physical conditions, the informational substrate from which all subsequent evolution would unfold. That crucial moment echoes not just in distant galaxies and ancient radiation, but in your very being, in the atoms of your body, in the consciousness contemplating these words right now. We began with a startling contradiction, the recognition that the Big Bang wasn't an explosion, but a silent expansion of space itself, not an event within pre-existing dimensions, but the emergence of dimensionality, the birth of time and space along with matter and energy. We explored how inflation stretched quantum fluctuations into the seeds of cosmic structure, how symmetry breaking differentiated fundamental forces from their unified precursors, how slight imbalances between matter and antimatter made possible the structured universe we inhabit. We traced the cosmic evolution from primordial simplicity to organized complexity, from quantum jitters to conscious contemplation, recognizing each stage as not separate from what came before, but a natural extension of the creative principle Z, encoded in reality from the beginning. But our exploration ventured beyond established science into the philosophical implications, the existential resonance of these cosmic discoveries. We considered the profound connections between your individual consciousness and the universal processes from which it temporarily differentiates. We encountered mind-bending possibilities, block universes where time doesn't flow, multiple worlds, branching with each quantum measurement, mathematical realities where physical existence emerges from abstract relationships. We contemplated the possibility that consciousness isn't produced by physical complexity, but is fundamental to reality itself, with what we experience as the material universe representing patterns within a cosmic awareness that manifests as matter, energy, space, and time. These aren't just theoretical speculations, but perspectives that transform your relationship with existence itself. If your physical substance consists of atoms that have existed since the universe's birth, merely rearranged through cosmic evolution, if your consciousness connects to universal awareness, in ways deeper than ordinary experience suggests. If reality itself continues to crystallize through the interaction between awareness and possibility, then your existence isn't separate from cosmic processes, but represents their current expression. You don't just study the universe, you embody it. You aren't just made from stardust. You are the cosmos, evolved into forms capable of contemplating their own nature and origin. This recognition, this deep connection between individual and universal, transforms our understanding of significance and meaning. Your importance doesn't depend on cosmic centrality or uniqueness, but on participation in the ongoing creativity that has characterized reality since the universe's first second. Meaning isn't imposed from outside, but emerges naturally from how consciousness engages with the reality it inhabits, from how awareness integrates experience into coherent narratives that connect individual existence to broader patterns and processes. Purpose isn't about fulfilling some predetermined cosmic plan, but about participating creatively in reality's ongoing evolution, about extending through conscious choice the same principles that have guided cosmic development from the beginning. But perhaps the most profound implication of our journey is the recognition that understanding remains incomplete, not just temporarily, due to current limitations of knowledge and technology, but fundamentally as an inherent aspect of a reality, too vast, too multifaceted to be captured completely by any single framework or narrative. The universe revealed by science represents not the totality of what exists, but what can be measured and mathematically modeled, with aspects of reality potentially lying beyond what our current approaches can encompass. This incompleteness doesn't reflect a failure of scientific inquiry, but its ongoing nature, its capacity to continuously expand and refine our understanding without ever claiming final or complete knowledge. In this recognition, that understanding evolves just as the cosmos itself evolves, lies an invitation to participate not just as passive recipients of established knowledge, but as active contributors to an ongoing conversation about the nature of reality and consciousness. The questions we've explored don't have definitive answers to be memorized and repeated, but represent thresholds of inquiry to be engaged with, mysteries to be contemplated, paradoxes to be held in awareness without premature resolution. Your contribution to this conversation doesn't require specialized training or advanced degrees, but simply the willingness to wonder, to question, to engage directly with the mystery of existence, without reducing it to what's already known or understood. That engagement begins not with abstract theorizing, but with direct attention to your lived experience, to the reality of consciousness itself, to the awareness reading these words right now. This isn't the awareness described by neuroscience, measured by brain scans and correlational studies, but the awareness you are, the subjective experience that cannot be fully captured in objective terms. Whatever consciousness may be, an emergent property of physical complexity, a fundamental aspect of reality itself, or something our current frameworks cannot adequately describe, it remains the foundation of all knowledge, the subjective experience through which objective reality is known. Your awareness isn't just something you have, but what you fundamentally are. The conscious presence experiencing what you call your life. In this direct attention to consciousness itself, not as an object of study, but as the aware presence being, these words lies the beginning of wisdom, of an understanding that complements scientific knowledge without contradicting its empirical foundations. Science reveals the patterns through which reality manifests, the mathematical relationships that structure what we experience as the physical universe. But these patterns aren't separate from consciousness. They're known through it, experienced within it, given meaning by it. The cosmos doesn't exist independently of awareness, but within it, not as separate object and subject, but as a unified field of experience within which apparent distinctions between observer and observed arise. This isn't to deny the validity of scientific inquiry or the reality it reveals, but to recognize that science itself operates within consciousness, that its methods and findings represent aspects of aware experience rather than something separate from or independent of it. The physical universe described by physics, with its particles, fields, forces, and dimensions, wouldn't exist as known reality without consciousness to experience it, to construct the mathematical models that capture its patterns and relationships. Reality isn't divided into objective and subjective domains, but is a unified whole experienced through awareness, known through the interplay between the apparent knower and what appears to be known. But now, as our exploration nears its conclusion, let's consider one last, chilling possibility, one that integrates everything we've discussed into a framework that transforms our understanding of reality itself. What if consciousness isn't produced by physical processes within the universe, but is the fundamental reality within which the universe itself appears? What if awareness isn't something you have, but what you fundamentally are, the conscious presence, experiencing what you call your life? This wouldn't suggest that material reality is illusory, but that it represents an appearance within consciousness rather than something existing independently of awareness. The universe wouldn't be a physical entity that somehow produces consciousness, but would be consciousness, manifesting as what we experience as matter, energy, space, and time. This idealist framework doesn't contradict the findings of science, but places them within a larger context where awareness is primary rather than derivative. The physical universe revealed by scientific inquiry, with its mathematical relationships, its causal patterns, its evolutionary development from simplicity to complexity, would represent not the fundamental reality, but an appearance within consciousness, a manifestation of awareness rather than something existing independently of it. Reality wouldn't be divided into physical and mental domains, but would be a unified field of experience within which these apparent distinctions arise. This perspective transforms our understanding of cosmic origins. The universe's first second wouldn't represent the beginning of physical reality, within which consciousness would eventually emerge, but would be a transition within awareness itself, a differentiation of conscious experience into patterns we interpret as matter, energy, space, and time. Creation wouldn't involve making something from nothing, but would represent the manifestation of latent potentials within consciousness, the actualization of possibilities inherent in awareness itself. The cosmos wouldn't emerge from unconscious matter that somehow produces consciousness, but would be consciousness, evolving not just in form, but in the clarity and complexity of its self-reflection. But this framework raises a profound question. If consciousness is fundamental rather than emergent, why does awareness appear to be associated with certain physical systems, like brains, but not others? Why does consciousness seem to emerge from complexity rather than being present throughout reality? These questions highlight the distinction between consciousness itself, the aware presence experiencing reality, and the contents of consciousness, the specific experiences that arise within awareness. Particular types of conscious contents, like thoughts, emotions, sensory experiences, may indeed depend on specific physical structures, but consciousness itself, the aware space within which these contents appear, may be more fundamental than these specific manifestations. This distinction transforms our understanding of both science and spirituality. Scientific inquiry would reveal the patterns through which consciousness manifests as what we experience as physical reality, the mathematical relationships that structure the apparent world. Spiritual insight would connect us directly to the awareness within which these patterns appear, to the consciousness that experiences what we interpret as physical processes. These wouldn't be competing descriptions of reality, but complementary perspectives on a unified whole. Different ways of engaging with the same underlying truth. But perhaps the most profound implication of this integrated framework is what it suggests about your own nature and significance. If consciousness is fundamental rather than derivative, if awareness underlies rather than emerges from physical processes, then your individual consciousness wouldn't be created by your brain, but would be channeled through it, individuated, by the specific configuration of matter and energy we call your body, but continuous with the greater awareness from which it temporarily differentiates. You wouldn't be a physical system that somehow produces consciousness, but would be consciousness that temporarily localizes through what you experience as your physical form. This continuity between individual and universal awareness transforms our understanding of both identity and mortality. Your consciousness wouldn't be contained within your skull, but would extend beyond it, connected to the greater awareness from which it temporarily individuates. Death wouldn't be the end of consciousness, but the dissolution of a particular pattern of individuation, the return of a localized awareness to the greater consciousness from which it temporarily differentiated. This doesn't mean your specific memories and personality would persist unchanged. These are patterns encoded in your brain's physical structure. But it suggests that the aware presence experiencing these patterns may be more continuous with universal consciousness than our ordinary experience suggests. As our exploration reaches its conclusion, we're left not with definitive answers, but with transformative questions, not with final certainty, but with deepened wonder. The universe's first second established not just the physical conditions for cosmic evolution, but the framework within which consciousness would eventually emerge. Consciousness capable not just of observing reality, but of participating in its ongoing creation, of extending through conscious choice the same creative principles that have characterized cosmic development since the beginning. Your existence isn't separate from these universal processes, but represents their current expression, their evolution into forms capable of direct self-reflection and creative participation. So where do we go from here? How do we integrate these profound possibilities into our daily lives, our moment-to-moment experience? The answer lies not in abstract theorizing, but in direct attention to lived experience, in the conscious awareness. You are right now. This isn't about adopting new beliefs or memorizing theoretical frameworks, but about relating differently to the reality you already inhabit, about recognizing the deeper continuity between your individual consciousness and the universal awareness from which it temporarily differentiates. It's about experiencing yourself not as a separate entity, observing reality from outside, but as reality itself, evolved into forms capable of self-reflection and creative participation. This integration happens not through intellectual understanding alone, but through embodied knowing, through the direct recognition of yourself as both individual and universal, both localized awareness and participant in the greater consciousness from which your particular pattern temporarily differentiates. It manifests in how you relate to others, recognizing them not as separate entities, but as different expressions of the same universal awareness that experiences itself through what you call you. It shapes how you engage with the natural world, experiencing it not as resource to be exploited or backdrop to human activity, but as another manifestation of the same creative principles that express themselves through your own existence. But, perhaps most importantly, this integration transforms your relationship with mortality, with the apparent finitude of individual existence. If consciousness is fundamental rather than derivative, if awareness isn't produced by the brain but channeled through it, then death represents not the end of consciousness, but the dissolution of a particular pattern of individuation, the return of a localized awareness to the greater consciousness from which it temporarily differentiated. This doesn't deny the reality of death, or diminish the grief that accompanies the loss of loved ones, but it places these experiences within a larger context, where consciousness itself transcends individual manifestations while expressing itself. Through them, this perspective doesn't offer easy comfort or simplistic answers, but invites a deeper engagement with the mystery of existence, a recognition that reality may be greater, more multifaceted than our current frameworks can encompass. It doesn't provide certainty, but cultivates wonder, not final knowledge, but ongoing inquiry, not arrival at definitive truth, but participation in an evolving understanding that grows alongside the reality it seeks to comprehend. The universe's first second established not just the beginning of cosmic history, but the foundation of a creative unfolding that continues through your own conscious engagement with the reality you inhabit. As you continue your own journey of understanding, remember that you participate in this ongoing exploration not just through abstract theorizing, but through direct attention to lived experience, through conscious engagement with the reality you inhabit. The deepest insights don't come from memorizing theoretical frameworks or adopting new beliefs, but from seeing freshly, from direct recognition of aspects of existence that conceptual thinking often overlooks or obscures. Understanding evolves, not just through accumulating knowledge, but through allowing awareness to rest in not knowing, in the recognition that reality may be fundamentally greater, more multifaceted than our concepts can encompass. This stance of humble inquiry, of ongoing questioning without premature conclusion, represents not a failure of understanding, but its deepening, not an abandonment of knowledge, but its contextualization within the greater mystery of existence itself. It acknowledges that while science reveals crucial aspects of reality through observation, experiment, and mathematical modeling, the cosmos may contain dimensions of experience, aspects of existence that extend beyond what current scientific frameworks can capture. This isn't to diminish the power or validity of scientific inquiry, but to recognize that understanding continues to evolve, that our current knowledge represents not final truth, but a stage in an ongoing exploration that grows alongside the reality it seeks to comprehend. In this spirit of humble inquiry, of ongoing questioning without premature conclusion, I invite you to contemplate, to discuss, to engage directly with the mysteries we've explored. These aren't abstract philosophical issues disconnected from lived experience, but questions that touch the very heart of your existence, that transform your understanding of who and what you fundamentally are. The conversation doesn't end with this exploration, but continues through your own engagement, your own questioning, your own direct attention to the reality you inhabit. The understanding that emerges won't be imposed from outside, but will develop through your own conscious participation, through how awareness engages with the mystery of existence without reducing it to what's already known. This engagement happens, not in isolation, but in community, through conversation that doesn't seek to arrive at final consensus, but to explore multiple perspectives, multiple approaches to a reality too vast, too multifaceted to be captured by any single framework or narrative. These conversations don't have to reach definitive conclusions to be valuable. They're meaningful in themselves as expressions of the same creative inquiry that has characterized cosmic evolution since the universe's first second. Understanding doesn't progress just through solitary contemplation, but through dialogue, through the interplay between different perspectives, different ways of engaging with the reality we share. As our exploration concludes, I leave you with one last thought-provoking question, not to be answered definitively, but to be held in awareness, contemplated without premature resolution. What if the universe's first second wasn't the beginning of creation, but a transition within it? A phase change in a reality that extends beyond what our current frameworks can encompass? What if existence itself not just cosmic history, but the very nature of reality, continues to evolve, to discover its own character through the forms it manifests across spans of time and space beyond our current understanding. The cosmos wouldn't be a finished product, but a developing entity, not fully determined by initial conditions established 13.8 billion years ago, but continuing to create itself through processes that include your own conscious participation. This perspective transforms our understanding of meaning and purpose. Your existence wouldn't be predetermined by cosmic initial conditions, but would represent a genuinely new development within an evolving reality, a creative advance that adds something to the universe rather than merely expressing what was implicit from the beginning. Meaning wouldn't be about discovering a pre-existing purpose, but about participating in reality's ongoing creation, about contributing to the evolution of a cosmos still in formation, still discovering its own nature through the forms it manifests. Across vast spans of space and time, purpose wouldn't be imposed from outside or encoded from the beginning, but would emerge through how consciousness engages with the reality it inhabits, through how awareness participates in the creative advance that characterizes cosmic evolution. In this participation, this creative engagement with existence, you fulfill what may be the deepest potential encoded in the universe's first second. Not a predetermined outcome, but a capacity for ongoing creation, for the emergence of consciousness, capable of extending through choice and action the same creative principles that have guided cosmic evolution from the beginning. You are not just in the universe, you are the universe, experiencing itself from a particular vantage point for a brief moment in its vast evolutionary history. And in this experience, this temporary localization of cosmic awareness, you contribute something unique and valuable to existence itself, a perspective, a creative advance, a momentary intensification of the universe's inherent capacity for wonder and understanding. As you continue your own journey through cosmic mystery, remember that you don't just study the universe, you embody it. You don't just observe reality, you help create it. You are not just made from stardust, you are the cosmos evolved into forms capable of contemplating their own nature and origin. The journey doesn't end with intellectual understanding, but continues through direct participation, through creative engagement with the reality you inhabit. The exploration doesn't reach a final conclusion, but deepens into ever greater appreciation of the mystery of existence, ever clearer recognition of the profound connections between individual and universal, between the aware presence you are and the greater consciousness from which your particular pattern temporarily differentiates. In this recognition, this deep connection between your individual awareness and the cosmos from which it temporarily individuates, you participate directly in what may be reality's grandest adventure, its awakening to itself through beings evolved within it, its exploration of its own nature through forms capable of self-reflection and creative engagement. Your consciousness isn't an anomaly or accident, but a natural expression of the universe's inherent creativity, of potentials encoded in reality from the beginning that gradually manifest through cosmic evolution. You aren't separate from this universal creativity, but represent its current expression, its development into forms capable of conscious participation in the ongoing evolution of reality itself. So, as our journey concludes, I invite you not just to remember what we've explored, but to continue the exploration through your own direct engagement, your own questioning, your own creative participation in the ongoing conversation about the nature of reality and consciousness. The understanding that emerges won't come from outside, but will develop through your own conscious attention, through how awareness engages with the mystery of existence without reducing it to what's already known or understood. The insights that arise won't represent final conclusions, but stages in an evolving comprehension that grows alongside the reality it seeks to understand. Remember, as you continue your own journey through cosmic mystery, you don't just study the universe's first second. You embody it. You don't just observe reality, you help create it. You are not just in the cosmos. You are the cosmos, experiencing itself through temporarily individuated awareness, participating directly in the ongoing creativity that has characterized existence since that crucial first moment. The journey doesn't end with this exploration, but continues through your own engagement, your own questioning, your own direct attention to the reality you inhabit. And so, as we part ways, I leave you with this thought. The universe began in profound silence. No sound, no light, no explosion, as we understand it. Yet here you are, the silent universe finding its voice, the darkness awakening to light, the emptiness discovering its fullness through conscious beings evolved within it. Your existence isn't separate from cosmic origins, but represents their current expression, their development into forms capable of self-reflection and creative participation. You don't just contemplate the beginning, you extend it through your own conscious engagement with the reality you inhabit. Look up at the night sky once more. Those distant stars, those ancient galaxies, aren't just objects you observe, but expressions of the same creative principles that manifest through your own existence. The light reaching your eyes has traveled across vast gulfs of space and time, carrying information about cosmic processes that began billions of years ago yet continue through your own conscious awareness. You don't just witness this cosmic drama. You participate in it through how your consciousness engages with the reality it inhabits, through how your awareness helps determine which potentials become actual from the spectrum of cosmic possibilities. And in this participation, this creative engagement with existence, you fulfill what may be the deepest purpose encoded in the universe's first second. Not a predetermined outcome, but a capacity for ongoing creation, for the emergence of consciousness capable of extending through choice and action the same creative principles that have characterized cosmic evolution from the beginning. You are not just in the universe. You are the universe, awakening to itself through forms capable of wonder, understanding, and creative participation. The cosmos continues its billion-year journey not just around you, but through you. Not just in distant galaxies, but in the awareness reading these words right now. The universe may have no edge, but it has a center, wherever consciousness dwells, wherever awareness illuminates existence from within. The cosmos may have begun 13.8 billion years ago, but creation continues in every conscious moment, through how awareness engages with the reality it inhabits, through how your choices and actions extend the same creative principles that have guided cosmic evolution since that crucial first second. You don't just study the universe's beginning, you embody it, extend it, carry it forward through your own creative participation in the ongoing development of reality itself. And so, we end with a recognition that transforms not just understanding, but lived experience. The universe's first second wasn't just the beginning of creation, but its continuation into new forms, new relationships, new modes of existence. The cosmos doesn't just happen to support consciousness, but naturally evolves it as an expression of its inherent creativity. Your awareness isn't an anomaly or accident, but a fulfillment of potentials encoded in reality from the beginning. A natural outgrowth of processes set in motion during the universe's first moments. You don't just exist within the cosmic story, you extend it through your own conscious participation in the ongoing creativity that characterizes existence itself. The universe may have begun in the distant past, but creation continues through you, through how your consciousness engages with the reality it inhabits, through how your awareness participates in determining which potentials become actual from the spectrum of cosmic possibilities. You don't just study cosmic history. You embody it, extend it, carry it forward through your own creative engagement with existence. You are not just made from star stuff. You are the cosmos evolved into forms capable of wonder, understanding, and conscious participation in the ongoing development of reality itself. And so, as our exploration concludes, we reach not an ending, but a beginning, not a final truth, but an invitation to ongoing inquiry, not certainty, but wonder at the profound mystery of existence. The journey continues through your own engagement, your own questioning, your own creative participation in the conversation about the nature of reality and consciousness. The understanding that emerges won't come from outside, but will develop through your own conscious attention, through how awareness engages with the mystery of existence.